Hello and welcome to this artificial intelligence course by Intellipaat. The world is moving towards super intelligence, and the race to reach it has already begun among the top players. And there is clearly one company leading this revolution at the moment. I'm talking about OpenAI, which has just taken a step forward with the launch of GPT-5. This launch of GPT-5 isn't just another tech update, it's a wake up call. We've officially entered an era where AI is just not another tool, it's a mind that learns, reasons, and creates at a scale we've never seen before. From writing code to designing products, diagnosing diseases to composing music, AI is reshaping every single profession on earth. 5 years from now, the professionals who understand AI will lead, those who don't will follow. And this is why right now is the most important time in history to learn artificial intelligence. In this AI course, you won't go through a theory track. You'll build a rock solid foundation for components like deep learning algorithms such as ANN, CNN, RNN, and transformers that lay the foundation for these groundbreaking AI models. You will intuitively understand how AI learns, the foundational algorithms behind it, and how you can harness the power of these algorithms to start building the generative AI. We'll go from the exact skill set companies are desperate to hire for to make you industry ready. By the end, you won't just be aware of AI, you will be ready to use it, build with it, and stay ahead of it. So, if you're ready to future proof your career in the age of super intelligence, let's get started.
Okay, so before we even talk about neural network, we need to talk about their most basic building block, which is the perceptron. Now, what is a perceptron? In simple words, mini brain cell, a small unit that makes simple decision, or we can say a single artificial neuron. In our brain, neuron receives signal from other neurons, and based on the strength of those signals, they either fire, which is they send their own signal forward, or stay quiet. A perceptron works in almost the same way, but with numbers instead of biological signal. Here's what happens step by step. The very first step is the input. The perceptron takes in set of values. This could be anything. Numbers from a spreadsheet, pixel value from an image, or measurements from sensors. Let's call them x1, x2, x3 and so on. Second is weight. Each input is multiplied by a number called a weight. This weight decides how important the particular input is. Imagine your brain is trying to decide, should I take an umbrella today? You have many possible pieces of information which is inputs you will consider. So is it raining right now? This is very important for your decision. So it gets high weight, maybe 0.9 or 1.0. What day of the week it is? This probably has nothing to do with whether you need an umbrella today. So it gets a low weight, for example, close to 0. So in neural network, each input has a weight, a number that says how important is this input for the final decision. If an input is important, it gets multiplied by a big number which is high weight. If it's irrelevant, it gets multiplied by a small number which is nearly equal to 0. So it hardly affects the output. Then third is bias. This is like an extra push or offset added to the total. It allows the perceptron to make better decision even if all the inputs are small. You can think of bias as your default tendency to say yes or no. Then we have summation. All the weighted inputs are added together along with the bias, which gives you one single number which we call as the net input. Then we have activation function. This is where the decision happens. The simplest one is the step function. If the net input is greater than or equal to a certain threshold, the perceptron outputs a 1, meaning yes, activated or belongs to a class. If it is less than the threshold, its output is 0, no, not activated or belongs to other class. Up to this point, the perceptron is just following fixed rule, but here's really exciting part, it can learn. When we train a perceptron, we give it a bunch of examples where we already know the correct answer. For each example, it makes a prediction, it compares that prediction to the actual correct answer and calculates the error. So we can say how far off it was. If it was wrong, it tweaks the weight and bias a little bit to do better next time. This tweaking follows a formula called as perceptron learning rule. There's also a learning rate, a small number between 0 and 1, which decides how big or small each adjustment should be. A small learning rate meaning slower but more careful learning. A large learning rate means faster but riskier changes. Over time, as perceptron sees more example, it keeps adjusting until it can make correct prediction most of the time. But here's an important limitation. A perceptron can only work well if your data can be separated by a straight line. For example, if you plot your data point on a graph and can draw a straight line between two categories, the perceptron can learn that. That's why we call it as a linear binary classifier. linear because of the straight line, and binary because it handles only two categories. If your problem is more complicated, meaning you can't separate the data with just one straight line, you need more than one perceptron. In fact, modern neural networks are just layers and layers of perceptron working together. That's what makes them powerful enough to handle things like image recognition, speech translation, and so on. So even though the perceptron is the simplest kind of neural network, it's the foundation stone. Without it, we wouldn't have the advanced AI models we use today.
Just a quick info, guys. Intellipaat offers artificial intelligence course training, which will enable you to learn skills like neural networks, focusing on CNNs, RNNs, and their application in AI, natural language processing, computer vision, and generative AI. Through this course, you will also master deep learning concepts, AI model building with TensorFlow, transformers, BERT, GPT, LangChain, and NLP pipelines with advanced techniques like image recognition, chatbot development, and much more, all taught by top 1% experts and IIT faculty. And with this course, we have already helped thousands of professionals make successful career transitions in AI and data science. You can check out the testimonials on our Achievers channel. The link is in the description below. And without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take your first step towards the dream career growth in the field of artificial intelligence.
We learned that there are three types of machine learning that every other machine learning cat into: super, unsupervised learning, and reinforcement. Now, guys, if you observe carefully, right, if you look at couple of, there are multiple different techniques of solving a problem in machine learning. Since we are on the topic of machine learning, it's very important that we get some understanding very clear. If the understanding with respect to machine learning isn't clear, we will not be able to jump to the deep learning topics very easily. Just this. So first of all, I believe everybody's class that whenever you implement any machine learning algorithm, you need to split the data into 4 different types of data types. Not data type, but data types. Example, X train, Y train, X test, and Y test. Did everybody that a data is split in 4 different data categories, if you can think of it like this: X train, Y train, X test, Y. Just for clarity in the class, I am still going to repeat the topic, and then we are going to jump into a very fascinating topic called a neural network right now. Okay, specifically a feed forward neural network, densely connected feed forward neural network. Okay, so first of all, whenever you are given a data, example, suppose if you consider somebody's age, somebody's salary, somebody's civil score, and whether that person deserves loan or not, right? So I have age, I have how much salary a person makes, what's that person's civil score, and whether that person deserves a loan or not. If you look at this data, right, this particular data has 3 features. Feature number 1 is age, feature number 2 is salary, feature number 3 is civil score, and feature number 4 is loan. So we have age, salary, civil, and loan. These are my features. Now, what usually happens is, let's say for these features, right, I have some data set that looks like this. So for example, if my age is 23, my salary is say is 80,000 rupees, right? I make 80,000 rupees a month. My CIBIL score is 800. Then the loan will be given. One means, yes, I will give that person a loan. Let's say if my age is say 37, my salary is say 60,000 rupees, right? Or your CIBIL score is say 700, then no, I will not give you loan because it does not make sense. And if I'm say 39, I make 2 lakh rupees as a salary, then, and you know, my CIBIL score is 815, then yes, I'd end up giving the loan. So see guys, the first important thing that you have to know is, whatever your features are, which is these values, right? Your age, your salary, and your CIBIL score. The one that you use to calculate the target variable. This is my target variable. Loan is what I usually call as my target variable. This is what I want to calculate. And these are my features. Whatever your features are, they are called as the independent features or independent variables or X, and your target variable is known as Y. So what usually you need to do in machine learning is you need to make two cuts, C-U-T-S, cuts. The first cut you're going to do is going to be here. You will split the X and the Y separately. Okay. So what you do, you cut the X and the Y separately in a machine learning based data. So what did I do here? So see, every single data section here would become my X and every single variable here would become my Y. So everything here is an X, everything. And after you have taken the data like that, you have split the X and the Y. My people, you further make another cut. So see, the first cut you did was to separate the features and the target separately. And remember guys, there could be multiple target variable that is also allowed. And of course, multiple features is what usually you will see in your career. Okay. Now what you do, my people, you split or you do the second cut. And that cut is called as dividing the data into training data set and testing data set. So let's say this is the second cut I have made. This cut is going to be my second cut. Splitting the data into two categories. One is called training data set, the one that you will be using to train the model, and the other one is to test whether the model that I have built is good or not. Remember guys, I am not telling you the concept now, but apart from training the model and testing the model, there is one more data set split that you take, and that is called validation. Have you heard of a concept called validation set? Validation set is used for cross validation or hyperparameter. How many different tables can you see in this particular example? Can you see table number 1, table number 2, table number 3, and table number 4? Everybody, can I see 4 different tables created? In the example of splitting the data into 2 different sections, I see 4 tables. Each individual table has a name. So guys, this portion of the table, this portion of the table that you see that I have highlighted in yellow is called as X underscore train, because X and train. This portion of the table that I'm highlighting in blue is called as Y underscore train. So Y underscore train. This particular data is called as X underscore test, and the other one is called as Y underscore test. So did we get 4 answer? X train, Y train, X test, Y. Apart from all these tables, you will make one more table called ypred or y prediction. Whatever your model training has been done, you try to predict some output of the model. Say the prediction of actual test set is 1, you also got 1. So can you compare your y test and ypred and see how good your algorithm is? You can compare the y-test with y-pred and check whether your model is clear. This concept is very critical for you to understand, because without understanding this, we cannot proceed forward. Now, let me ask you something. Is this all possible only and only if your model is a supervised learning algorithm? Think about it. I want you to think deeply. All this thing can only be done if your model is supervised learning. Agree, disagree? If your model is an unsupervised learning model, do you even have a label to compare y-test? No. So remember, the way to check or test whether my supervised learning model is good or not, I can do this. But if my model is unsupervised, whether my model is performing good or not, there are other ways. Relationship between white and is this my actuation? When I compare y-test and y-pred, am I not comparing that from actual reality? How far is my prediction? So the relationship between y-test and y-pred is to test that how close was I to the actual. We call that as F1 score, accuracy score. You guys must have heard about. Is the idea clear, everybody? What is the relationship between y-test and y-pred, which is this data? Good. So guys, just a quick idea to in supervised machine learning, what kind of algorithms you will see on multiple different occasions. For regression, you have linear regression, polynomial regression, decision tree regression, and random forest regression. There are multiple different types of regression you will see in supervised learning. But when it comes to classification, I have k nearest neighbor, decision trees, logistic regression, naive-based classifier, and support vector machine. These are some of the algorithms that you will find in supervised. When it comes to unsupervised learning, you have multiple different clustering techniques, singular value decomposition, SVD, principal component analysis, PCA, k-means clustering. You also have something called as closeness or association properties like a priori and FP growth. You also have something called hidden Markov model. This is not, well, it's a little complicated topic to just directly say it is unsupervised. It is unsupervised, no doubt, but it's a different kind of algorithm. And reinforcement learning is a completely different game. Q learning, DPRO, DPO, PPO will not even get to. Now, what we've understood so far is couple of idea on machine learning algorithms, machine learning techniques. And by the way, you don't need to learn hidden Markov model and a priori or an FP growth algorithm. This is just an example. Doesn't necessarily mean you have to go ahead and learn it. This is just an example. Now that we've understood the concept of all of this, right? I want to bring about a concept which is going to be very critical for your understanding, and the PPT that you see in front of you were all talking about the basics. But guys, what happens is because we've discussed more on what machine learning is, how it works, what it does, what we are going to be talking about right now is a type of algorithm that makes process even more easier, and the algorithm that we are talking about today is going to be pretty much on something called neural like. Now, let's get started with understanding the topology of a neural network. A is nothing but a mathematical model of a human neuron or into a very simple mathematical sort of a model. Okay, so human brain inspired mathematical model is called as. Typically, an artificial neural network has a layer. You to tell me this. Do you see three layers? The blue layer is called, the middle layer is called, and the outside layer or the green layer is called. So first of all, whenever you design any neural network, let's say you come up with your own neural network, is where the data is going to be input. It will pass through the hidden layer, and the output layer is the one that will give you the good. Everyone has heard about AI, but right, don't really know the inspiration behind the artificial neural network and where do they actually come from. So you guys need to know that in humans, right, we have the concept neuron, a literal neuron that is used or that is available in our brain. We are inspired from that and we've created a model of our own. Now, I am not interested more in the biology of it. What I'm interested in is what information it carries. This particular graph that you see in is taking the input x1, x2, x3, x4 all the way till n, passes through some weight. We do something called addition of bias and we sum it, pass it through activation function, and we get the output. Now you must be like, but I don't understand what the logic is. Like, okay, what is weight? What is bias? What is this x1, x2, x3? What is this w1, w2, w3? I don't understand. Okay, understand it. Let's understand something. A neural network defined or a simple perceptron that I defined will have a black input node 1, input node 2, and input. Guys, this is what I like to call as my input layer, IP layer. This is my first. Then this becomes my hidden layer. Okay, the layer that is sandwiched between input layer and output layer. Okay, so this is my output layer, and this is my hidden layer, and this is what I'd like to call as my every single circle that you see, we call that particular circle. Every single circle that you see here, we call that particular as node. Guys, node from input layer 1 needs to be connected with every node in the hidden layer. Meaning node 1 will be in touch with this also, node 1 will be in touch. Node 2 will be in touch with this as well, and node 2 will be in touch with, and node 3 will be in touch with the hidden layer node 1, and it will be in touch. This connection is connection. Then whatever your input layer connections are, your hidden layer connection will be connected to the output layer node 1 and your output layer node 2, and then you're going to get an output called output. Okay, this particular value will give you something called Y predicted result. Now guys, if I name everything together, node 1, node 2, node 3, model 1, model 2, and say C1 example. See guys, from your input node 1 to your model 1, the connection is actually called as a weight. We call this particular thing as a weight, W-E-I-G-H-T, weight. So between node 1 and M1, can I say W1, W2, W3, W4, W5 and W6? There are 6 weight values that are connecting from node 1 to. There are 6 lines that are connecting. If you don't know what weights are, let me tell you. Yesterday's class, did I tell you that you should look at a neural network like an information flow pipeline? Like an information flow pipeline? Yes or no? So let me ask you guys something. If I have a place, a water tank, can the water tank have a pipeline which is a big pipeline, which a big diameter pipeline? And the same water tank can have a pipeline which is a small water pipeline. If my weight value is 9 and my weight value is 2, which pipeline carries more? 9 will carry more water or 2 will carry more water? Will it be 9? Okay, listen to me guys. Can I say that from node 1 to multiple different connections that we are doing, the weight value W1, W2, W3, W4 are simply how much information I am passing? Yes or no? Will you think of it like this? How much information is being transferred from my input layer to my hidden layer? How much of that information is being passed? Remember, weight values can be positive also. Very good. Now tell me, sir, how can I know how many connections I need to do? Very simply, how many nodes? 3. How many nodes do you have at the input? 3. And how many do you have at the hidden? 2. What is 3 multiplied by 2? 6. That will be the number of weights value you need to connect. multiply the nodes in the input, multiply the nodes on the output. That is the exact amount of weight value you need to connect. But have we connected all the weight value? No, because after weight 6, you have weight 7 and weight 8 also. So totally, to build a simple neural network connections together, how many nodes did I need? 3, 4, 5, 6. How many nodes? 6 nodes in total. 6 nodes, 8 weight values, correct? 6 nodes, 8 weight values. But guys, your job is not done, because in hidden layer and the output layer, you add also one more thing called bias. So this is bias number 1, this is bias number 2, and this is bias number 3. So please tell me together how many biases did I add? 8 weight values and 3 bias value. So total, how many parameters do you get? What is 8 plus 3 every 11. So you built a neural network model with how many parameters? 11 parameters. And guys, the mathematics of this is so important. Have you ever seen a large language model, guys? Like, let me very quickly show you why the math is important. So let me show you something, right? Oh, by the way, I just want to let you know. See, this is our model that my team built. This is for AI for Bharat. So this is, oh yeah, look at this. This is 4,64,952 downloads. That's nice. That feels good. Wait, so yeah, let me just open up DeepSeek. So if you see, open up DeepSeek R1, right? Can you see the model has how many? Let me open that up, or maybe let me show you one of the models that I like, Microsoft 5. So 5 3. Let me come over here. Let me say 5. Oh, there's also, okay, let's say 5 3. Here, my see, guys, if you see this particular model, right? This model I'm assuming is a, what, how much is the size of this particular model? I'm assuming what, this must be a 3 billion parameter model. The large language model, which is Microsoft 3.5, I can literally chat with it. How are you? Right? If I send a message, it will be able to respond back to me. I am 5 Microsoft language model. Don't have a feelings, but I'm here to do whatever XYZ, XYZ, XYZ. If you observe this particular value here, can you see here? The model size is a 3.82 billion parameter. So the logic that I'm teaching you right now, the way to calculate the model parameters will come handy later on. Are you understanding? When you go into generative AI, the logic that we are learning right now will slightly help you there. I want you to understand the connections I'm taking you through. Okay. So guys, we built a neural network. The total neural network connections are 8 by 8 weights and 3 biases, total 11 parameter model. Your model size is an 11 parameter model. Okay. Now listen to me carefully. Rather than teaching you the theory and unnecessary stuff, let's understand what the logic behind it is. Very good question. Sir, why do we need a bias? What is the reason? In a neural network, to make the model learn the pattern, okay? To make the model learn patterns within the data, we add a little bit of error, a small uncertainty we add in the. I'll give an example. Imagine you want a child to learn how to play cricket, learn how to play badminton, learn how to play. Okay, let's say you want a child to learn how to play badminton, okay, or tennis. So tell me one thing: your child is going to face lot of challenges while learning tennis. Agree? How to hold the racket, pain in the hand, tennis elbow, high competition, heat, and all of that stuff. But apart from all of this, okay, apart from all the technical understanding of tennis, will the child also learn other things like getting late to the, going late to the session, falling down on the road, other problems which you cannot ever think of, but it builds his character as a tennis player. It is raining, the city is closed for some, I don't know, for some Bharat Bandh or India XYZ nonsense. So can I say there are some issues that you can never predict, but they can actually exist, that can stop you from becoming a tennis player. Some things that you can never judge, never understand, it might come up, but they will come up. I'll give you an example, right? I'll say, let's say you wanted to study for your exams. Everyone listen to me. You wanted to study for your exams. You have exactly 50 days to revise all the concepts. You've properly created all the plan that I will be able to complete all the revision in 30 days. But suddenly your relatives get sick and you need 15 days to go help them. Are you understanding? There are always going to be chances where your plans may not work out, where there will be some kind of uncertainty introduced in the model or uncertainty introduced in your life. What a bias does is we introduce that slight uncertainty in the model because we want our model to understand the pattern within the data, but with slight uncertainty we make the model. Are you understanding what I'm trying to say? That's the logic of a bias. Bias meaning we give it some kind of an unnecessary information that makes my model more consistent, meaning consistent variant logic, preparing the model for every small little thing so that it understands the relationship actually, even if the small error exists. That thing is called as unclear. Tell me, what is the English word of the meaning bias? A certain favorable position in a person's brain, right? A certain partiality of sorts, a certain favor or a behavior. So bias must not be a very good thing, right? In English language, when you say I am a biased person, am I saying I am highlighting my positive character? No. So tell me, if I'm introducing the concept called bias 1, bias 2 and bias 3, I am actually introducing a small miscalculations in my data to make sure overall my neural network can be handled and managed by myself. Meaning, I can slightly tune my biases and I can change the way the behavior of the model works. Right? I can change the behavior of my model with the tune. Okay. I'm going to give you guys a small idea. Okay. Sir, we connected the input layer. Okay. We connected the input layer with the hidden layer and the hidden layer with the output layer, and we might get the answer. Okay. But before we even continue forward with this, I want you guys to understand one very important factor. Okay. Sir, how many input layers can I take? How many hidden layers I can take? And how many output layers can I take? First of all, you can only have one input layer in a neural network. Your input layer can only be your output layer can, but your hidden layer can be many. Agree? Meaning, I can take a hidden layer of node 3, I can take a hidden layer of node 2, and I can even take a hidden layer that looks like this. Everyone, listen to me. Suppose my input layer is 3 input nodes. I can take my hidden layer as the initial 3 input, then one more input layer with 2 nodes and one output layer. Can you see my input layer is of 2, hidden layer 1, hidden layer 2. First layer has 3 nodes, second layer has 2 nodes. But for now, understand that this is allowed in a neural network. Understood? You are allowed to take this particular inference. Both are input layer. You can consider that, but actually no, hidden layers are hidden layers. They have their own responsibility. They are cause any changes, right? Let me explain. My input layer is a specifically well-defined structure where the input of the model is taken. Agree? Only when the initial layer where the input is past is going to be called as input layer. Am I making myself absolutely clear? Your hidden layer is not your, only your input layer accepts the input within the model. So only that has the capability of being called the input layer. Am I making myself absolutely? Okay. Point number 2. Listen to me very carefully. I can take a hidden layer where the number of nodes could be anything 1, 2, 3, 4 and 5. My hidden layer 1 HL1 has how many nodes? 5. I can take second more layer called hidden layer 2. How many nodes can I take? 1, 2, 3. Hidden layer 1 and hidden layer 2. I have taken how many layers? Hidden layer specifically 2. Hidden layer 1 is nodes 5 and hidden layer 2 is 3. This time, rather than having one node in the output layer, how many nodes do I have in the output layer? 2. First of all, is this allowed? The answer is yes. Anything is allowed because it is dependent on the goal. Okay, good. Now, listen to me carefully. Will every single node be connected to every other node like this? Yes or no? Then the second node will connect to every other node 1, 2, 3, 4 and so give me 1 second. 1, 2, 3 and 4 and 5. Okay. How many nodes did I have? Is this 3 node? Is this 3 node? Okay. How many node is this? 1, 2, 3, 4, 5. 5. What is 5? 3? 15. So how many weights value do I need here? 15 weights. First, input layer to hidden layer 1 connection. Did you understand that you can take as many input nodes as you want, as many hidden layer nodes as you want? Is that concept clear to that? Yes, in the input node, any number of nodes are possible, and in the hidden layer 1, any number of nodes are possible, and the connection should be done like this. Acha, by the way, listen to me carefully. Sir, connecting the node of every single node to every other single node, the name of this connection is called dense connection. What do we call this? Dense connection. Remember, this is going to be your lifesaver in the future. We call this FCN or dense connection. What is the full form of FCN? Fully, F-U-L-L-Y, fully connected layer or network. Did you get it? FCN or dense connection. You can call it either call it fully connected network or call it dense connection. Now tell me guys, I understood that between my input node 1 and my hidden layer 1, I can connect 15 different weight values will help me connect my input layer node 1 to the hidden layer node 1. Until here everyone is clear. Now guys, tell me one thing. Is my no, my network is not complete. So now tell me, do I need to connect my hidden layer node 1 to hidden layer node 2, which is layer 1 to layer 2 connection? So this is 1, this is 2, this is 3, right? And then this is going to be, let's say 4. I know the diagram is a little tricky, but get the idea, right? And then we have something called 5. Now, did I connect every single node to every other? Now, guys, tell me this. This is how much? 5, right? Multiplied by 3. What is 5 threes are? So, how many weight values do you need here? 15. You need 15 different. Now, let me ask you, only hidden layer number 1 and hidden layer number 2 Only between hidden layer number 1 and hidden layer 2, how many connections do you need? 50. And between input layer 1 and hidden layer 1, how many connections do you need? 50. Every you are allowed, ALLOWED, you are allowed to do what? Take as many hidden layers you want. Hidden layer 1, hidden layer 2, hidden layer 3. You can take it to hidden layer 1000 also. No problem. Take as many as you want. And in each hidden layer, you can take as many nodes that you want. Are we clear? But tell me one thing, guys. When I say you are allowed to do whatever you want, shouldn't there be some kind of a rule? Shouldn't there be some kind of a universal rule that a student in United States of America or India or New Zealand, they all should follow the same rule? That if you want to take hidden layer, how many hidden layers should I? For hidden layer number 1, how many nodes should I take? And for hidden layer 2, how many nodes should I take? Should there be a rule? Yes. Are we clear? So is everyone's question clear? Sir, why did you take 5 here? Why did you take 3 here? This is just to show you as an example. But remember, there is a reason behind why you should take 5 in the hidden layer 1 and got the logic? That doesn't mean that if I'm allowed to take 1000 hidden layers, suppose the hidden layer can be gone all the way to 10,000. But should you take all the 10,000? Let me ask you a question. You went to a mall and you saw this beautiful jacket. If the jacket is 30 or 3000 rupees, will you pay the cashier 6000 rupees? When 3000 is enough for you to buy the jacket, will 6000 be an overkill? The guy will take 6000 happily. Why pay extra? That logic applies in the taking of the nodes in the hidden layer. When input layer or when the hidden layer can work with 5 nodes, why do you want to take number of hidden layer and bias will not decide the objective? Okay. So tell me, why every single node should be connected to each? What if one of those are not connected? If they are not connected to each other, are they sharing information? And if they are not sharing information with each other, are they truly connected or learning? The answer no. So that is why every single node needs to be connected with every other node, so they can share information with each other. Let me give you guys an answer. I'm sure you guys don't know this, but if you do a crime in a state like Karnataka and Mumbai, do you think you can escape? Isn't Indian police connected every single place here? They share information with each other. One police station can share information with other like in a second. Are you understanding? Just like that, you have a neural network that can share information from one place to other place. Got it? To share the information and to learn better, they are all connected. Are we clear? So let's complete this. My hidden node 2 or hidden layer 2, will it be connected to my output layer, this and this? And then this will be connected to this and this, and then this will be connected to this and this. Are we clear? And these, please tell me, how many weights will I need here? 3 multiplied by 2. What is 3 to? So 15 plus 16, 15 plus 15 plus 6. Can I say totally 36 weight values are required to build a... Apart from 36, bias 1, bias 2, bias 3, bias 4, bias 5, bias 6, bias 7, bias 8, bias 9, bias 10. How many biases? 10 biases. So did you guys learn how to create a neural network? Okay. Neural networks are also called universal function approximators. Now you will be like, what? What is this new terminology you keep introducing every single time here and there? Well, guys, the technical terms are important. Do you guys agree with me? understanding the technical terms becomes very, very important. Otherwise, you will sit in a group of people and you will not know what to say. So first of all, sir, what do you mean by universal function approximators? Okay, so copy. Okay, let's understand what neural network does so brilliant that my machine learning is incapable of that. Let's understand. This is a simple picture of a jug. Everybody agrees? Not a very complicated thing I'm drawing. A very simple photo. If I want to build a mathematical to plot this jug on an x-axis versus y-axis data. For example, x-axis and this is. Writing down the formula to print this jug, a line, a curve that looks like this, a curve that looks like this, a curve that looks like this, and then again a curve, again one more curve, and a curve like this. Do you think it would require a lot of time, energy, effort, and computation to come up with the formula to print this jug? Mathematically, agree? Like if I want to make this jug mathematically plottable, meaning this equation could be x to the power of 4 minus 3x to the power of 3 minus 0x cube minus this, and then this curve would be some formula. Then I need to combine all the equations together. I don't want to do that. Okay, I am not interested in doing that. So rather than dealing with a problem like that, can I do this? Can I take multiple different data points on that jug randomly? One here, one here, one here, one here, one here, like multiple different data points. Okay, like I'm going to show you. Look at this, everyone. I'm taking multiple different points. Okay, on this particular jug. Random points, guys. Random points. Completely random points. Now tell me, did I take all the data from the jug? Or am I taking the complete jug as a Am I taking the complete jug as absolutely not? Am I not taking some random data points on the jug? Now tell me, if I okay, just specifically if I were to remove the jug round, okay, if I were to remove the jug from the background and just have the dot, okay, are you seeing that the red dots are kind of taking the jug? I removed the photo of the jug completely, but the red dots are kind of giving me almost a very closer. So tell me, rather than taking the entire jug, calculating the mathematics behind, can I use a neural network to take this data of the jug, give it the original picture of the jug, and it can approximate how the jug would look? So rather than exactly calculating the formula or the way a jug looks like, did it approximate what a jug would look? So what should you learn from this topic? No matter how complex my data is, will my neural network fit that data? Understand it will approximate. Let me ask you this question, okay? Imagine my data looks like this, okay? My data of the customers look like my new work. Rather than coming up with the exact answer, will it fit the like this? It will say that, yeah, depending on the data, my neural network's learning is, I have learned that the model follows this behavior, the green color part. Isn't my neural network's output approximating the actual data? Now, if I wanted to do this in machine learning, is it that easy? You know why this is not easy? Because every machine learning algorithm does it not have its own bias, its own variance. So approximating the relationship if in a data which is very, very complicated, won't I have to choose multiple different algorithms? And even that algorithm is not guaranteed if that complex data exists, it will approximate the data well. Agreed. This is one of the reasons, my people, neural networks are the best universal function approximators. Meaning, no matter how complicated your data looks like, my neural network can always learn. Isn't it the best way of learning something with a little practical? Whatever I taught you was a. When we take an actual practical example, the one that is used in the industry, won't we learn better? Is everyone agreeing with me on this concept? That yes, sir, I think taking one example will give everyone a clarity about the theory that you had taken. Now is the time to learn the practical part of it. Are we clear? Because theory was important for you guys to first understand how. Okay, let's take this of sleep. Cups of coffee, travel time, and productivity score. Productivity score. Guys, I only had 7 hours of sleep in the last night. And in the morning, I had 2 cups of coffee. The distance between my office and my home is 25 minutes. What will be my productivity score for that day in the office? Can I say 85? Productivity is a score between 0 to 100. How much productive will you be that day? I'm saying 85%. I had 6 hours of sleep last night, only 1 cup of coffee in the morning, and my travel time is 32 minutes from my office to my house. Will my productivity be 65? I had 8 hours of sleep, 2 cups of coffee, and my travel time is only 17 minutes. Will my productivity? I had 8 hours of sleep, 3 cups of coffee, 19 minutes of travel time, and my productivity score is 9. This class. Are you understanding this data? I have taken the data of how many hours of sleep did I get in the last night, how many cups of coffee I'm drinking, what is the travel time from my office to the home, and what is the productivity. Is this data set making sense? So tell me, the relationship that my independent variable has with my dependent variable, the relationship can be understood by neural network really, really well, right? Under what hours of sleep, what cup of coffee, what travel time, what should be my productivity score? So if I want to calculate, I slept for 7 hours in the last night, had 4 cups of coffee, and my distance is 20 minutes. Can my neural network help me predict what will be the productivity score next? Yes. Agree, disagree? If I give it enough data, this is what my neural network will tell me. Will my model help me? Guys, if I want to make my neural network build every single percent, how many inputs, how many inputs do I have? Hours of sleep is feature, cups of coffee is feature number 2, and travel time is feature number 3. Because productivity score is my target. How many features do I have? 3. So my neural network will also have only and only 3 input. Can I take 4 node input? Sir, you cannot. Because in the first node, what will you pass? Hours of sleep. In the second node, you will add how much coffee did you. And in the third layer, you will add the travel time node. So tell me, based on the goal of my project, how many input layers am I supposed? So did you guys understand why did I take 3 as my input node? Why does my input node layer or my input layer has only whatever is your feature? That is exactly the number of nodes you should take in the input. This is if you have number of features which is 5, how many nodes will you take? Simple. Sir, how many hidden layers? For simplicity reasons, can I just take one hidden layer of 2 nodes? Can I please do this? Sir, for 100 features, should the nodes be 100? Yes. Absolutely correct. If your input feature is 20,000, then how many nodes will you add in the 20,000? Simple, plain. Now, can I say for simplicity reason, my input layer is 3 node. I am only taking one hidden layer with 2 nodes so that the logic. My people, my output layer node is also 1. You know why 1? Because my target variable is a number between 0 to 100. No. I want my output to be any number between 0 to 100. Won't one output layer give me that answer? One output node will give me an answer between 0. Now guys, listen to me. If my target variable had data like this, negative, neutral. Example, I had 3 label. My label was positive, negative and neutral. Then how many nodes would have been my output? Positive, negative. If your output is a regression based output, which is continuous variable data, only enough. But if your target variable was multiple different classes, equal to the classes will be your equal. Getting, I will later on make this in one node also. I can make the 3 node output in one node. I will teach you that later. But for now is output clear? So depending on the goal of my data or the project, is this the neural network I have decided? This is how my neural network will look like. Node number 1 connection to node number 2, node number 2 connection to hidden, then this, then this with this, and this with this. Now, I will connect the node from here to here and a node from here to here, and then I will have an output here. Is this the neural network design? We've just successfully just designed our neural network. This is the first step. Okay. My question to you is I want all of you to listen to me. Imagine you and your friend are doing boating. You understand boating, kayaking, boating, whatever you want to call it. There is this beautiful lake and your friend, you are sitting on the shore, on the edge of the lake. This class, let's take कोई ले लेते हैं. Shiv is on the boat. Shiv is, and he is boating in the, let's say Vani is sitting in the edge of the river. Now Vani has a very weird thought. Vani wants to throw some. Now because Vani is sitting at the end of the lake, at the edge of the lake, what will Vani have? So what will Vani do? If you think about it, what will Vani do? Vani will pick up a rock and she will throw the rock at Shiv. Now what will happen is, unfortunately, the rock that, sort of went here. It went to this piece of the lake. But based on the calculation, will Vani get some feedback? I think I need to throw the rock a little forward and a little to the bottom. Vani will get the feedback from the first mistake she made, the error she made. Oh, I think I'm way too far. I need to throw a little bit more and a little to the left. Now Vani throws one more rock, but she throws way too far. Will this error also give Vani the feedback? The third rock Vani throws hits Shivam on the. So can I say that even us human beings, we learn from our mistakes? From the mistakes, do we become better from the mistakes that we learn? To me, can I say that mathematically speaking, the error is nothing but actual value minus predicted value. This is going to tell me how much mistake or error I have. My actual value minus my predicted value will tell me the mistakes I have done in my predictions or my model, how good my model is. Don't you want your actual value and the predicted value data or the difference as less as agree? So tell me one thing, for the neural network to learn, to become better, don't I want the information flow to go like this? In this direction, pass the data, like how many hours of cups of coffee did I have, my people? 7. How many cups of coffee? 2. And how many is my travel time? 32 minutes. Suppose I do something called as the forward flow of the information, and the output my neural network will generate is 60. My people, the predicted value by the neural network is how much? 60. But what is the actual value? 85. So tell me, what is 60 minus 85, everybody? Is the difference 25? Yes or no? Is the difference going to be 25? So tell me, is my model learning the best? Did it understand best? No. So once you go forward, don't you want to go backward and teach the model what you did? In the forward flow of the information, I am encouraging my model to make some prediction. Once you make the prediction, and based on the mistakes I need to know, don't I need to go back and fix my mistake? So going back, fix, again predict, fix, predict, fix, predict, fix, predict, fix, predict. Do I keep looping fix, predict, fix, predict? This loop goes on and on and on. Make a prediction. Oh, I'm far. Stop. So tell me, when I say fix, when I'm saying fix something, what am I fixing? First of all, guys, the neural network is able to make the prediction because there are some values called weight 1, weight 2, weight 3, weight 4. Some numbers are given to weight 1, weight 2, weight 3. When I say fix, am I saying I am changing the values? When I go back, I am changing the weight 1 value, weight 2 value, weight 3 value, weight 4 value, weight 5 value, weight 6 value, weight 7 value, so that my prediction is until here you guys logic. I'm talking about the logical part, not the mathematical part, just the logical part. Good is today. How do you build a neural network? How many connections it requires to build a neural network? And we've taken a small data set also. Okay. While we go fix the data, don't you need to fix both weights? And you can't just conveniently fix only weight and say, oh, everything is good. You need to fix your bias. So what we will be fixing, we will go back, fix the weight. So as promised, let me show you some real life examples of a feed forward network. Imagine guys, I have taken this variable called hours of sleep. I have another variable called cups of coffee. Cups of coffee. I have another variable called travel time. And my target variable out of all of this is the productivity score, correct? Guys, because I don't have a data of my own, right? For hours of sleep, cups of coffee, productivity score, I currently don't have any data of my own. So what I'm going to do, my people, I'm going to show you how to generate your own synthetic data, meaning your own fake data to try the model on, just to get a hands-on on how a neural network works. Then we'll take a couple of examples and then we'll try to solve how a neural network works on other data, right? So first of all, I'm going to import pandas as PD, right? This is one of the most important libraries that I'm going to be using, of course. Now what I'm going to do, my people, how many number of samples do I want to generate? Can I say 1,000 samples, everybody? I want to generate 1,000 samples and only 1,000 samples. Okay, good. I'm going to say np.random.rand, random, number of samples, comma 3, multiplied by np.array, and inside this I'm going to write 24, comma 10, comma 60. Now you guys will be like, all right, what does this code do? Let me ask you a question. My feature set is hours of sleep, cups of coffee, and travel time. How many columns are these? 3. So can you see here? I have taken number of samples, comma 3. I am telling NumPy that create 3 columns for me. The hours of sleep will be a number between 0 to 24. Agree, disagree? Because we have only 24 hours in a day. So I want my NumPy to do a pointwise multiplication so that the random numbers will range between 0 to 24. Now tell me, how many cups of coffee do you think you can drink at a max? Can I say up to 10? I mean, more than 10, you must be, I think, crazy. But am I saying that randomly generate data between 0 and 10? And the number of travel time will be between 0 to 60 minutes. Agree, disagree? So it will randomly generate that data for me for hours of sleep, cup of coffee, and travel time. But for y, I don't need to do this. Why? Because y value is a random number between 0 to 100. So np.random.rand, number of samples, I will just multiply with this with 100. Agree? All I am doing is just creating random numbers between 0 to 100. This is just for the creation of my data. But the problem is, whenever you deal with random numbers, every time I run the program, it will give me, every single time, the program will give me weird random numbers, right? Random numbers also won't be very solid. Random numbers will be different every single time. To make sure the random numbers are generated once, but they don't change again and again, we have to use something called np.random.seed, and I will take the seed value to be 10. I'll give you guys a practical example. Tell me this, np.random.rand, okay? And let me just say number of samples are 2, 1, okay? And if I run this, can you see I'm getting a random number called 0.645 and 0.5? If I run this again, did it change again? If I run this again, did it change again? Again, this keeps changing. If I want the random number to be generated once, but don't change it again and again, what you do, take some random seed value and put whatever number you want to put here, but the number should be positive. Remember, negative seed values are not accepted. Anything 2 to the power of 31, 2 to the power of 31 is allowed. So how do I take power of 31? Because you are actually 32, right? Because it's a 32-bit machine. So if I run this now, do you see I have a random number generated? But if I run this program again, is my random number changing? Look, no, I have generated the random number once and I have, that's good. So now that my data is generated, I have made my data work. What will I do? I will take pd.dataframe. Inside this, I will pass the value x, and the columns that I will pass will look something like this. First will be hours of sleep. Let me copy this. Let me paste it here. Copy, comma, copy, comma. Okay. So cups of coffee. Copy this, paste it here. Travel time. Copy, paste it here. So what did I do here, everyone? I have taken pd.dataframe.head of 5. What do you see in front? My randomly generated data. I had 18 hours of sleep, 0.2 cups of coffee, 4 cups of coffee, 7 cups of coffee, 6 cups of coffee, and 5 cups of coffee. If you want to convert this into integer, feel free to do that. I'm going to take the same data that I've taken. I'm not going to change it. I'm going to keep it. Sir, I want to create my neural network. So define create underscore custom CUS custom underscore model. Now listen to me carefully. Guys, to define any neural network from today onwards till the time you leave your job in neural networks or deep learning, remember one thing: you need to first declare your input layer, you need to define your hidden layer, and you need to also define your output layer, correct? This is how a neural network is defined. You split the neural network into input layer, hidden layer, and output layer. Sir, how do I declare an input layer? Use any variable you want. I'm going to say inputs equals to. Now, in order to create a neural network, we are going to be using a package or a module called Keras. Okay. So what will I do? From TensorFlow, I'm going to import something called Keras. Are we done? To declare or to create my input layer, you need to say Keras dot with the capital I call input. Can you see here? Keras dot input. Now my question is, what will be the input size of the node? Shape equals to inside the bracket 3. Did you just tell the TensorFlow model, can you please create an input layer for me? I have already told you this is my input layer, and what will be the shape? How many values will I accept in the neural network at once? Only hours of sleep, cups of. Please create the first layer, and the first layer will have 3 nodes. How many nodes did I take in the model? 3. After the first layer, which is the input layer, what do you need to declare next? The hidden layer, correct? Take some variable x equals to. Now my people, what you need to do to write hidden layers, you need to import one more package, one more module from TensorFlow dot Keras import something. Whenever you need to import any layer, you have to import something called layers. From TensorFlow.keras, I have imported layers. I come to the bottom. What do I do? X will be equal to layers dot. You're telling the neural network that, hey, I am creating a layer, which is a hidden layer, and I want that layer to be dense. Whenever you say dense, I'm saying dense. How many nodes do I want in my input layer? 2, 1 and 2. One layer but 2 nodes. So what will you say? 2 comma. You guys know that when I taught you this program, what activation function did I take to show you the exact same code? Have I taken the activation function as a sigmoid activation function here? When I taught you the program, the activation function taken here specifically was sigmoid. So what will you say? Activation will be equal to. Now tell me guys, I have taken my input layer, I have taken my hidden layer, but did I connect them? Did I make the connection? Is the connection touched? Is there a point of contact? Not yet. How do you connect them? Take a bracket, and can you see here the variable or the variable name that I took for my input layer was called inputs, and I have just passed it in inputs. Now did I connect them together? Yes. What do you mean by dense? Sir, what do you mean by dense? What does dense mean is you are now connecting each node to each other node. So 1 and 2 is connected. This and this is connected. And this here. Now you have completed your layer 1 and have a lot to do. Now I will create something called output layer. Now tell me one thing. I will take one more variable. So output's equal to, because output is also a layer, so will I call layers? Layers also is a dense connection, right? Hidden layer and output layer also need to connect with each other. Fully connected, no, which is dense. So did I call dense? Okay. In my output layer, what will be the number of node that I 1. So what will I write here? 1 comma. What is the activation function? My question to you all is this. Isn't my output regression based output? Any number of productivity between 0 and 100 could be gotten. So I can't use sigmoid. No, I cannot use sigmoid because sigmoid will give me between 0 and 1. I want between 0 and 100. So very simply write down, tell me, did I connect my hidden layer with my output layer? No. How do I do that? Put a bracket, pass x. Can I say my neural network is complete? Okay. Okay. Sir, can we use min-max scaler to get all the output done? Let me ask you a question. In machine learning, you have to do feature engineering all by yourself, right? Feature scaling, uh, feature engineering, feature extraction, all of this. But in deep learning, do you do any of? My question is very simple. I'm not asking a complicated question. In machine learning, you had to do normalization also, standardization also, recursive feature elimination also, covariance, not covariance, sort of correlation testing also. All of this you had to do. But in deep learning, which is the neural network, is that an important? The answer is no. So tell me one thing. When you implement deep learning, sir, can I use min-max scaler, normalizer, standardizer? If I don't use it, what will happen? Nothing will happen. Your answer will be still the right answer. But sir, should I do it? The answer is yes. Because doesn't it save neural network a lot of unnecessary? Am I making sense? I'm giving you a very okay. So coming to the point, can we use min-max scaler? We can. But tell me one thing. Are the ranges, ask me this question, are the ranges too different, meaning one range is between 0 to 10, other between 0 to 100 and the other between 0 to 10,000? No. Mostly, probably they are all in the same range. So you don't need a min-max scaler or a standard scaler. You don't need it. But can we do it? I took the input variable or my input layer. I took my hidden layer and I have taken my output layer. I made sure I connect the input layer with the hidden layer. I made sure that my input layer is connected, my hidden layer is connected to my output layer. This is the code that I've written. And my activation is linear because the output that I want from this model will be a number between whatever specified range. Now, my people, what you do, you take a variable by the name model. Now you import something called keras dot model. What this dot model will do, inputs will be equal to inputs and your outputs will be equal to your outputs. What you are doing, you are combining your input layer, hidden layer, output layer all as one model and the name of the model will be. So guys, I have taken my entire neural network and called that neural network as a. Can I say this? I will just simply return. Is my function written? Is my function complete? I have said I have created my own custom layer. I took the input, I took the hidden, I took the output, combined everything as one model and I'm calling the good. Now, my neural network, whatever model I have taken, I need to instantiate it or take a variable for it or a name for it and I'm going to call create custom model. Remember guys, once you have created the model in any neural network code, you need to compile the model. So model.compile. Inside this particular, you guys know that you have to use something called as a some kind of an optimizer that can make my neural network work as fast as possible, as best as possible. Usually, the kind of optimizers that we use is something called Adam. There are many. Adam, Radam, Adagrad, RMS prop. There are so many. We are taking something called Adam and the learning rate I'm going to take for this particular Adam is 0.01. And the loss function, since this is a regression based output, what is the usual loss function that people use? Mean, SQUARAD correct? We in loss function. When you implement linear regression, what loss function? Mean square error, mean absolute error, mean absolute percentage error, root mean square error, yes or no? Whenever you have used linear regression or any kind of regression based output to measure how much loss it is, haven't we used root mean square error, mean square error, mean absolute percentage error? These are some of the errors you can use in linear regression. I have simply chosen to use the concept of mean. Agree, disagree until here. Now guys, what you can also do is you can print something called model.summary. And if you run this output, please tell me, everybody, input layer is what shape? Can you say 3 is the input layer nodes? The nodes shape is 3 in the input layer. Good. My dense layer, which is the layer, which is my hidden layer, also has 2 nodes and output 1 nodes. Now tell me guys, totally how many weight values and how many biases? Together total how much? So how many parameter model have I just built? What's the parameter model that I have just built? 11 parameter model. And if you want to summarize that, you can summarize it with something called quick, how do I say this? A quick brush through. I haven't yet come to the optimizers, like I said, but overview I'm going to give you. If you leave from your home to go to your office, you want to take the fastest route which will give you or which will get you from your work to your office and your office to your you as a human being want to optimize your distance or time from office to work, work to office. Just like that, a neural network wants to do something called converge. Sir, what do you mean by converge? Understand the pattern as fast as possible. Agree? I want to understand the pattern within the data in the best possible way, in the best possible directions. Agree? To make sure that my neural network converges or understands fast things the most effective way, not fast, but in the most effective way, you have to use something called optimizers. Optimizers make your neural network understands the pattern within the data in the most perfect sense, in the most right direction, in the most right sense of way. It makes your understanding clear. But when I write optimizers, will the time frame and the understanding become faster? The answer is yes. That is what an optimizer does. For today, I mean for optimizers, because optimizers itself are a very complicated topic. I can't just like complete it in like 2 minutes. It will take, that's great. So tell me one thing. My data set is built of so many different types, right? So from sklearn dot, what do I call if I want to import for train test split? So I need to use something called model selection, right? I can import something called train. Yes or no? But in our example, I am not going to do any train test split. No, I'm not going to do it. I'm going to pass the data directly. I want to do something called model.fit. I will pass the value of x, I will pass the value of y, and epochs will be equal to 150. Or I don't want 150, 50. Batch size is equal to, let's take 32. Validation split will be 0.20, I think. And verbose, let's keep the verbose to 1. To 1. Okay. But I want to explain something to you. Kernel interrupt. Yeah. Let's understand the line number. So first of all, let me talk about two very important criteria: epoch and batch size. Guys, my question to you is very simple. Okay. So many blogs will tell you that one forward propagation and one backward propagation is one epoch. Believe it or not, go right now and check some of the blogs. This is the definition that they say is an epoch. 100% wrong. This is not true. This is not what epoch is. This is not what epoch is. Epochs don't work like this. My question is simple. Okay, let me ask you this question. Let me ask you guys. Sir, any specific reason why Jupyter Notebook is not able to load the library of Keras? So first of all, remember one thing. If you have a package, you will be able to import that package like this. Okay, import TensorFlow and you will be able to run this, right? If I say kernel and restart, see, I'll be able to import TensorFlow like this. You don't have a library of TensorFlow and hence it is not loading. So in order to install TensorFlow, just mention pip install TensorFlow and select the most updated TensorFlow variant, which is 2.1.8.0. Copy this, come over to your Jupyter Notebook and mention with a hashtag, sorry, with an exclamation mark, pip install TensorFlow and run this code. Once you run this code, like how I will run it, it will say that requirements is already satisfied. So if you have the package, it will show up this. If you don't have the package, it will install the package. First of all, I think you guys need to understand a little something. If you guys are slightly interested, let me tell you guys an idea, right? So let me show you an example, right? So give me 1 second. My projects open. Okay. So let's say I have a Visual Studio, or you know what? I think you can ignore Visual Studio Code. This is Google Colab. Okay. What you do, guys, is in Google Colab, I want you to click on this side, this section of the UI, and go to change runtime type. You will have only three options: CPU, T4 GPU, and V28 TPU. Always prefer T4 GPU, considerably better. And click on save. Then click on connect. See, you will find something connecting here, which is it's connecting to sort of like a server where you will be able to sort of use this compute resource whenever you want. Okay. Now, majority of you also don't know that you cannot do machine learning unless you also have something called Anaconda. Okay. So if you know that there is something called Anaconda, guys, is a list of packages and libraries that you automatically get. You don't have to install. You don't have to work hard on installing the packages or libraries for yourself. Just very simply go to Anaconda download, okay? And once you download Anaconda, you will come to this page where you have to mention some random email and click on submit. It will take you to a download page. Download Anaconda, run this, and you should be able to have a library where every single package, including this TensorFlow, Pandas, Jinja, right? All other packages which are not available, you will get it. Okay. If not, you don't want to do this, you can go ahead and install TensorFlow automatically, like how you did it here. Okay. Import NumPy as NP. Okay. So everybody, let's get back to our program. We generated a synthetic data all by ourselves. We have taken and converted that data into data frame. Once we converted that into data frame, we wrote down our neural network. Now tell me one thing. Have I shown you how many hidden layers we have taken? or how many activation functions at the output end. No, right? This is a simple neural network we have taken. Everyone agrees? This is not a complicated neural network with 5 hidden layers, multiple nodes in the hidden layers. No, 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 no. That is not the intention. Intention is to make sure you understand the basics of neural network. I wrote down a simple input layer with 3 nodes, simple hidden layer, one hidden layer with 2 nodes, and one output layer with 1 node, which is linear. I wrote down the optimizer which makes sure that my model converges partal, and I also have a model.summary part which is going to be printing the summary of my entire model, what my model does, how does it look like, all of that stuff in one go. Now guys, what I'll do, I will take something called as history. History is equal to model.fit. So whatever model you have taken, I want to fit it. Sir, in the model.fit, I am passing the value of x and y. Now, sir, how many epochs do you want to run? Epochs will be equal to, I don't know, let's say 150, example. And the batch size that I want to take would be approximately equal to 32, right? Validation split will be equal to 20%. And let's say verbose will be equal to 1. And if I run this model, okay? See what's happening right now. It's running my neural network, and you guys can see that it is printing something crazy. It's going on and on and on and on and on and on and on for 150 size. For 150 steps of operation is what my machine learning or my neural network will be trained on. Now, once all the 150 operations are over, can you see the list of the neural network training that happened? So my model went through step number 1, then went through step number 2, then went through step number 3. That's great. But sir, what do you mean by epoch and what do you mean by batch size? And sir, why is this an important criteria for me to remember? Okay. Uh, for a deep learning engineer or a machine learning engineer, why is it important? Okay. I'll give you a very simple question or a very simple example. Okay. Imagine guys, I keep in front of you 10 different types of fruits or 7 different kind of fruits. And I tell you, you are facing in this direction. Your face is in the direction of the arrow. You are supposed to turn only for 2 seconds and then vapas turn back again. How many fruits were you able to remember? Only for 2 seconds. If you are able to sort of move your head for 2 seconds and then tell me how many fruits were you able to remember at once. Now, if I increase the complexity of 10 fruits to 10,000 fruits, 200 fruits example, not even 10,000, 100 fruits. How many will you be able to remember in 2 seconds? Not much. Much will you be able to remember? No. So tell me, did you look at the entire data or the data that has been passed to you once? Did you look at all of them only once? Did you look at the entire data once or more than once? If you have to remember or understand the data well, do you have to look at the data again and again and again and again multiple different times? When I say epoch is equal to 100, your entire training data set is seen by the neural network 100 times to get a better idea of the data. Epochs meaning that particular data is seen by the model 100 different times. When I say seen, technically speaking, that same number is used in the neural network training 100 different times because I want to make sure I understand the data really, really well. If you just pass the data to me once and expect me to understand everything in just one go, it's not possible. I have to look at the data multiple different times to get the idea. That is epoch. Now, sir, passing and looking at the data at once when the data set size is 100 is also very hard, no? Like looking at handling with so much data at once is also hard. So I will split 100 data point into small small bite size pieces. This is one piece, this is one piece, this is one piece of data, this is one piece of data, and this is one piece of data, right? This is what you called as a batch size. So if you have 100 data points and divide it into 10 batches, each data batch will have a 10 data points. Understand what I'm trying to say? Batch size means from the entire data, take a small portion of the data and pass it to the model. You don't take an entire data set, take a batch of the data set, pass it to the model, then take the second batch, so that bite size information goes to the neural network. It does not have the responsibility to look at the entire data at once. Okay, let me explain batch size for you guys. Okay, if my data set size is 32,000, this is the training data set, and my batch size is 32. Each batch of data will be how much? How much will be the size of the batch? 1000. How many such batches will be there? How many such batches will be there? 32 batches will be there. Is the idea clear? Is the idea clear, everybody? Got the logic? Very, very good. Until here, all everyone. Okay, very nice. Okay, good. Okay. Listen to me. Can you see something called verbose equals to 1? We have to give pattern in which our model looks the data. See, when we use words, we got to make sure that they mean something. Pattern doesn't have any meaning. What pattern are you giving to the model? Model is responsible for learning the pattern. You are simply giving the data to the model in such a way which it becomes easy for the neural network to consume or utilize. So pattern may not be the right word or choice of word. We can say that we are passing the data in such a way where it becomes easy for my neural network to consume. We are nobody as human beings to pass the data. We pass the pattern. We use machine learning to understand the pattern. So there is nothing called pattern for machine learning. We don't pass anything. We are not the one passing the pattern. We are the one getting the pattern from neural network. What we do, it's just that I'm not sure if you guys like have seen a child who's just like a 5-year-old 6-year-old kids, right? If you see them eat something, they don't sometimes have the idea that okay, if I'm eating something which is not going to fit in my mouth, let me break it into 4 different pieces, right? Kids usually open a wider mouth and try to eat everything at once, which becomes harder for the kid, right? So rather, we break the food item into 4 different pieces and we give them piece by piece. That's the same logic. So rather than neural network handling everything at once, we just break it down into smaller chunks. Yeah? Good. Okay. Now verbose. Sir, what is verbose? See guys, verbose is how you are getting the print statement. Okay. I'm saying what segment of data has given or looked by our model. Model has some ways. I have a 32,000 data set example. I divide it into a batch of 32. Okay. Each batch is 1000. This data set, which is batch number 1, will go to my neural network and it will update the weight value, correct? आप ऐसा समझिए 4 रोज है, ठीक है? एज, सैलरी और सिबिल. एज है 27, Salary है 12,000, 12,000 rupees. Civil score is 750. 32, 41, 59, 59,000, 62,000, 38,000, 800, 850, 700. When I split the data into 4 batches or 2 batches, example, in batch number 1, I got 27, 1200, example. 27, 1200, 750. The batch size is also not sequential, it is random. Meaning, index number 1, index number 2, index number 3, and index number 4, correct? 4 rows of data exist. 1 and 3 goes to something called batch 1. 2 and 4 will go to batch 2. The library TensorFlow remembers the sequence or the index कि batch 1 was having how many indexes and batch 2 was having how many indexes. एब्सोल्युटली। तो क्या होता है कि टेंसरफ्लो की जो इंटरनल लाइब्रेरी होती है ना, वो इसको अपने आप हैंडल कर लेती है ताकि डेवलपर पे प्रॉब्लम और लोड ना आए। ए डेवलपर डोंट हैव टू वरी अबाउट दिस, तो इसीलिए इंटरनली दिस इज हैंडल्ड बाय द टेंसरफ्लो लाइब्रेरी इटसेल्फ। बट या ये हो जाता है हैंडल इंटरनली। फर्स्ट ऑफ ऑल, ओके, मेमोरी इन डीप लर्निंग। Okay, so let's understand this. You could have a DDR4 RAM, okay? Say 32 gigs of DDR4, DDR3 RAM, okay, in your computer. Or you can have the most weird, the most old Pentium era DDR1, DDR2 chip, no problem, okay? When you say my neural network has learned something, it has become intelligent. When you say I have learned something, what did it learn? The only thing it has learnt is my initial weight connection from node 1 to node 2 was 2. After making my knowledge or my intelligence or understanding the data, the weight value is 1.7. So the changing of the weights and the bias value from some random number to a very proper number, this makes the network intelligent. When you have a RAM, okay, there are two kinds of memory. Actually, there are multiple kind of memory. RAM, ROM, you have an internal NVSEM memory, right? So, in a given neural network, okay, memory and speed of a neural network have no connection with each other. Why do they have no connection with each other? Because when a neural network trains itself or learns better, the neural network had totally 11 parameters, 8 weight values and 3 bias values, correct? When the neural network has learned also, it has become the most smartest, the most intelligent, still the trainable parameters are 11, 8 and 3. Now, sir, where do we utilize the concept of memory or RAM? See, while my neural network is learning, there are multiple different additions, subtractions, multiplications, divisions, multiple different process that I need to run. Running for those processes, I might need RAM. So, sir, is memory dependent for a neural network? Let me explain. If you have a good RAM or a good memory, yes, taking a deeper neural network will make more sense. If you have a neural network with one input layer, one hidden layer and one output layer, so total parameters that needs to be trained are only 11. Mathematical, will be also lesser. Okay.
Yeah.
But if I take a neural network with say as the input node, correct, very good, 1000 as the input node, multiple different hidden layers,
Yeah.
and then one output layer. In
Yeah.
this situation, RAM should be higher, but there is one small problem. The problem is, sir, if my in-memory solution like RAM is higher, will this be sufficient? Actually, no. You also cannot do the operation because CPU is a sequential operator, correct? Meaning, imagine there are four people or four tasks that you want to do. After the task one is over, only then you will do task two.
Yeah.
Then you will do task three. Then you will do task four. That is why instead of relying on CPU, we rely on something called GPU. So
General
both
processing
RAM
unit.
and GPUs are required because GPU will be parallel operator, okay? At the same time, RAM will give it enough memory to operate parallelly. So speed is not affected by memory. Speed is affected by the type of core or the processing that you do. So
Okay.
GPU and speed is directly related, but GPU or speed or memory, they are not directly related because I'll tell you why. You can always reduce the size of the neural network and compress it also. It's possible very much. But yes, good question, deep question. I like this. So if you work in a company like mine, I work on A100 GPUs. I'm not sure if you have heard of this shift, but A100 is
No,
where
I'm not heard.
your chat GPT, Twitter's Grok, that's a quantum chip that they have launched. Correct. Perfect. See, tell me one thing, guys. When this model is running, I ran this particular model, correct? And I got the answer. But once you close this Google Colab, all the learning will be lost. I trained my neural network model. I ran the history. I ran this particular code. If I close this once again, I have to rerun the entire code once again. And tell me, if your data set size is 50 million data set, do you think you have the option of running it once again? So, sir, my question to you is, if I make my neural network learn something really important, can I save that intelligence? The answer is yes. Am I going to show it to you? Yes. Guys, verbose is just a way of how the entire neural network will look like, or the print statement will look like. See, if I make the verbose equal to, let me take epochs equals to 2 and verbose equals to 2. So can you see here, when I change the verbose, hasn't the print statement looked a little different? Initially, it was looking proper and nice, and now the print statement doesn't look. And if I say verbose equals to 1, my print statement looks separately. So it's how you look at the data. So my verbose or my epoch size was 150. So I am just going to run the whole thing once again. Okay. Sir, what is validation split? You guys did machine learning. In machine learning, you guys know, right, that there is something called training, testing, and there is something called validation. Validation will tell the model on specific the test data set or a specific data set what my model's accuracy is. It's not training, not testing, anything apart from that. It's a separate data set on which we do the validation or to check whether my model has done a good job. So that is what we have called or validation split. This is what validation means. Okay. Do we have to find out the optimum density or we choose randomly? No, no, no. This is random, Toby. There's no need of identifying it in the beginning or the prior. There's a smart way to figure it out, which I'm going to explain it to you right now. Don't worry. Which good question though. We figure that out very nicely. Okay. So now, guys, if you understood, we have run the machine learning model or our neural network for 150 epochs and the batch size 32. But my question to every single person is, guys, how do you accept that somebody, yes, Pallavi, I got it, my dear. You gotta give me some time to give you and get back to you how companies save intelligence. So there is no intelligence as such, but don't worry, I'll come to that question. Okay. See, listen to me carefully. Point number one, when you say, when your best friend says that, hey, I have consistently performed better in my exams, or I will prove I will consistently perform in the exam. Okay. How do you accept that claim? What will be the proof to accept that, yes, I believe now whatever you're saying is the truth. Result. Oh, thank you so much. So, from all the 5 exams that this person has been giving, his score needs to improve consistently, right? Like this. And his bad habits, the habits that he's been consistently carrying very proudly, should decrease, no? Right? So all the bad habits should decrease and all the good habits will increase. Agree? This is how you will be able to prove that, hey, I am proud of you, my friend. You have proven that you are capable of change or you are changing. Just like that, if I want to tell my neural network or I want to look at my neural network, how my neural network has performed or whether it has performed good or not, I need to test that, right? I can't just suddenly believe and say that no, 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 no. I believe my neural network is performing well. Do you think you can do this? Do you guys think you can do this? No, absolutely not. In order to get the idea clear, what do we need to do? What do we need to do? I need to validate and check whether my output is correct. So overall, on the test data set, what loss have I felt or what losses have I taken into? So model.evaluate, and inside this pass the data x comma y, since I have not split them separately. Verbose equals to 1. If you don't want to mention verbose, by default also it will be taken as 1. Print f double quotes of what is the test loss, what is the overall test loss that we got. So if I print my test loss, what answer will I get? I got the answer that the overall test loss value is this. Can you see the print statement, the one that is printed in front of you? 32 out of 32 with the green color line, 0 seconds, 3 milliseconds per step. Overall loss is 844, but the test lot average is 826.09. If I change the verbose equal to 2, is my print statement different now? It is different. If I say, okay, first of all, very, very weird. But verbose equals to t. Did it print everything else unnecessary? Unnecessary information was not printed. So verbose is the way you want the print to look like. How you want the print statement to look like. How much information of the print that you want to give about the operation. So my recommendation is give verbose specifically to tell the developer that, hey, I have used a verbose of 1. But yeah, if you don't use 0, it does nothing. Okay. So how many maximum value we have for verbose? I think more. Oh, there is more, Baba. There's more. TensorFlow verbose. I think there are so many verbose values. I think there is 1, 2, 3. Yeah, up to 2. 0, 1 and 2. There are 2 values. Verbose is 0, verbose is 1 and verbose is 2. Now tell me guys, I want to plot a graph and check whether my neural network has been doing a good job or has been doing a bad job. When you have a data set, you split the data set into training and testing. To really understand whether the model has learned, can I split the data set into training, testing, and validation data set? Nothing we do is without intentions. Nothing we do is just out of a random behavior. We don't do that. We put our brain into it because we can think. Listen to me. The reason why we take training and testing and validation is because who consumes training? Training is consumed for the model learning, correct? For the explanation of the model, for the knowledge of the model, the training data set is consumed, correct? Great. Sir, why do we use test data set? Test data set is used to test the learning, correct? Whatever my model has learned over a period of time, to test that, I use the test data set. Then what is the use of validation data set? My model, my neural network model, my machine learning model, is it working at the optimum capacity? Is it working at the most optimal capacity? How do you test that? You have used the training data, you have used the test data. You have nothing left in your model. You have nothing else left to check it, to validate it. So, what do you mean by validation? Validation will tell you multiple things. Is my model working at the optimal capacity? Am I going to be able to validate my model to, okay, testing is a different concept in English and validation is a different concept, right? When you say validate, you result it as an output. Okay, so when you validate somebody's feeling, do you acknowledge somebody's feeling? Let's say your wife comes to you and says she's upset about something and you validate her feeling. Do you acknowledge her feeling? Yes, I understand you're hurt. I understand I did some mistake. And this is the reason I understand I have made the mistake. You validate it, right? You inference, you understand, you acknowledge. In validation set in machine learning, what happens? If you want your model to perform at the optimal level, do you have any data left? No, sir. Training is over, testing is over. Validation set is like an extra test set that the model has not seen, on which you can do some extra operation that you want to do. Got it? Got the logic? Validation set is just like a test set. In fact, it is the cousin brother of test set. You can think of it like that. They are family members, but they both have not seen each other, or they both are unique. Models have never seen test set. Models have never seen validation set. Sir, why did you take validation set here? Tell me one thing. If I would not have taken validation set here, or if I would not have taken validation split, acha, let me ask you guys a very simple question. Did I not consume the data set into directly as an X and Y? So tell me, did I actually genuinely take a test set in my model? Do you see any X train, X test, Y train, Y test? No. So my validation split is my test set, right? When I mention validation split equals to 20%, 80% of my data has been used in training and 20% of it has been used in testing. Am I making myself clear? Because I did not do any training and testing split, I just very simply mentioned validation split equals to 20, which means my percentage of the data that was used for the model testing was 20%. 20% of the data set was used for testing, 80% of the data set was used for training. And if my data set is 32,000 data points, 80% of my model will be used for testing. Because I have not taken any train test split, I have said that the validation split is 20%, making it a training set. If I have 100 data points in my data set, in my actual model, okay, this is my data. If I take 70 data point for training, so can I say 70% of my data set is going to be used for training? 10% of the data will be used for testing the model. Okay, so 70 plus 10 is 80. The other 20% of the data we are taking separately. Understand one fact very clearly, first of all. Sir, why do we take the data separately? Because we do not want the data to be seen by the model at all, correct? Sir, why do we keep the secrecy of this 10% of the data and the secrecy of the 20% of the data? Because we don't want the model to see this data ever again, correct? If the model sees the data, it will become overfit or overconfident, correct? Then real testing has no meaning. Why do we use validation is, suppose you have run your linear regression model. Example, suppose you have run the linear regression model on the 70 data set and tested the model on the 10 data set, correct? Can you make your linear regression even better? Even better, if I ask you, can you make your linear regression model even better? You can say yes, you can say no, but do you have any more data left? So why will you use validation? What is the intention of validation? Other 20% will be used for to make or to optimize your algorithm to make it even better. Got the logic? Sir, how do we make it better? Tell me one thing. In linear regression or logistic regression, you give hyperparameters, right? Like, uh, okay, Okay. In decision tree, how do you split a decision tree's root node? Gini impurity, information gain, or entropy. These are the three values, right, on which you decide which root node will be split. Either it will be Gini impurity, either entropy, or either information gain. Which one is better? We don't know, right? Given data, we don't know which one is better. Already my training has been consumed by the training data set and testing has also been consumed. So tell me one thing, to optimize the answer, will you use the test data set once again? No. We can't do that, correct? So tell me, if I want to make my decision tree even better, even optimized further for hyperparameter tuning, can I take the validation data set on which my model's training will help me to calculate which data is better at splitting the decision tree for which criteria, how much deep my model should be. So rather than using the entire data set, will validation set help me? What will be the core difference between training data, testing data, and validation data? You have to really understand what is training data, testing data. Okay. Imagine every single person in the class is studying for a physics exam. Okay. All of you. Or a maths exam. Anything. Okay. Whatever you have learned for the exam, is that the training set? Whatever you have studied for your exam, whatever you could study for your exam, that entire data is your training data. Now tell me one thing, to test or to give the exam, okay, suppose you have studied something to give the exam, but before giving the final exam, don't you take multiple mock tests in between? They are like test, but they are like mock test to check how good you are performing, how optimized your results are, how better you have become. Agree, disagree? So tell me, won't validation set act as a mock test? But tell me one thing, whatever training data you have seen, if the same data will come in the mock test, won't you score 100 and 100? Validation set is like that extra special test set which you can test the model further on to make it better, to make it optimized, to go beyond a certain scope. You use validation set. First of all, remember this. It's not just validation split or validation steps. There are more. Okay, have a look at this. Validation. Can you see validation batch size, validation data, validation frequency, validation split, validation steps? Not one, but there are many. First of all, validation split is going to be a number that will tell you how to split the percentage of that data. Okay. Validation steps will tell you how many batches, how many groups will you be able to take from the pre-existing batch size again and again to make your model run. Okay, I'll explain that very carefully. How many batch sizes do I have? 32. If you take validation steps equal to 2, out of those 32, how many batches will be taken for validation at random? Half of from batch 1, half from the other two, because 16 plus 16 is 32. Got the logic? Okay, no problem. Validation split is equal to 0.20. Okay, but hyperparameter tuning Moses is a step that you have to follow certain rules, certain regulation. What you're doing right now is just sort of doing like a quick dirty work. But yes, you are in the right aspect of thinking that yes, sir, I can call this sort of like a tuning of my aspect, which is not wrong, which is absolutely correct. No doubt. Can you think of one logical reason of improving the model with a test set? Do you think you can do that? Is the responsibility of the test set to improve the model or to test the model? What is the responsibility of the test data set? If the same test data set you will use for model improvement, will your model for sure overfit? I want you to think about it for a second. When you studied for the exam and when you gave the mock test and the test in the real life, can you use before even giving mock test directly the test? Tell me this. Will directly giving the test help you in some way of understanding whether you improved or not? No. Same condition may also apply for validation. Okay, Munna, I want you to think from a logical perspective a little bit and tell me if this makes sense to you. There is a responsibility given to each individual process. Okay, sir, can I not just in the time of my examination on the test exam, I cannot, can I just run away from the class? See, of course you can do whatever you want, but there are certain regulations specified and those responsibilities are not to be violated. Same way, if I am studying for the exam, I am giving some mock test for the exam and I have taken the test data set. The test data set logically and mathematically are built for what? They are built to check whether my model or my student is the optimal learner or not. I told you in the beginning of the class that validation set and test set are kind of test set, correct? Validation is not a separate thing. It's a kind of test set, correct? But you should not use validation set for testing something. Or if you use validation for testing something, it should not be used for just testing. Only your pure test data set should be considered for whether my model has learned, your accuracy, your F1, your precision, your recall should be calculated only and only on the test set. On validation set, I can check whether my model could be further improved or not. Can I make my model's intelligence even better or not? In those conditions, only and only your validation set will be used. Otherwise, you can always confuse test set with validation set. Sir, can I not use validation test for test set? Of course you can. But internally, your machine learning library will not allow you to do that. At the end of the day, validation set is also a type of test set. सपोज मैंने 5 डेटा सेट लिए मुन्ना, ठीक है, देख जैसे ना एग्जांपल समझिए आप 1 and 2, ठीक है, age, सिबिल, salary and this example. So let me say age, salary, सिबिल and whether the person should be given loan or not, example. So 1, 2 and 3. Assume कीजिए मेरे पास 5 डेटा पॉइंट हैं, 1, 2, 3, 4, 5 and let me remove 6 1. Okay, एक मिनट, remove 6 1, 7. Okay, मेरे पास 7 data points हैं. Let me expand this, expand this, expand this. And in real life, when my model is being trained, can I say I use say majority of the data? So data point number 1, number 3, number 4, number 6 and number 7 is used for training. So 1, 2, 3, 4, 5 is used for training. To test whether my model has actually learned from this data or not, I will use model data point number 2 for testing, correct? अब validation के लिए 1, 2, 3, 4 validation split will be data point number 5, correct? My model has been trained on this training data set, no doubt about it. My model will be tested on this data set to get the accuracy, which is going to be this particular value too. Okay, good. When I want to improve my model or I want to check whether my model is doing good or not, I am not checking or improving the model by changing anything in the data. I am not changing anything in the data. Nothing in the data will be touched. I am checking that in linear regression or logistic regression, there are multiple different ways a logistic regression algorithm could be built. Let me explain. Give me 1 second. Suppose I have a decision tree algorithm. In the decision tree algorithm that I built, I could have made my decision tree split the root node based on Gini impurity, or I could have split the data on information gain, or I could have split the data on, let's say, entropy, example. Correct? Now, when I build the decision tree, which data will I use to test which particular hyperparameter helped me build the tree better. Training and validation, right? Training will be used to train the model, and this validation data set will help me build that. On the validation data set, is Gini impurity split the best, information gain split the best, or entropy split the best. At the same time, if I build my decision tree, in decision tree I have the option how much deeper I want the model tree to be built. So should I build 2 step deeper, 3 step deeper, or 4 step deeper? Can I try which step deeper also on the training data set and validation data set? Got what I'm trying to say? So, meaning the decision tree that you are building on multiple different types of decision trees or types of decision trees will be only built on the validation set, right? Not on the test. Training will be used for training and validation will be used to check which one is the best split model, correct? Okay. I have built a model where I am taking same data set, multiple different models. Listen to me carefully. Oh, right there. Okay. I have used a model called decision tree. I have taken a decision tree algorithm. To make this decision tree classifier even better, have I taken multiple different types of parameters in the decision tree classifier that first try the decision tree to split on the basis of Gini impurity, then also on entropy. The maximum depth of the tree should be 3 leaves or 3 or 5 or 7. I have multiple different data. Can you see, to train the machine learning model or to make the machine learning model find better, I have passed something called X-train and Y-train, which is my model parameter. To train a machine learning model, you do pass a train a machine learning model, right? But can you see here, I have passed something called the cross validation equals to 5. CV means cross validation, right? So what do you mean by cross validation? Cross validation means it will try and test for 5 validating set of data points. Train will be done on the training, but the validation will be done on the score of validation data points. Meaning, when I ran the algorithm, I got that the optimized answer or the neural or the decision tree that you should build should have entropy as the criteria, maximum depth could be 5, min sample leaf could be 6, and min sample split equals to 2. This result came directly from validation dataset, not test dataset. That to make my model better, only validation is used, not test. The job of test is only to print precision, recall, F1. That's why when I'm printing precision, recall, and F1, look at this. Am I comparing Y test with YPred? YPred is nothing but this X test. See? So if you have one model that has intelligence and the other model has different intelligence, is there any way to combine two models together to evaluate third type of model which is better than these two? Like the one is any way to connect ChatGPT and DeepSeek together to produce, it's called mixture of experts. So what happens is in large language models, you have something called MOE. It's called mixture of experts. What MOE or what mixture of experts does is it takes inference from multiple different types of models and it will not combine them but sort of take them as a reference. If you truly want to combine, you have to do something called model distillation, which is completely it's a different concept altogether. But yes, the answer is yes, you can do that. So validation done before testing, is there a very bad accuracy? If there's a very bad, then it is to do some change in the training data set. See, in real life scenario, if your model is not performing up to your expectation, it's not the problem of the test set or the validation set or anything else. It's the data itself. Because test data is 10%, 20%. Majority is going into training only, right? If it is not able to perform in the training itself, what can training and what can test and what can test data set do, what can validation do? So majorly it depends on the training data. Cool. So yes, import matplotlib and plt from, or import matplotlib dot pyplot as plt. Everybody listen to me carefully. Sir, I want to make sure that I want to check how my neural network performed. Okay. So plot.figure, everybody, Inside this, I will say figure size is equal to SIZE. Figure size is equal to, let me take 8,6 example. Plot dot plot, PLT dot plot, and inside this, history, HISTORY dot HISTORY, history of loss. The label that I want to put this in, LABEL, will be the training loss. This will be the training loss data. Plot dot plot, history dot history. And inside this, I will take something called as the validation loss, pretty much the same thing. And label will be equal to validation loss. So validation underscore loss, pretty much the same. And what title do we give it? Plot dot title. Let's say that the title of this plot is model over epoch, or you know what, train versus validation loss graph. Loss graph. And what I'll do is model or plot dot x label. I will pass this as the epoch that we've taken. Plot dot y label, and y label, I will say that it's the amount of loss the model has incurred. Plot dot grid, and of course I'm going to make plot dot legend also as true. And inside the grid part, let me take the alpha is equal to 0.4 example. Do you see this graph in front of you, my people, everyone? Okay, now listen to me carefully. Is my loss decreasing over a period of time? The more and more epochs I have given, the more and more the neural network has seen the data, the better the model has become, right? The loss function has decreased. Your expectation in any deep learning model is that my model and my training should decrease in its loss, and it is decreasing in the loss, everyone. The answer is yes. So, which means my model has eventually become better over a period of time because my loss function has decreased. See, on the x-axis, number of epoch, as and when the epochs have increased, my model's loss has decreased. That's why my model has become better at understanding few things. It's become better at understanding how the whole aspect of it works. Agree, disagree? Your neural network actually did perform well. And tell me one thing, didn't we just give a very simple neural network? We didn't even make it complicated. Even if the neural network is simple, it was able to understand things very easily and better. Now, guys, sir, I want to make a prediction. I want to make a prediction in the future. How do we particularly, can we see the neural network right here? So in this portion, when I used history dot loss within the history, what you're doing, whatever variable you have taken, within that you are taking specifically something called loss, and you're taking something called validation loss. That's it. That's what you've given. So this comes from TensorFlow, but we defined it. We are the one who've defined the name history. So when you look at this graph, you get the idea that over a period of time, my loss function has decreased consistently. Both my training loss and my validation loss, they are both at the same aspect. But let me ask you guys a small question. Sir, if my age or my cups of coffee is something. So for example, if I have a sample data where the cups of coffee is np.array. Inside this np.array, what was the data set like, my people? Cups of coffee and hours of sleep and travel time. Give me 1 second, copy this, paste it here. What is the cup of coffee? Hours of sleep. How many hours of sleep do you want to give, guys? How many hours of sleep do you want to give this guy now? Let's try it out. Hours of sleep will be 7, cups of coffee will be 3, and travel time will be equal to 25 minutes. Can I say it like this? If I pass in hours of sleep, right? HOURZ, hours of sleep. Cups of coffee, right? Cups of coffee, and travel time. And travel time. Sir, I want to make a prediction that for this data set, what is the answer? Can I say prediction is equal to model.predict, model.predict, and pass in your sample data? His productivity score for that day will be 46.98%. Almost 50% he will be his productivity. Got the logic, everyone? If you want to take knowledge, print the model, get the output. This is how you're going to be able to predict. That's it. I was able to predict what is the answer. Sir, what if I make the hours of cup of coffee 10, cups of coffee 6, and travel time 30 minutes? What about now? What will be his productivity score? 46.98. What if I make this 10, run it? What about now? 46.98. But sir, I changed the value. Why the model did not predict? Because tell me one thing, isn't my model's data completely random? We made the data of the model not from a proper perspective, but from a random perspective. So tell me one thing, was my intention of teaching this program to tell you how a model or a neural network works? Actually, no. The reason I taught you all of this was because I wanted to show how a basic neural network is written. Agree, disagree? The only reason I made you guys run through the entire code was to put the effort in just teaching you the concept of how a simple neural network is written. Guys, did I tell you how to take multiple hidden layers? How to take multiple nodes within the hidden layers? How do you take multiple? No, because we started with the basics of neural network yesterday, correct? And my intention was not to teach you the complicated part of neural network. We wanted to simply understand that how can a simple neural network be built? And after running this code, you must be feeling slightly better, right? That, yeah, I understand how a neural network is actually written. What steps, what values are okay for me to do? What ways I can write my neural network? At least from this perspective, you will be slightly clear, correct? Okay.
Just a quick info, guys. Intellipaat offers artificial intelligence course training, which will enable you to learn skills like neural networks, focusing on CNNs, RNNs, and their application in AI, natural language processing, computer vision, and generative AI. Through this course, you will also master deep learning concepts, AI model building with TensorFlow, transformers, BERT, GPT, LangChain, and NLP pipelines with advanced techniques like image recognition, chatbot development, and much more, all taught by top 1% experts and IIT faculty. And with this course, we have already helped thousands of professionals make successful career transitions in AI and data science. You can check out the testimonials on our Achievers channel. The link is in the description below. And without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take your first step towards the dream career growth in the field of artificial intelligence.
Now that we understood the fundamentals of artificial neural networks or ANNs and how they process information, let's move a step further into a more specialized type of neural network, the convolutional neural networks or CNN. While ANNs are great for general purpose learning, CNNs are specifically designed to handle visual data like images and videos, making them a powerful tool for computer vision tasks. In the next section, we'll understand this in detail.
Today, I am going to be talking to you guys about convolution neural networks. Remember, convolution neural networks are different architectures for neural networks. Okay? If you remember feed forward network, do you remember in feed forward network, you had an input layer, you had a hidden layer, and an output layer. The most important thing is this. When you wrote a feed forward network, you had an input layer, a hidden layer, and an output layer. Agree, disagree? And the input layer and the hidden layer are fully connected layers. So basically, every neuron is connected to every other neuron. Then here, the second neuron is also connected to every other neuron. Now the third neuron is also connected to every other neuron right there, right? And then you have this neuron connected to these two parts. Then you have these two parts. Then you have these two parts. Then you have these two parts. And finally, the output of my network. I taught you a concept that this is a small and a simple image. This image is a 6 pixel by a 6 pixel image, correct? If you can see here, 6 pixel by 6 pixel image. And this is mono channel, right? Single channel, meaning either 0 or either 1, correct? Now guys, if you ever ask me one question, sir, How do we see these colored images? This apple image that you have shown me right in front of us, how does this particular image looks like, guys? This is a 3-channel image. Okay, this is a 3-channel image. The first channel is the R channel, the G channel, and the B channel. So this is a 3-channel image. So sir, how would an image look like if I want to show apple? Like for example, if I want to show somebody, okay, how an apple is made, it will look like this. Okay. So what would happen is, let's say you would have a image which is, say for example, 900 pixel by 900 pixel example. So if I want to show a good image, 900 pixel by 900 pixel. The 900 channel by 900 pixel image will have a 3-channel. So it will look like this. This is the first channel, this is the second channel, and this is the third channel. So do you see another channel in the background and another channel in the background? So channel number 1, channel number 2. Do you see that this first thing is channel 1, second is channel 2, and third is channel 3. So basically it's like a layer. So can I say it's forming like a box, like a cube of sorts, everybody? An image is actually a cube of sorts. First layer and second layer and third layer. So basically the R channel, the green channel, and the blue channel. So when you take a color images, does it not become 900 cross 900 cross 3? This will be the size of the data available in a simple 3-channel. A 900 cross 900, because this is 900 pixel into 3 layers or 3 channels. So 900 cross 900 cross 3. Now everybody, if I multiply 900 cross 900 cross 3, what would be the answer? Would it be approximately 24 lakh 30,000? This would be the size of the data, 24 lakh 30,000. Now everybody, listen to me carefully. If you want to deal with a 3-channel image, I already know that my input layer, if I have an image of 6 pixel by 6 pixel, can somebody tell me what is the overall data in this particular image? Example 6 pixel by 6 pixel. Okay. So let me copy this image. Let me paste it here. Let me remove this and let me paste it here. Okay, let me reduce the size. So if I want to build a simple neural network, what is 6 6 what is 6 multiplied by 6? 36. So tell me, if I want to deal with an image with a feed forward network, automatically what will be the input size? How many neurons will I have to use in the input layer? 36 neurons will be used, because 0 pixel will go as the first data, this 0 pixel will go as the second neuron, this 0 pixel will go as the third neuron, and so on and so forth. So my input layer is a 36. Agree? But imagine if I had a 6 by 6 pixel image, but it is a 3-channel image. How much would the data become now? 6 multiplied by 6, 6 multiplied by 6 multiplied by 3. What will be the answer? 6 multiplied by 6. That into 3 will be 108. 108 will be the input neuron size that will have to work with the data. Now let's say, for example, if my input layer or my input neuron size is 108, then minimum to minimum, my hidden layer 1 should be at least 90. 2, 3, 4, 5, dot, 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 0, 0. So basically, at least my hidden layer 1 will be 90. So 6 multiplied by 6 multiplied by 3 multiplied by 90. What is the total value, everybody, here? Will it be approximately 9,720? Tell me one thing. to handle and work on single image. Did my feed forward network just blasted its proportions? To handle one single image, the logic, the layer, the size of the entire feed forward network just blew out of proportion. It just became large. Imagine the example I am teaching you. You have an image of 900 pixel by 900 pixel into 3 layer. It is 24 lakh 30,000. What if your input size is this and your hidden layer is also 800 neurons? So that would be 900 pixel cross 900 pixel times 3 multiplied by 800. This will be approximately 1.94 mil or maybe more than that, 10 to the power of at least 9 or 8. See, the problem here is when you work with such data, your feed forward network is not the right architecture to deal with image. And guess what, everybody? This proportion is just with single image. Imagine if you want to deal with a video. Do you think you will be able to deal with a video, let alone a single image with a feed forward network? It's not possible. We saw that a feed forward network is definitely not the right. Why? Because first of all, the size just became overwhelming even for a single image to work with. Second thing is, even after you build a neural network with such a large amount of data, even if you apply regularization, such an expensive operation regularization is, at the same time, it's not a cost effective solution. So whatever you want to do, you cannot make this feed forward network an easy operation or a simple operation. So sir, how do we solve this problem? How do I get this problem? How do I navigate this problem? The answer to the problems is KERNELS. Now you must be thinking, hey, what? What do you mean? I'm show you a piece of code. I don't want you guys to focus more on the program. I want you to focus more the output of the program. Okay. So before jumping into convolution, so see guys, imagine you are saying that you have an application called import numpy. Okay. Import numpy as np. Okay. Import matplotlib.pyplot as plt, and from pil import image because I want to deal with an image. Okay, now define a simple edge edge detection. Okay, and I will take a simple image path here. Okay, the image file will be the image that I open and inside this I'm going to convert every single image or whatever image is passed into a grayscale image. Actually, this needs to be converted to L. Okay. The image should be converted into array. So np.array, because I need to convert my image into an array, I'm going to convert this. Now kernel underscore x. Now if I want to show you a simple vertical edge detector, then np.array, the kernel would become something like this. So it would be -1, 0, 1, and put another bracket, -2, 0, 2, and then put a bracket another here. This would be -1, 0, 1. This would be my xth kernel. Now kernel underscore y is going to be again np.array. Inside this, I will have -1, -2, so this is what, 1 second, -1, 0, 1, -2, 0, 2, -1, 0, 2. So this would be -1 again. Bracket, come outside. This would become 1 second. This would become 0, 0, 0, and then this would again become 1 comma 2 comma 1. Okay, so these are my x kernels and my y kernels. Now if I want to apply them as a layer, so edges underscore x equal to np.apps, take all the pause, np.convolve, I think that's what np.convolve is. np.convolve. convolve, np.convolve, and inside this I pass in the image array. I flatten the array, make it one singular directory. Outside this, we also take the kernel X. We also flatten it. Flattening operation is done. I take a comma here. I think we also keep the mode as the same so that the application can be done. And outside we reshape everything because we want to get the whole thing back again as the image array, whichever has been passed, dot its shape. So we retain the shape. Okay. I copy the same thing. And oh yeah, it's mode, not model. Apologies. Let me copy this and paste it here. Move this here. This is going to be edges with respect to y. So with edges y, np.apps, np.convolve, image.flatten, we change the kernel x to kernel y.flatten, again image array.reshape. Okay. So we have changed every single array back. So what? Edges would become, the edges would change to np.sqrt of edges of x the whole square plus edges of y the whole square. So change that, and overall edges would then seamlessly be edges minus edges dot min divided by, if I take a bracket, edges dot max minus edges dot min. So this, okay, multiplied by overall 255 size of the channels. So plot dot figure, inside the plot dot figure size, let's say figure size should be equal to, let's take a standard 12 comma 4. I want it a little wider. And plot dot subplot, and inside this plot dot subplot, let's take this comma plot dot im show the image, sorry, plot dot image show, and inside this the original image array with also the grayscale image. So the CMap is equal to gray. So this is fine. Plot dot title, let's say that this is my original image. And let's have the axis off. So let's have the axis off, that's fine. Plot dot subplot, if I take the same exact thing, copy this here and paste it here. Let me call this particular thing 132. Image array would be what? Edges. So this would become edges. CMap is going to be gray. Edge detection. So edge detection. Plot axis is off. Let's have a tight layout here so that they don't overlap, which is going to be done. And the image path should be approximately equal to, I think this is the image, and simple edge detection will have a image path done directly. Did I make a mistake? Open image is what? Open. Oh yeah, I haven't passed the image path here. That makes sense. But yes, so it's not going to be to the power of 255. It's going to be a simple 255 image operation. So if I copy paste the image for and show you the example side by side, just for fun. Okay. If you guys are able to see this, let me expand on this and tell me if you are able to see the. I want you to observe an interesting characteristic. I am trying to move this image to, I have kind of highlighted my image, but I look like a negative image of my original image. So me in a complete black and white image, right? So this is me in a black and white image right here, right? If I look at the edge detection or just the edge, can you see here? I applied some kernels, some numbers to my original image. When I applied some kernels to my image, every single edge in my image. So for example, my neck, my face, my ears, my hairline of the, so here, all the edges are being detected, including my fingers, including my shirt's boundary. Now look at this. The edges are also available for my hand as well. My, this particular edge, the edge of the shirt, the edges of my, if you observe carefully, there's also edges of my eyes. There's a small edges of my nose as well. Can you see here? This. Now listen, tell me one thing. Isn't edge also an important information of the? This is a very simple information within the data, but is it also giving me some information within the data? But tell me one thing, to get single piece of information, did I actually work hard? Actually, no. When I wrote down the program, I had some kernels already decided. These kernels, the minute I applied these kernels, I had to do some normalization, combining the edges together, right? Here I'm combining the edges, here I'm normalizing. All I was able to do was build a simple edge detector, and if you pass any image to me, I will be able to detect any edges available in the program. Now you can, but sir, how were we able to achieve this? Like, what was the main intention behind achieving this? Guys, when do you have an operation called convolution operation, okay? Convolution operation. This is the foundation for convolutional neural networks, okay? What I'm about to do right now is I'm about to teach you an operation called convolution operation. Sir, how does a convolution operation works? Okay, I have created a small game which I always show everybody to understand convolution even better. Do you see this particular thing in? What is my input image size? Is it a, okay? And what is the size? Is it a 3 cross? You take the 3 cross, okay? This is your image. This is your image. You take a kernel, and what you do is you take the kernel and you put it in top of the image, and then you go 1 2 3 4, then down 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 1 2. So this is how the operation will look like. Okay, you are going to take a kernel and you will pass the kernel through the image. This is what it will look like. But if you observe carefully, this kernel will sit on top of the yellow highlighted box, correct? I am showing how the overlapping of the disagree. So if I take the screenshot of my input kernel and this particular image and a kernel, and if I click on next steps, do you see here, guys? 18, the first number of the value 18 is multiplied to the first value of the kernel 1. Can you see here the calculation? 18 is multiplied with 1. Let me zoom into it. Yeah. 18 is multiplied with 1. Then 138 is multiplied with 0. Can you see here? Plus 138 multiplied with 0. Plus 211 is multiplied with minus 1. 182 multiplied with 1. 133 is multiplied with 0. 107 is multiplied with minus 1. 146 is multiplied with 1. Then 222 multiplied with 0. And 14 is multiplied with minus 1. If you combine and run everything together, what is your overall answer that you got? What answer did you get? 14. Observe carefully. Now that you got the answer here, what do I do with my next operation? I move my kernel one. When I moved my kernel to the right, did I get the answer 260? I move my kernel again. Did I get 121? I move my kernel once again. Did I get the answer 1 minus 389? Then one step bottom, 182, 133, 107. If I keep repeating this operation of the kernel, what happens? Do I get an overall answer? What did I do here? I did something called point-wise multiplication. List everybody, it will make a lot of sense to all of you. If I have a data like this, 1, 2, 3, 5, 6. If I have a data that looks like this, let me copy this particular thing. Let me reset this so that the answers are completely random. Let me take my input grid, which is my input grid here. This is my input grid. Let me reduce the size of this. Let me take my kernel and let me paste my kernel here. In your mathematics, in your math, you have learned matrix multiplication by taking rows multiplied by columns, correct? You have learned matrix multiplication like this: 1, 2, 3, 1, 2, 4, 1, 1, 1. If you have a matrix like this, multiplied by another matrix, 1, 1, 1, 1, 2, 1, 1, 3, 1. So this row will be multiplied with this column. This is not matrix multiplication. This is called dot product. Sir, what is matrix multiplication? 1, 2, 3, 1 multiplied by 1, 3, 1, 2. Listen to me carefully. What is 1 multiplied by 1? Is it 1? 2 multiplied by 3, 6. 3 multiplied by 1, 3. And 1 multiplied by 2, 2. Did you understand? This is called matrix multiplication. This is also called element-wise multiplication. Element-wise multiplication. This is also called Hadamard product. What do we call this? Multiplication Hadamard product. Hadamard. Hadamard product. The symbol of Hadamard product is like this: one circle and a circle on top. This is what you call as a Hadamard product. So look at this particular thing and tell me 237 will be multiplied with the first. So 237 is multiplied with 1. 68 is gonna be multiplied with 0. So plus 68 multiplied with 0. Then 255 is multiplied with minus 1. So plus 255 multiplied with minus 1 plus 92 is multiplied with this one. So 92 multiplied with 1 plus 195 is multiplied with 0. So 195 is multiplied with 0. Then plus 10 is multiplied with minus 1. So plus 10 is multiplied with minus 1 plus 175 is multiplied with 1. So 175 multiplied with 1 plus 49 is multiplied with 0. So 49 is multiplied with 0 and 23 is multiplied with minus 1. So 23 multiplied by minus 1. If you club everything together, what answer do you get? 216. Did you get the answer 216? Everybody? Yes or no? So tell me this. Won't this kernel now, because you got the answer 216, proceed in the next step, meaning kernel going Do you see I made the kernel move one step forward? Now 237, 68 and 255 will be 68, 255, 43. Now I will move one step forward, then one step bottom, forward, 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 bottom, forward, 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 bottom, forward, forward. If I run the operation on the original image, my 6 cross 6 image just became what? What did it become? A 4 cross 4. Got what I'm trying to say? Your original image dimension just got reduced to a dimension. My original image size just became a. Listen to me carefully. I have a small question. Imagine I have a 6 cross 6 image. Is it a 6 cross 6? Is this a 6 cross 6 image? Everybody listen to me carefully. And you are applying the convolution. Do you see this symbol here, everyone? This is the symbol of what? This is the symbol of convolution operation. What is this the symbol of? When people write a symbol like this, what is this symbol? I am very good at drawing. This is the symbol of peace. This is the symbol of convolution. Remember this. When you convolve a 6 cross 6 image with a 3 cross 3 kernel, a 6 cross 6 image with a 3 cross 3 kernel, you got the output as a 4. Meaning, if I have a n cross n image and if I convolve it with a m cross m image, to make prediction on what will be the size of my output data, the formula that you have to apply is n minus m plus 1 cross n minus m plus 1. Meaning, what is n here? 6 minus what is m here? 3 plus 1 cross 6 minus 3 plus 1. So tell me guys, what is 6 minus 3? 3 plus 1, 4 cross 4. So point number 1. From now onwards, if I give you the input image size and if I give you the input kernel size, can you make the judgment what would my output data look like? Or how much will be the output of a given data? Yes or no, you can make a judgment. Now, point number 1. Sir, can my input image be of any size and my kernel be of any size? The answer is yes. Your size of the kernel also depends on you. The size of the image also depends on you. But tell me one thing. Are you going to just randomly take a kernel of any size? The answer is no. You don't do that. There is always a logic to everything and I will explain the logic. But listen to me carefully. Sir, can I take any size of the input image and any size of the kernel image? Theoretically speaking, yes, you can do this. You have no problem with it. Are we understanding? But usually what happens is kernels are usually taken as small as possible, like a 3 cross 3 kernel, because applying a small kernel is easier than applying a large kernel. So listen to me carefully. You will understand why this is the reason. But did you get the logic so far? Tell me this. If I do vertical edge detection, horizontal edge detection, my point is all these edge detection, all these kernels, are they doing two things? Reducing the size of the input data and also giving me some information about the image. Is this to the output of the convolution? Whenever I do convolution operation, my size is being decreased, so easy to handle, and some information about that image is being disagree. Now tell me one thing. This image that I have passed with the convolution operation, is it not a two-dimensional image? A black. Sir, what if my image is a 3D image or image which is 3-channel image? So will my image data look like this, everybody? This will be my image data. So tell me one thing, this convolution demo that you saw here, is it a 1D image, 2D image, or sir, this is a simple 2D image. Okay, have a look at this. Is this a 3-channel image? R channel, G channel and B channel? Everybody listen to me carefully. The kernel 1 0 minus 1, 1 0 minus 1, 1 0 minus 1. The same kernel 1 0 minus 1, 1 0 minus 1, 1 0 minus 1. Will it not be applied on each individual channel? This particular kernel will be applied on each individual channel. So if I do the convolution operation, I will combine the R channel, G channel and B channel. What is the answer? 124. Next, 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 next. Go on, go on, go on and move on until the end of the channel. So do you see that I got the result? Even if your image is a RGB channel image, the kernel will still be the same if you want to detect the edges. Tell me, if I want to detect the edge in the image, did my kernel change? No, my kernel remains the same. Whenever I want to do edge detection, my kernel remains the same. But did you guys get the idea that if I have an image which is not a single 2D image but a 3 channel image, convolution operation will still be the same. You will just apply the kernel on each. The logic will. So sir, if I want to apply the logic on a single image or a colored image, will I have to do any other operation? No. Okay. Now guys, I want you guys to listen to me very carefully because what I'm about to teach you right now is very. Imagine I have a face of a human being. Okay. Face of a human being. So let's say I have a face like this, right? Let me copy this. And wait one second. Let me, don't need much. So the facial part done. Okay. See guys, when you take a convolutional neural network, in convolution neural networks also there are layers, layers, layers. If you take the first layer is always responsible for low level feature understanding. Low level feature. Example, this is the. There are two types of edges available in this space, vertical edge and horizontal edge. Example, sir, what about vertical edge? Can I say all the black one is a vertical edge? The ear, this is the size, this is the ear, this is the vertical edge, vertical edge, vertical edge, vertical edge, also a vertical edge, vertical edge, vertical edge here. Can you guys see all the vertical edges in the data? This is also a vertical edge. Sir, what about horizontal edges? Can I say this is a horizontal edge? The eyebrow, the eye, the nostrils, the lip, the chin, the shape of this particular thing, right? The shape of slight indentations in the head. So tell me one thing, okay? If I look at the horizontal edge and the vertical edge, so I have this vertical edge detector and a horizontal edge detector. The first layer is only going to understand the lowest features like vertical edges, horizontal edges. There is also a cross edges, right? All these low level features will be understood by the first layer. When you go to the second layer, what happens? Then you start understanding even more detailed understanding about the image. So in the second layer, I actually get to know more about the data or more about the image. Example, what does an eye look like? What does an eyebrow look like? What does a nose, only and only nose looks like? What does the lower lip look like? What does the upper lip look like? And these are ears. So some high level features I get to see in layer number 2. If I take layer number 3, then I start seeing things like how does eye and eyebrow combined look together? How does nose and mouth look together? ear and eye or eyebrow look together, eye and nose look together. Are you understanding what I'm trying to say? The increase in layer that you do, or more and more layers that you do, higher the feature understanding becomes, and it becomes easier and easier and easier and easier and easier to understand. So how a convolutional neural network understands is the more layers you keep adding, the better understanding it gets about the particular image. Be it a cat, be it a dog, be it in this class, I have a now. Guys, did I not teach you that neural networks are something called universal function approximators? Do you remember I gave you the example of a water jug? If you have a ball and randomly take some data point on the ball, a neural network will be able to predict the shape that it is circled depending on the data. It can every single person. I want you to listen to me. There is something called as feature. 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 Everybody knows. Okay. If I show you the difference between a man and a woman. Okay. So let me take a man and another woman. Okay. Let's take this. Let me copy this and let me paste it here. Okay. Let me reduce the size of Angelina Jolie here very quickly and let me paste. If you look at the image of a man versus a woman, do you see some primitive differences between a man and a woman? Women's features are more softer, right? Men's features are a little bit more hard, right? All the way from the eyebrow to the eye to the nose to the lip to the size of the jaw, neck, hair, and multiple different primitive features for men versus women are different. So tell me one thing. Won't your neural network understand the pattern between what all men look like and what all women look like? This is what it is trying to approximate. So give a neural network any data and give it any differences, it will be able to approximate what those differences. It will always be able to understand the difference between, or the approximate difference between, what does a man look like and what does a woman look like, and it will try to extract global features. Is the understanding correct? Features that are the core differentiators for a man and I hope everybody got the idea of what neural network does. So don't focus too much about, oh wow, convolutional neural networks is able to give me an understanding on the face. If you apply a convolutional neural network on an image where, have you seen a bolt? Everybody, a bolt like this, not a bolt of lightning, but a bolt tool. So I'm talking about this nut and bolt. This. Imagine you have a a factory where loose bolt can be a health hazard or a death hazard. So tell me, if I show convolutional neural network a tightened bolt and a loose bolt, will it not tell me what, if I show it a new image, will it not give me whether the bolt? Tell me this. Okay, tell me this, everyone. If I am wearing a helmet, okay, if I'm riding the bike and if I'm wearing a helmet, am I wearing the helmet or am I not wearing the helmet? Can it not tell me the differentiator because it tries to understand the global? So if I say construction, okay, detection, listen to this. If I am a construction worker or I'm a worker in a factory, you will not be allowed to enter inside the factory until and unless you are wearing the helmet. Can you see? I am able to detect whether a human being has worn a helmet or not for his. I hope you are understanding what I'm trying to say. So guys, listen. If you give convolutional neural network image understanding or enough data, it will be able to extract global features and it will now tell you how it works. But convolutional neural networks work predominantly on what data? Image data. But now listen to me. Have I so far introduced the architecture to you yet? How does a convolutional layers are written? Actually, no. I will not do it at least for one more class. The reason is you just learned the concept of convolution. Agree, disagree? What does a convolution look like, or what does the convolution operation look like? To understand convolution neural networks, you also need to understand something called strides. Sir, what do you mean by strides in a convolutional network? Okay, I will teach you. You also need to understand something called padding in a image or for a data. You also need to understand something called pooling in an image data. You also need to understand an operation called flatten, which I haven't taught you yet. So to understand convolutional neural network, I just taught you the topic called convolution. You still need to understand what is striding, padding, pooling, and flattening. Once you understand all these 5 topics, we combine them together to make a convolutional neural network. Are we clear? It's not like suddenly I come to the class, teach you convolutional neural network in the air, you guys don't understand anything, and I say, congratulations, I've completed the topic. No, that's not how I teach. That's not how I will ever teach. I will take my sweet time and I will explain one by one. Okay. Once you have completed convolution, any questions in the convolution operation, anybody? Convolution operation is an element wise multiplication. It is also called Hadamard product. Okay. My question to every single person is, sir, now that I did the operation on the convolution, let me introduce the topic of something called striding. 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 Striding means jumping. Striding means jumping or leaping. L-E-A-P, leap. L-E-A-P, leap or jump. Okay. Striding means leap or jump. So tell me this. In this convolutional demo of a 6x6 image, how many jump am I making? After 128, 81 and 66, am I not making my 128, 81 and 66, my kernel is going one jump. So look at this, jump number 1, jump number 2, jump number 3. Then one towards the bottom in the column also. Can you see? After 128, I went one column down. Sorry, one row down. Again, one jump, one jump, one jump. Then again, I will go to the next column, which is 221. Jump, 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 jump. Sir, what do you mean by striding? Okay. Guys, in striding, what you do, imagine you want to jump two different jumps in the same data of whatever you gave me. Sir, I don't want to work in the same jump. I want to make a jump even more larger. So for example, okay, I believe images are better to understand. Okay, so for example, suppose my input image size is 8 cross 8 and my kernel size is a 2 cross 2, right? Okay, and let me take it like this. Actually, let me take it 3 like this. Okay. Tell me one thing, guys. Is this my original image? Okay. I'm going to show you. Okay. Guys, please keep your eyes and ears open because this is very critical for you guys. How many jump right now? But okay. 8, 2, actually 3, actually 2. Let me make it like this. And let's have a size of this. Okay. Imagine I have a kernel of 1, 2 and 3. Can I say this is my kernel size, everybody? Okay. When I have a stride, S-T-R-I-D-E, I have a stride of 1. Does that mean that my value, this particular, is going to move towards the left? Like, okay. So, can I assume that my data would look something like this? This is the first kernel operation. Then I will jump only 1. then only one, then only one, then one, then one, then one in the bottom, then one, then one, then one, then one, then one, then one in the bottom. And I can keep continuing going through the convolution operation one by one. When you want to take stride equals to 2, how many jumps will you make now? See, initially 9, 8 and 7 was the first kernel. Then if I take the stride equals to 2, then what will happen is after 9, 8, 7, I directly jump to 7, 7, 8. I skipped 2 levels. I jumped from 1 level directly to 2 level, then directly to 2 level. And because I have nothing to move forward, I will go 2 level in the bottom, then 2 level front, then 2 level here. Then I have nothing in the front, so I will jump 2 level in the bottom. So tell me, when you jump 2 level in the column, you also need to skip the if you are leaving 2 columns 9 and 8, you also need to leave 9 and 9. Your strides of jumps should be both common for row and column. Everybody, okay, have a look at this. How many strides have I given here? If you look at this data, observe one thing. What is the stride? Is it 2? Yes or no? The stride is equal to 2. The kernel size is 3. Tell me, the first value will be what? 2, 3, 5, 2, 5, 6. Okay. If I go next, did you see it jumped or skipped 2, 3 and directly went to? If I do the next step, what will it do? If I jump next, do you see it skipped 2 and 2 and directly jumped to 5? If I jump next 2, if I jump next, again it will be 6, 2, 9. And if I do next again 0, 9, 7. Then next, then next, then next. And because it has nowhere to go to the bottom or to the side, this is the out. Until here. Now tell me one thing. When guys, did you forget or did you see something awesome? And that is the outer numbers 987, 921 and 398 was only calculated. Then I strided. Then when I did striding again, the middle values are being used in the stride more. Or whenever you do kernel operation, middle values are preferred more than the values on the outside for now. Okay, please keep this in your mind for now. I'm going to come with the concept of padding, but please keep this in your mind. Okay. So, why do we use striding in CNN? What is the advantage? Sir, why should we use striding? What benefit could it have? Point. Whenever you do striding, number one, sir, why should you do striding? What is the reason behind striding? Dimensionality reduction is one of the reducing the data is going to be one of the most important concepts. It will reduce the data. Okay. Remember one thing. Sir, why should you use striding? The computation required to calculate CNN is decreased if you make the striding introduced or if you use striding in the convolutional network. Number two, if you want to downsample your original image or compress your original image, will you use? If you want to downsample the image, compress the image by some size, you will use striding. Number three, any overfitting that you see in your machine learning model, that overfitting problem can be solved using. And tell me one thing, only and only the important features will pop up after striding has been done. Are you understand? Will be done. These are the advantages. Sir, what are the disadvantages? Definitely there is information loss. 100% clarity that there is information loss. Makes sense. Now tell me one thing, okay? But if striding on a fixed number of steps, then how come only important info will be captured? Tell me. Every single kernel captures the important information. When you keep striding with the smaller strides of 2, region of interest, your region will hold the important information, right? For example, hand, eye, face, whatever your structure is, when the padding or the kernel goes through all that particular value, won't it pick up a little bit of information of the hand, the finger, the earring, the eyes, the eyebrow, whatever you want? If you increase the striding, suppose if I increase the striding by, listen to me, how many output do I get? 1, 2, 3, 4. 8 by 8 image became 2 by 2 image. Tell me, my region also increased, right? By the way, have a look at this. Look at the region of interest. Guys, isn't my region of interest also very, very large? I am picking up all the data from the region of interest. If I reduce the size of my region of interest and increase the stride, for example, my region of interest is only 3 and my stride becomes 10. Look at this. Are you understanding? My region of interest just became this much. So look at this, 1, 2, 3. If I go ahead with next step. So see, if I take my stride equals to 10 and my input kernel is 3, can I proceed forward with anything? My 10 stride cannot go forward left, cannot go forward right. This becomes my feature. So remember, information gathering also depends on the size of the stride. The larger the stride you do on a small data, the more information you will lose. The smaller the stride, larger the image. So you have to balance the stride and the region of interest also. Okay, listen. Your output image formula should be n minus f divided by s plus. So what will be your n? N will be my original image. So original image. What will be my f? F will be the kernel that I am introducing. And what will be the s? S will be the stride that you have introduced in the model. So everybody, please look at this. What is the n? Is the n 8? Everybody, let me make a life a little bit awesome. Give me 1 second. Let me take 2. Update. Yeah. Guys, my original data is a 8 by 8 data. What is the S or what is the F? What is the kernel size? Is it a 3 cross? What about the stride? How many do I want to do? 2. Remember one thing. How much will be the output if you apply this formula? The output here will be the output of the data that you're going to get. So n minus f plus s equals to 1 is equal to 3. So do you see that the output that you got for this particular, do you see here? When I applied the formula, I got the output that the output will be a 3 cross 3. Listen to me. There is a certain assumption. What assumption do we take? The kernel should always be odd by odd and it should always be same. Understanding or not? You cannot take a kernel which is 4 cross 2. Then the formula will not work. And you're not supposed to take this kernel like this also. You're not supposed to do that. Your kernel should always be odd by odd and it should always be a. If you have sorted your input kernel, your input image could be anything, your stride could be anything. This formula will work and I will be able to calculate the output. Okay, good. So you guys understood the concept of advantages and okay. Sir, why are we going to be using striding? Sir, what is the reason why we are going to be using striding? Guys, when your input dimension becomes very, very large, aren't I only interested in the useful information? Have you ever heard Elon Musk make a statement, signal over noise? Okay, what do you mean by signal over noise? Important things over useful or useless next thing. So basically, signal is what you really want in life. The good things, the decisions, the right things to do in life. Noise is just the noise that you want to ignore. So tell me, if I want to take my original data and use signal or important details from the image while reducing the size of the data, can striding be important in that case? The answer is yes. The answer is yes. So in general, human face recognition will usually be similar size kernel as compared to objects or animal images. Every kernel for any CNN operation will still be the same. You can decide the size, but people usually... Okay. What is the implication of picking an even kernel? There is no problem by taking a 4 by 4 kernel. It's just that usually the input images and output images, if the kernel density sizes are 3 by 3, they tend to work fine. But can I take 4 by 4? Yes, sir, you can. There is not much implementation or problems. You can still do it. There is no problem. Today, I will take you guys through the concept of something called padding. Then I'm going to take you through something called pooling, and then we'll try to understand what is flattened layer. Actually, I'm going to teach you what is not just flatten. I will tell you FFN plus fatten. Okay. So FFN plus FLATTEN, flatten. Let's learn it like this. The topic that I'm going to be discussing with you right now is called padding. Now guys, remember, padding is a very important technique in machine learning that is used both in natural language processing plus generative AI plus image processing. Okay, so what do you mean by padding? I'll give you guys an example from the perspective of a text first, then I will give you from the perspective of a image. So guys, imagine you guys want to analyze a text for whether that text is a positive text, whether the text is a negative text, or whether the text is a neutral text. So this is pretty much a classification problem. Okay. Suppose if somebody says, I love the movie. The other person says, I do not like it. I do not like it. It could have been better. Now, as a machine learning engineer or as a job is to make sure that you are able to explain a in a way, in a language which a computer understands really. Okay. Have 5 million such data points. I love the movie. I don't like it. It could have been better. So see, my question is, when you're passing the text to a neural network, whatever neural network you have chosen, is the length of the text varying completely? I love the movie. The length is completely different. I did not like it. It could have been better. The length is different. It was great. It is different, right? So basically, every single input of a text is a completely different varied length. But when I pass it through a neural network, I want to standardize everything, correct? I want to make sure the length of the text is one single final uniform length, correct? 150. So tell me one thing. In natural language processing, what do? We break the text into tokens, right? So I, comma, love, comma, the, comma, and movie. Did I break my sentence into multiple different tokens? I love the movie. What is the length of the text? Is the length of the text 4? Good. I break this down into a token also. I, comma, do, comma, not, like, it, could, have, been, better. What is the length of the token length? What is the token length? 1, 2, 3, 4, 5, 6, 7, 8, 9. Token length is 9. The third text is also converted to token. It was great. What is the token length? 3. What you do when you call the concept padding is when you learn the concept padding, which text is the maximum character between all three texts or in the entire data set. Please assume that this is your entire data set. Okay, this is your entire data set. In the data set, which is the highest text? 9. So what you do, every single data will be converted into a token context of how much? 9. So the first character will be I, comma love, comma the, comma movie, comma 0, comma 0, comma 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I do not like it. Could have been better. It was great. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Did you understand what I did? Whichever character or line was the maximum, I took the length of that, and every single sentence, wherever the sentence was available, I wrote that, but wherever it was not, I wrote zeros. So tell me, when the sentences were uneven, I made them even by filling them with 0. Did you understand? This is what you call as padding in natural language processing. Have you ever heard the context, or have you ever heard in the past that the GPT is able to take 1,20,000 tokens at once? Meaning, in GPT, one single question you can ask is 60,000 tokens. Agree, disagree? Have you ever heard of the concept of tokens in GPT? If you ask GPT a question, okay, so have you ever experienced this or not? GPT will only allow you to ask a question of a certain length. It will take a certain length and it will give you output in a certain length. You cannot just ask it and give it a 500-page book and ask you to revise the 500-page book. It will not have the limit. It has limitation. So the token length is particularly this token. When you say you break your sentence into individual word, each individual sentence is called as a token. Everyone, so tell me, did you understand the concept of padding in the concept of text? How do you do padding, text padding? Very good. Let's learn image padding, making you understand padding very well. I also have created a game. So tell me one thing, if you look at this particular thing, is this everybody? 1, 2, 3. If I apply padding, am I applying 0 to the end of every single corner? Can you see 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0? Now listen to me carefully. I have a small theory I want to teach, a little bit of theory I want to teach. Please understand this completely and then you will understand this is my origin. Okay. Is this, okay. Now all of you should first of all understand, sir, I understand what padding is, but why in the world are you asking us to learn padding? There must be a reason behind it. You can't be just writing down zeros randomly in the bottom and expect me to believe that it is important. Listen to me, first of all, okay? Guys, if I ask you a simple question, suppose if I have a kernel of size 4 by 4 or 2 by 2, example, okay, makes sense to you. When I do an operation of striding one by one. So 50, 100, 100, 200 will be the first number. Then 100, 150, 200, 250. Then 150, 100, 250, 200. Then this, 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 then this. If I go through it, understand one thing, guys. Listen to me carefully. This 150, 250. How many times did it repeat in the process? Like what I mean is the concept of this 150, 250 got representation how many times? Look at it, okay? So see, the kernel saw the number 150, 250 how many times? I'll tell you. So 1, 2, and then twice. So when the kernel passed through the first layer, the 150, 250, this number, this pixel got represented twice. But what about 50? Only once? So task is any number which is in the middle, especially these numbers, don't they get over-represented when the pixels pass through? And because they get over-represented, my border pixels are usually underrepresented, right? So all my border pixels, these guys are so underrepresented that my inner pixels are overrepresented and my border pixels are under. Because I want to give every single pixel enough representation, what can I do? Can I do one smart thing, everybody? Can I make 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Now tell me guys, if I now have a pixel representator, so tell me what will happen? What will happen? Because I put the border now, 0, 50 will be represented. Then 50, 100 is represented. Then again 100, 150 is represented. The problem of representation is solved in such a way that 50 and 100 that was just being represented once is now going to be represented. The border pixel will still be over-represented. Agree, disagree? This problem you can never solve. But at least the border pixel problems you now have solved. They have multiple representation, and that is one of the reasons why we use something called padding. Are you guys understanding the concept of something? So my question to me carefully. This is my original image. I am applying something called zero padding. Is my original image and padded image same? If I apply one padding, what will happen to the image? The zeros will be put to the left, to the bottom, to the right. And if you apply the padding equals to 2, can you see there are 2 layers added to the right, to the left, to the bottom. If I add a padding of 3, if I apply padding, can you see the image is being represented topic. The more padding I have, the more center my image seems to be in. If I want to do convolution neural network, to reduce my dimension, I have something called striding. To increase the dimension, I have something called padding. If I want an exact number of dimension as an output, can I smartly use striding and padding together to reduce the dimension to a... Am I making sense? So striding is the one that reduces the dimension. If you guys remember, okay, so let me take you guys, okay. Imagine my original image is what? 11, 11, correct? So I will take a 11, 11, okay, update. Is this my 11, 11 update, everybody? So see, kernel. So look at this. My original 11, 11 image, if I increase the size of kernel to 5 by 5 and update it, do you see I am doing the striding equals to 2 and making my original kernel as 3, 3. Do you see 11, 11 after striding just became a simple 5 by 5 image? this one, what happens is, the reason why we use padding is because, first of all, I want my image to be centered. I want enough information to be represented. Then using the concept of striding, I will then skip some of the topics of the zero, but still have enough representation in the middle so that I get both the representation also and I also escape the enough sizes also. And this is one of the reason why padding becomes like a simple and a very critical. Padding takes the feature in the middle so that the features get represented as much as. Okay. Now let me ask the question. Sir, why is it zero? Is able to see this? If I take my data to completely bottom, is my R, G and so tell me, if I just want to take a original image of an apple and just at the end of the day, I want to add an extra layer, the end of the day is just going to be like a dark layered background. Are you understanding? It is still considered as a pixel, but we ignore it, but it still is considered as a pixel so that the image size is also increased. At the same time, we also end up ignoring. Did you guys get the logic of something? Now carefully. MNIST dataset. I'm going to show you guys an example of something. You guys are going to like it, but please try to understand what this particular data does. Okay. So let me show you an example of, a simple data point like copy. Everybody have a look at this. Is this a number 7? Okay. Now I'm going to ask you guys, if I take a kernel of 7. So my question is, do you see black and white pixels in this? Yeah, this is more of a grayscale image, meaning one channel image, 0 to 255, correct? 0 being the darkest, 255 being the lightest, correct? Everybody knows this. This is a grayscale image. We call this as a grayscale image. Agree, disagree? Okay. If I choose this particular feature, can you see I am choosing a specific window in an image? Now guys, too serious. Okay, see, my point is to explain the topic. Now don't take me too seriously that if you take a window, why did you take only 3 by 3, why did you take only 4 by 4? Don't go with that logic, just the concept. Try to understand the concept. See, if I zoom into it like this, okay, can I say this is one, or let me reduce the size of the density of this 4 ko, let me make it 1. Can I say this is 120? This is 245, 255, 255 or sorry, actually I'm doing the reverse, right? Since this is lighter or this is darker, this is 5, this is 0 or 0, 5, 90, this is 80, this is 80, this is 255, this is 80, this is 255. Can I assume these are the pixel values for the computer to understand for that particular sizes? Because I have 90, 5, 0, 0, 80, 80, 0, 0, this. Okay. If I teach you the concept of something called pooling, P-O-O-L-I-N-G, pooling, out of this overall data, which data has a maximum number or a maximum value? 255? Out of the entire data, which image or which value has the maximum value? Maximum value is 255. What is the minimum value? Is it 0? The entire pixel information in pooling is converted to, okay, if your original data set looked like this example. So let me do an example. Suppose if I take a kernel size of if you take a kernel size of 2 by 2, okay, what is the maximum number here? 50, 100, 100, 200. Maximum number 200. Maximum number 250. Maximum number 250. Maximum number 200. So give me the array size 200, 250, 250 and 200. Did I get this output in the first go? When I went through the first layer, did I get this output? Okay, good. Next, what about now? 250, 255, 255, 250. So if I do the output layering again, the maximum number here is 250, 255, 255 and 250. Agree? Again, what is the maximum number in this pixel? It is 250, 255, 255, 250, 250, 255, 255, 250. Again, the last layer. What is the maximum value? 200, 250, 250, 200, 200, 250, 250, 200. Did you just convert 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, a 5 by 5 pixel into a 4 by 4 pixel image where you had a window size of 2 by 2 and you took only the maximum number of that entire pixel? Guys, what you did is whatever is the maximum representation in that pixel window, you have taken only that representation. This concept is called as max pooling. What pooling? What pooling did you do? This is called max pooling. Sir, what other kind of pooling will exist? There is something called max pooling. There is something called min pooling. There is also something called average pooling, meaning 50 plus 100 plus 100 plus 200 divided by 4. Guys, tell me one thing. Whichever is the most important feature in the entire pixel, rather than taking every pixel, have you decided to take only that pixel information? Only the most important information? For example, in this number 7, are you able to see very carefully that this upper value, the side value here, this lower value, are they too important for me? Are they adding any information to me? No, they are just gray. So even if I just ignore them, am I still going to get the answer 7? See, if I remove this, remove this, remove this completely, remove this in the side, remove this, remove in the bottom, remove this in the side, I am still getting the answer 7 because I know 7 is the maximum information there. Are you understanding what I'm trying to say? Pooling will take only the most important pixel and that maximum pixel you take and you get the answer. So in our example, 255 is the white pixel and 0 is the black pixel. So what will you do? You will do min pooling, correct? Because minimum number will be 0 and which will be darker. Understanding what I'm trying to say? So here I will use min pooling and here I'm using max pooling. Everybody got the concept? This is the concept called pooling. Either you can do average pooling, min pooling, max pooling. If you are scared, SCARED, scared that my 50, 100, 100 and 200 information is being lost, you can do something called average pooling. Are you understanding? If you are scared that you are losing the information for the given pixel, You take the 50 plus 100 plus 100 plus 200 and you add all the numbers together and you take the average of that data. So let me ask you a question. If I have a pixel like this, black pixel, white pixel, white pixel. So this is completely black, this is completely black, this is completely white, this is completely white. So 255, 255, 0, 0. So 0 plus 0 plus 255 plus 255. Is it going to be 127? So when you did the average pooling, did you get a gray color image, a light gray color image, which is the middle of all the 4 pixels, the center of all the pixels? This was completely black. This was completely black. This was completely white. This was completely white. Your output that you got, was it a gray color pixel? Because it was the average or no? Got the logic? So when you do average pooling, the answer will be the center value or the value which is going to be like the average. Until here, now let me ask you, tell me guys, are you able to see or understand that all techniques are like independent? It's just that when we combine everything, do you think in a convolutional neural network, whatever you guys learned, the striding, the padding, all of this will come together to make my convolutional neural network output in a specific way, like a little bit more easy, like it will make my convolutional neural network's output work in a specific way. Agree, disagree? I can make this claim that a combining these features and these techniques together can make my life a little bit more sorted. Agree? They can make my life a little bit more sorted, but there is still one problem. Everybody, there is still one problem. The problem is, let me ask you a simple. If I combine all the neural networks together, towards the end of the day, if I have a convolution neural network, or you know what, let me show you guys an example that I have created, and based on this I think you guys will be able to understand. Okay, are you able to see this particular thing in front of you? When you have an input image, okay, I will first apply convolution operation to that particular image. Why do I do this? Okay, every single time I have a convolutional neural network, I apply convolution on that particular image. Is that convolution applied to an image to understand or extract the feature from the data? Example. Listen to me carefully. Are you guys able to see this? Are you guys able to see this? Okay. Can you see 1 1 1 1 1 1 1 1 1 1 1 1 1 1? Everybody, please listen to me. I don't want you guys to go anywhere right now. Can I say every single one here is an edge? Every single one here is an edge. So listen to me. Every single operation of one here, okay? Okay, look at this. Can I say I have an image where this 1 1 1 1 1 is an edge in an image. So this is completely black. This is completely black, and this is completely black because they are 1 1 1. So this is completely white. So there is an edge in my image. So can you see there is a clear edge? Edge meaning this is an edge, right? This is an edge, like there's a line. This is an edge in the image. If I apply this vertical edge detector and apply this vertical edge detector next, do you see I got 3 3 3 3 3 3 3 in the middle? I got the answer that yes, there is an edge in the image. So when I applied the convolution layer, did I not get the answer in the feature that yes, there is an edge in the image? One side is completely black and the other side is completely white. So tell me, if I apply the convolution layer on a particular image, does it give me the feature in the data? It will reduce the dimension of the image for sure. It will definitely reduce the dimension, but the most important thing is then once the features are extracted, only the important features are extracted when I apply something called max. Once I do the convolution operation here, I take max pooling to extract the relevant features from the features extracted in the, okay. Once those important features are extracted, what is the problem? Dimension was higher here, dimension became low. The dimension was high here, dimension become low here. So can you tell me, because the dimension was low, my convolution kernel also needs to be low. So here my convolution kernel is smaller compared to the initial convolution. I apply that. But after that, do you see something called fully connected layer? Imagine everyone, imagine I want to show you something really, really awesome. Okay, I want you guys to understand, okay, completely what I'm trying to teach you. You'll get the idea. Okay, I think this is good, but they have not mentioned pooling here. Input layer, convolution layer, fully connected layer. Okay, ये भी बढ़िया है, but you guys will end up being confused. Okay, let's try to make you guys understand this. This is the reality of convolution neural. Listen to me. Image is of the size 256 pixel by 256 pixel. Is my understanding? The original image is of the size 256 pixel by 256 pixel. Is the understanding correct? Okay. Or because they have made the life very, very easy, can you see this is a 224 cross 224 cross 64 image? Okay. Do you see 224 cross 224 cross 64 in the bottom? In the bottom here? Okay. Tell me this, what do you understand? My question is very, very simple. Okay. And the question is this. This particular image that you see, is it giving you the information of the convolution layer? Great. Okay. So let me go one by one and explain it to you what exactly are we going to be doing in this case. But first of all, to understand what are we going to be doing in this case, what do you need to actually understand before you even jump into the context of this particular thing? So I have an image. Okay. I have an image. The image is a grayscale image. Agree? Observe one by one. Let's go in detail. The image that we have passed is not a multiple colored image. It's a grayscale image. The image dimensions was 224 cross 224 cross 64, correct? To make our life easy, okay, or to make our life easy, we can just say that there are multiple different available values inside this. When I apply the first convolution layer, okay, my convolution layer went with 224 cross 224 cross 64. This is my convolution layer. Then I applied another. Can you see the middle layer is the pool layer? The red color layer is the pooling layer. The red color. The minute I applied pooling on my convolution layer, the dimension became small. So tell me this, does it mean that whatever information was available or extracted by the first convolution layer, all important information now exists in my pool layer called pool 1? Every single important information I could filter out from the image is now available in my layer called pool 1 layer, correct? The eye, the face, the nose, the lips, the ear, the color, the skin, every information is available in my pool layer. Because my pool layer is smaller, can I apply a larger convolution layer? No. Whatever is the pool layer, you also need to apply convolution layer. Why convolution layer, everybody? Because this convolution layer will extract enough information from the pooling layer also. Agree, disagree? Just because the pooling layer exists doesn't mean it has all the information it is ready to give you. In neural networks, one layer is never enough for the neural network to learn. Correct or not? One layer is never enough for the neural network to learn. So what will you do? Will you apply another convolution layer? When you apply another convolution layer, you get another pool layer. Correct? On this pool layer, you apply another convolution layer, then another pooling layer, another convolution layer, another pooling layer, another convolution layer, finally the last pooling layer. So how many pooling have we done? How many max pools operation have we done? 1, 2, 3, 4, 5. 5 max pool operations were run, correct? How many convolution layers did we take? 5 convolution layers. And when you say convolution, do you see they have said convolution plus ReLU because ReLU is my activation function? I disagree. ReLU is the activation function you need towards the end. So tell me one thing. Sir, towards the end of it, can you see FC, FC6, FC7, FC8? FC6, FC7, it means fully connected. Sir, what do you mean by fully connected? Everybody listen to me carefully. Can you see the final pooling layer of 7, 7, 512? Can you see this? This 7, 7, 512 or for example 7, 7, 2. So can I call it like this? 7, 7, 2 can be written like this. Everybody listen to me please carefully. 1 and 2. So this 7, 7, 2, can it written like this? This is 7. This is 7. The width is 2. 7, 7, 2. We convert this 7, 7, 2 array, which looks like this, okay, which will look like this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. This is a 7, 7, and like that, there will be one more array in the back, correct? 7, 7 array will be there. Like I will have two arrays like that. What we do, we flatten them. F-L-A-T-T-E-N. Flatten them. Meaning, what is 7 into 7 into 2, everybody? Fast. What is 7 into 7 into 2? What is 7 into 7 into 2? If I multiply? Yes, fast. 98. What I do, I convert this 7 into 7 into 2 into one single dimension array. Meaning 1, 2, 3, 4. Totally, what will be the size of the array? 98, correct? This data you pass into a simple feed forward neural network. Then you pass it inside a hidden layer, and finally the classification will be whether the image is a dog or whether the image is a cat. Got the logic, everybody? Because initially my image was so big I could not apply the feed forward network directly. Did you make sure you pass it through multiple convolution, pooling, convolution, and made sure that the dimension becomes so small you can apply feed forward network in the data? Understanding? Because at the end of the day, my output should be whether I am a dog or whether I am a cat. So tell me, after applying multiple convolution layer, pooling layer, convolution layer, pooling layer, convolution layer, pooling layer, convolution pooling, once the dimension becomes very small, I applied a feed forward network or a fully connected network, and finally I get my output that whether the image is a cat or whether the image is a dog, and my job is done. Why do we increase dimension then reduce dimension? See, the reason why we increase dimension and decrease dimension is because sometimes if you keep decreasing, your information loss becomes very, very high, correct? So you go from 50 to 20 to 1. Do you have any chances of increasing the layer size? You don't. So Toby is, in convolution neural networks, you manipulate your image in such a way that, okay, I want to tell you this example. In India, okay, we have this thing called sugarcane. Okay, actually it's everywhere, but yeah. Don't you want to extract as much juice as you want from the sugarcane? So you take this sugarcane, you pass it through the machine once, then you pass it through the machine twice, then you pass this through the machine thrice, because I want the sugarcane to extract and give me as much juice as maximum capacity of the juice as possible. So don't you want to take an image and extract as much feature you can from the image, information from the image? So the layers you write of the convolution plus pool, convolution plus pool, convolution plus pool, convolution plus pool, these are all the layers that are extracting every single bit of the information from the image. Every single portion. But tell me one thing, if you do convolution plus pooling, are you going to go through something called information loss? You will go through the concept of information loss. Now everybody listen to me carefully. My question is very simple. Input image is a two-dimensional image or three-dimensional image? So let's not call it 2D and 3D. Let's call it two-channel image or a three-channel image. So the image could be either a two-channel image or three-channel image. So we can call it as a three-channel image also. So if it is a three-channel image, okay, then you need to make sure that the image is either converted into grayscale so that the dimension or the processing is decreased. Otherwise, you can convert it into normal color image and you can do the processing, but it's gonna take a lot of time. Okay, this is something I can tell you right now. It can take a lot of time. Okay, anyways, my question is, can you not smartly introduce the concept of striding in this also? If the image size is larger, I suddenly want to decrease the dimension to a very small size. Can I not implement something called striding, then pooling, then something called ReLU activation function, and then convolution operation, right? So let me say convolution and then pooling, sorry. So are you understanding what I'm trying to say? I can first implement striding, reduce the dimension, apply convolution, ReLU activation function, pooling, and now I have a very small data. Agree? I will do this only when I want the layers to be either one, maximum two. If I want to bake a cake, there is a sequence of steps you have to follow. You cannot skip the sequence of steps, otherwise you don't have a cake in your hand, you have something that can give people food poisoning. Convolution and then pooling. The reverse is not allowed. Going to make sense, or can reverse be allowed? Okay, so simple question, listen to me. I can say that first I am going through something called convolution layer, or if I say I will do pooling, then I will do convolution, which should not be allowed from the logical perspective. Tell me, shouldn't convolution layer come first and then only the pooling should happen first? So tell me one thing, if I have the original image, listen to me carefully, this is my OG image, my original image. What other operation after OG image are allowed? Can I? Is it going to be allowed? The answer is yes. You can. Why? WHY. Why? To reduce dimension and only pick up important feature. Can I do striding? Yes. Why? Because to reduce the dimension and input feature or important features only that could. Now next number 2. Sir, can you apply convolution layer after striding? Can you apply convolution layer? Yes, you can. Okay. Sir, can I only apply convolution plus pooling? Yes, you can. Sir, can I apply pooling plus striding plus convolution? No, you can't, because you cannot pool in the beginning without striding or without convolution. Are you guys understanding what I'm trying to say? So either striding is allowed, either convolution layers are allowed, but you cannot skip them in the order. Your order cannot be different like that. Okay. Sir, can I apply striding plus convolution plus pooling will be layer number 1 plus striding plus convolution plus pooling will be layer number 2 plus striding plus convolution plus pooling will be layer number 3. Now let's come to the topic. How many layers to take? How many layers to take? And how to take those layers? Who is responsible for this architecture building? YOU. I cannot tell you when to use striding, when not to use striding. Yes or no, guys? If I tell you in this class right now that use striding in XYZ condition, don't use striding in the XYZ condition. Do I have a rule book in machine learning or convolution when to use striding, when not to use striding? It will depend on the goal of your project, guys. I can't make the claim right now. Either you don't want to do striding, do convolution plus pooling plus convolution plus pooling plus striding plus convolution plus pooling. This is also one architecture you can build. Agree, disagree? You let the convolution plus pooling happen. You let the convolution plus pooling happen, and suddenly to decrease the dimension completely, you did striding plus convolution plus pooling. This is also allowed, right? Or you could do striding plus convolution plus pooling plus convolution plus pooling plus convolution plus pooling. Are you guys understanding what I'm trying to say? The architecture type that you guys go through, that is taken, or that decision is taken based on the architecture of how we want to build. My question is this, sir, I did not use any striding. I did convolution plus pooling and convolution plus pooling plus convolution plus pooling. Sir, will I get the right answer? The answer is yes. Because convolution neural networks are not very much affected by the size of the layers or number of layers. They are not very deeply affected. So convolution neural networks will at the end of the day end up working absolutely best with the least amount of data or resources that you give also. Understanding? Even if you give it a little, it will give you the maximum impact. So you can try multiple times and it will make your life very, very easy. Are you understanding? Okay. Sir, all this knowledge is important, but I think the world works on practical understanding, correct? The world works on practical understanding. So if I give you guys a small practical understanding, you guys will get the knowledge on, okay, now I understand how do I need to write. Agree? You remember I taught you feed forward network in the last class where I taught you hyperparameter tuning and whatnot. We did so many crazy amount of stuff. So now I'm going to teach you something called convolutional neural networks in a practical setting. Okay. Can you give us a real world CNN application where we see this in everyday life? Absolutely correct. Have you ever seen VAC signal in your area? I'm not sure if you know this, but in Karnataka, we have a signal, or in our state, right, which is one of the most sort of amazing state. Do you see the signal has something called VAC? Yeah, okay. So guys, this thing called VAC is actually called vehicle actuated control. Okay, what that means is, imagine you have a road and this is the traffic signal. If the density of the cars are larger, meaning one of the car is here and the other car is here and there is multiple traffic, the signal will go between 30 seconds to it will go from 1 minute to 2 minutes. And if this traffic signal density is lesser, the signal will be left early. Are you understanding what I'm trying to say? So in Karnataka, specifically in Bangalore, you don't need a human to divert the traffic. It is done by the AI. There is a camera. The camera monitors how many traffic system exist, including VIPs or VVIPs, including politicians. Only and only one maximum police car is in the front, one is in the back, and the entire traffic signal is derivated or derived or handled all by AI, and the AI name is called Netra. In Hindi or Sanskrit, Netra means eyes. So this uses convolution neural networks to measure the density of the car. How many cars exist? I'm going to show you guys an example, okay? Vehicle density GIF. Do you see that I have vehicle density detection CNN? Are you able to understand the amount of traffic in the car? Can you see here? The amount of car, the density of the car that is available in a traffic signal. Look at this. I am measuring each individual truck, car, and the density of that particular thing available in a traffic signal. All these are done using CNNs. And guys, these are so simple to build, so easy to build. I can't. So these are all the practical implementation of example for you right now. Okay. The question is, sir, can we use both pooling and striding together? It will cause information loss 100%. But the question should be, sir, what kind of information loss? Okay. What kind of information loss? Okay. I'll give you guys a small idea. Okay. A small understanding. Have you ever heard of a concept called do you know what happens in a QR code? So I'll give you an idea. Okay. So give me 1 second. Okay. Let's say, for example, just for simplicity purpose, let me show you an example. Okay. Let me copy this and let me paste it here. Okay. Is this visible, everybody? Okay. Do you guys see that this, and do you see a small circle white here? Okay. Now let me tell you how beautiful is technology and how they are connected with each other. Do you know that every single QR code built in this planet will always have these 4 squares? These are called alignment boxes or alignment checks, meaning if your QR code is ulta, rotated by 180 degrees. So for example, suppose if you take a QR code, rotate it like this, rotate it completely 180 degree, or like this, or it is in any other orientation, I know where to start reading it from. QR code is read from the bottom. It goes like this, from bottom to top, then down, then up, then down, then up, then down, and then up. Now let me tell you one thing. Even if the QR code is destroyed, meaning this portion of the information I don't have, this I don't have, and this I don't have. Even if that happens, QR code can be read because there is something called error correction, correct? Meaning, try doing this. Sometimes when you take a QR code and scratch the QR code, you will still be able to read the code. Now tell me one thing, error correction. Meaning, if there is an exist or error in the QR code, you can still correct the error. Meaning, my QR code can still function without a certain amount of information not being present in the data. Meaning, information loss happens for sure, but I can correct my information loss. Agree? My information loss existed, or my error or my QR code was not complete, but I was able to correct it. So keeping this in mind, remember, mathematically speaking, we can always correct our codes. So sir, when we have an information loss, does it mean I am losing the important information or irrelevant information? Let's talk about that. When we do pooling, everybody listen to me carefully. When we do pooling, what kind of information do we lose? Actually, we lose the information of the data which is not relevant for my calculation or which is not relevant to my detail. Meaning, suppose if I have a number 25, 26, 100, 150, when I did max pooling, did I not take 150? Why did I take 150? Because every neighboring pixel is going to be related to this 150. That is my understanding, correct? My pixel 150 will be nearest to 26. Okay, I'll give you a much better idea. I'll give you a much cleaner, much better idea what I'm trying to say. Okay, see, before you are trying to reach, oh, Control Z, give me 1 second. Before you are trying to reach the number 7 here, where is it? Where is it? Okay. Before you're trying to reach number 7 or the number 7 itself, do you see the numbers or the pixels become more grayish first? First they become more grayish, then they start being more darker, and then the darkest. So first initially they start becoming a little bit light grayish, a little bit dark grayish, and the darkest. Then again light grayish, and then completely white. Can you see the transition of pixels? When any information about the eye, suppose if I want to calculate the human eye, the edges will always start with a little lighter pixels, right? When the eye is to be extracted, my pixels become a little bit lighter, then darker, then with the information and lighter. So if I take just the maximum information, I skip the nonsense and go to the darkest first, correct? I don't take this as my information. I go with the darkest first, right? Okay. So when you do pooling, the intention is I am interested in taking what? I am interested in taking only the relevant information. So can I say relevant information extraction is what a pooling would do? Am I making sense, everybody? Because only 1 or 2 guys are responding and I don't know if you guys got the concept or not. You guys got the concept until here, okay. But when you do striding, does striding care relevant and not relevant? Or its job is to just jump from 1 to 2, 2 to 4, 4 to 8, again in the bottom jump 2, then 4, then 6, then 8. Agree, disagree? So when you implement striding, your job is not of information loss, your job more is dimensionality reduction. I want information to exist, no problem about that. But I want the size of the data to be miniaturized as much as possible. Am I making sense? Now, if you use pooling plus striding together, do you have to be careful about what is it your outcome that you want? What kind of an outcome do you want? When you do pooling, important information came. But the minute you do striding, aren't you negating the concept of pooling? Aren't you took pooling to take relevant information, and now striding when you're doing, you just want to do dimensionality reduction. That means you want to take important information, but that important information, you suddenly want to decrease it to a very small size. Agree, disagree? So can I say that, okay, based on your sentence, can I say that it will completely depend on my goal? If I want my layers to be lesser and I want my output to be faster, I can just take 1 or 2 max pool layer and then suddenly do striding to very much reduce it so that feed forward network can come in. Agree? Make sense? But let me ask you a question. I told you this in the beginning of the class. The more convolution layers you have, the better is the understanding of the feature, deeper you go, correct? Initial convolution layer will be able to pick up only basic features. But by the time you go towards the end of the layer, this layer will have a very deep understanding of the feature because each layer also acts as a filter. Is my understanding correct? So from all the initial data, my last layer has the most important understanding of which feature is important in the image. I hope you guys got the thing is, you guys forgot one very important thing. Guys, haven't you all learned the concept of supervised learning and unsupervised? Guys, if you want to identify whether something is a dog or a cat, you also forgot that that image will also have a label. No, dog. This image cat. This image dog. This image cat. Yes or no? So tell me one thing. For every single image of dog that I take, I also have a reference why. So the last layer of my convolutional neural network, isn't it going to tell me that every single dog that was labeled as a dog had a feature where there, and for every single picture that was human, no tail. So tell me, we got involved in convolutional neural networks so much that we forgot to understand that this last layer can always be mapped back to the original value, which is whether it is a dog or a cat. And this can better help me understand that every dog will have a tail and every human will not have a tail. Yes or no? That's how the neural network learns, right? To compare and understand. Oh, now I understand. So actually, convolutional neural networks will work how exactly? When the image is passed, the first image of the data is passed in the layer. Tell me, it will make a prediction. No, I think it is a cat, but originally it was a dog. The actual label is a dog. You say it is a cat. Won't you do back? Relearn the last layers understanding even better. And when you do back propagation and forward propagation again, won't you do convolution again, pooling again, convolution again, pooling again, convolution again, and whole thing changes and you get the idea. I hope you guys are understanding what I'm trying to say. That we got so much into the detail of convolution neural networks that we forgot that there is of course a back propagation that happens and a forward propagation that. And let me ask you a question, everybody. Do you remember I told you that there is something called as a kernel in the convolutional neural network? And you guys asked me, sir, how did the mathematicians and scientists came up with the kernels? Can I tell you something very. Do you know that in feed forward neural network, what are we trying to optimize? Aren't we trying to get the best possible weight values and best possible bias? The best possible weight values and the best possible bias values in convolutional neural network. When you have the image and when you do the convolution operation, the kernel is randomly initialized. Meaning the kernel does not initialize itself with 1 comma 0 comma minus 1 1 comma 0 comma minus 1 1 comma 0 comma minus 1. No, the kernel is initialized completely randomly, meaning 10286 minus 1231. Doing forward propagation and backward propagation, forward propagation and backward propagation, each individual convolution layers kernel number becomes better and better and better. Eventually we come up with the most optimized kernel that can identify the eye, the face, the lip and the mouth, and now I am able to see whether it is a dog or whether it is a cat. Understood? Meaning you've just taught the convolutional neural network how to identify the eye, the weight, the lip, the face and the tail. Got it? Meaning the first kernel will be able to identify all the color or the fur of the dog. Then the next will be to identify the shape of the dog. The third kernel will automatically identify the face, the lip, and the fourth kernel, the overall dog. This is why convolution neural. So unlike feed forward neural network, convolutional neural network optimize for the values of the kernel in each individual convolution layer. And because the design of the neural network is built in such a way that in layer number 1, only the basic information will be given. Everybody listen to me carefully. In layer number 1, only the basic information can come because you have just applied the first layer of convolution on the initial image, correct? So tell me, when I optimize or calculate the values of the kernels, won't they be very, very basic? Because you are in the first, and the more deeper you go in the layer, that kernel needs to be even more deeply optimized because this kernel has more information to be. Let me ask you guys a question, okay? Give me 1 second. What was the name of the people who left the company? I forgot the name of this guy. I am so sorry. It's not Sebastian Raschka. It's Andrej Karpathy. Okay. Andrej Karpathy. Give me 1 second. Andrej Karpathy, RNN Visualizer. Okay. Visualizer. Okay. Give me 1 second, guys. I'm going to show you something awesome. Give me 1 second. Okay. Okay. Have a look at this, everyone. Have a look at, I'm going to show you something really, really awesome. You guys are going to love this. What was the name of his CNN layer, CNN layer visualization. Okay, CNN explainer. Okay, give me 1 second, guys. Just a second. Okay, I promise I will explain it to you in a much more detailed way. Okay. Okay. All right. Are you guys able to see this particular GIF? I'm going to zoom into it a little bit. Okay. Do you see that each individual layer is able to represent what information? See, these are all the kernel. Okay. This kernel is able to understand the overall edge of the thing. So can you see this is the edge layer visualizer? Or if I can show you, yeah. Can you see here? This is my input image. This is the kernel and my output is this. This is my input layer, my convolution kernel and my convolution operation, and this is my output. Okay. Do you see that the kernel values are changing? From 0.11 to some values they are changing. In some possible number, I am getting the best edge detection. Yes or no? If I randomly put a kernel, no edge detection. If I slightly make it a little better, the edge is better. If I make it the best, is the edge just the best? I am able to very clearly see the edge. Understanding? Go down. So can you tell me, will this not be the first visualizer of the layer? My first layer will be a very glorified edge detector. Make sense? If I scroll to the bottom, right, look at this. Input size is equal to 7 by 7. Padding equals to 2. Okay, let me say my padding is equal to 2. Okay, padding is equal to 2. My kernel size is 2, my striding is 2. Are you able to see how the output and the values are going? My kernel size is 3 and 4. How about now? 2, 3, 4, 5, 6. I have already taught you this. Right? I increase my stride, my data becomes smaller. I decrease the stride, my data becomes bigger. Okay, let me. I can take a better one also, right? 3D visualization of a 3D neural network. Okay, so let me make you understand it. Can you see that my initial layer is only able to identify the edges 4, 4, 4, 4, and 4. I did a convolution operation again and I did pooling. Can you see the pool operation making any sense here? Any pool operation, is it making any sense? Is it looking like the number 4 itself? That's not how the pooling operation saves the data. But can you see, I have flattened my layer. See, every pooled layer output is flattened and I flatten it, pass it to the feed forward network, and the probability the neuron says is, the possibility is this a number 4. Let me erase. Suppose if I say the number 3, okay, if I say the number 3, have a look at the way the neural network is going to function, okay. Look at it. Can you see still, including the aspect, my first layer is a simple glorified edge detector. He's only taken one layer. Can you see? Then once I do the pooling and my pooling operation is done, I am able to see the probability of the number 3 pop up even better. And these highlighted box are the reason why the number 3 is the reason my number 3 is predicted, because all the blue boxes, all the boxes that are bright are the reason why number 3 is predicted as. Are you guys understanding? This guy has only done one layer, only one layer. See, input layer, input convolution layer, then again a pooled layer and a second pooled layer and a flattened layer. He's taken two simple pooling operations, consecutive two pooling operations. So can you see here? The point I'm trying to explain is every single time you do a convolutional neural network, remember one thing, is it comparing with test data here? Yeah, it is a test data. So the output that you get from a CNN visualizer is actually trained on a MNIST data set. We have a data set given to us by a company that created handwritten for millions of records. I think they have 60,000 plus examples. This is the data set. So what they've done is they have taken every single human way of writing 1, 2, 3, 4, 5, 6, 7, 8, 9, and we can then recognize whether that particular data can be we can predict whether data can be done or not. The problem here is the number or the number written is very low dimensional. Can you see that the image of number 7 is a 28 by 28 pixel? Agree? It's a 28 by 28 pixel, meaning the quality of the data is terrible. But guys, even with this terrible data, even with this terrible input data, let me do this. I will teach you how to take a picture on your phone and recognize whether the number is 8 or 9 or 7 or 1 or 2. How about this? See, let me tell you the challenge. Everybody, let's do this. The challenge is your photo from the phone. Isn't it a 1080 by 1080 pixel image, or it's a 1080 pixel image, high dimensional, high resolution image? Your input training data is a 27 pixel by 27 pixel image. Agree? What if I teach you a practical way of taking a photo from your phone and recognizing whether the digit is 7, 3, 2 or 1? How about this? This is a very practical challenge, everybody. It's not a very easy thing to build. But let's build this so that we understand how exactly are we able to identify a number which is a low dimensional, low level data for a high level, high dimensional image to recognize whether the number is 1, 2, 4, 6 or 8. Cool? Are we clear? Sir, is there a traffic data set? Yes, there is also a traffic data set, traffic image data set. So we have a data set or a road vehicular data set analysis. We have a data set here. So can you see here traffic data? Everyone. You have data for every single thing. If time is over, let me teach you a very practical example of how do we take a picture from a phone and recognize from that particular picture the given image what kind of number it is, even though the data that we get is going to be low dimensional. We are going to be implementing a convolutional neural network to solve a problem, and exactly how it works, I'm going to show you the best of it. Are we clear, everyone? This will give you guys the most practical idea how to implement a CNN in your life. But please remember one thing, guys. All the effort that is gonna be proven at the end of the day is actually not mine, but it actually is yours. Perfect. All right, guys, time right here. Okay. So if you can see here in the striding, what happens, you end up taking a kernel size. Okay. Now remember one thing, whatever kernel size you want to take or your preferences, right? Convolution is something you control. Striding is something you control. Padding is something you control, and pooling is something you control. So basically, as a data scientist, you have a control over all of this. And in the last layer, we have something called feed forward network, or basically flatten the array. So 3D array, 2D array, any nth dimensional array is converted to a one-dimensional list, and that list we pass inside a feed-forward network. That is what we call flatten. Pooling is basically having an entire image. For example, this is the image. I have a kernel size of 3 by 3. So when the kernel of 3 by 3 is put on a specific image, whichever number is the maximum, that number we pool, and we call that particular thing as max pooling. Okay. Now guys, remember, these are some of the topics that you guys need to keep in your mind. These are some of the topics that we will be actually utilizing or using when we are going to be working on my neural network. But that's not what's interesting to me. What's interesting to me is I want everyone to understand this. First of all, I will give you some rules, some guidelines that I want all of you to follow. If you follow these guidelines really, really well, I don't think you will ever have a problem writing any neural network. In case, if you ever want to deal with an image, definitely you will never have a problem. Number one, let me ask you guys a small question. Any image on this planet, if it is given to me, can be either a single channel image or a mono channel image, or it can be a 3-channel image. Everybody knows this for a fact. There is no 2-channel image. Remember this. There is no 2-channel image. Including your black and white images are either mono channel or 3-channel. Okay, remember that you can manipulate these channels mathematically, but I'm giving you guys a very simple idea. I don't want to confuse you guys even more. Remember this. You guys will be given an image with the X dimension, with a Y dimension, and the number of channel that particular image can. Now, once you have understood what kind of data you're going to feed inside the image, if your job is a classification job, which majority of the jobs, okay, in neural networks, in image classification, it's basically classification. But guys, I want to give you guys a small idea. This is not to confuse you. This is not to give you guys a little bit of surprise, but I'm going to tell you guys a little something which is kind of critical for everything. Okay. So there is something called object segmentation. Okay. Or let me just write segmentation. Okay. See, one of the main advantage of using machine learning, specifically deep learning in an image, is something called as segmentation. Now, what do you mean by segmentation? Guys, if you have, and from this image, you want to separate the cars with a proper, you want to separate the human beings with a separate boundary, and you want to separate every single thing given in the image separately, we call this operation as segmentation. So for once, don't even think that image classification is the only task in learning. The best model that we have right now is something called segment anything now. Okay. This segment anything model was built by Meta, or which was known as AI, Facebook. They have built something called SAM. It's called segment anything model. This model is the most advanced segment anything model we have on our planet. Okay. The reason I say this is the most advanced is because this does something called point-to-point reference localization. Okay. What it means is, if you have an image, okay, say a frog, and you want to very clearly borderline the frog and segment it, remove it, and replace it with something else, guess what? SAM, or segment anything now model by the AI research done by Meta, is the best model that you have anything right now. Okay. This is one of the things. You also have something called object detection. Okay. So object detection is also one of the major applications that you will be seeing in a classification tasks, where what would happen is, in object detection, you don't care about the entire environment. You only care about one specific person or maybe two specific guidelines. For example, in the entire image, I only want to detect human beings, okay, or maybe vehicle. So if you remember, object detection will tell you with a bounding region. By the way, this green color bounding region is called ROI, not return on investment, but region of interest. So you can also build an image classification or an image processing model to object detection, to segment anything models. There are multiple different use cases of image processing, specifically with convolutional neural networks. Okay. One of the ways that we are going to be dealing with images is where you are going to be doing something called image classification. Now, the reason I had to teach you all of that is because remember one thing, as you guys have learned that there are topics of supervised learning, unsupervised learning, reinforcement learning, right? There are multiple different categorization in machine learning. Remember one thing, the one that we will be doing is every single image will be given a label. So suppose I have an image where a number 7 is written, the label for that image will be 7. To help machine learning or a deep learning network understand that this image is nothing but a number 7. Okay, so the very first thing I want to introduce you to all is a very simple topic, right? Sir, how do we get started with the concept of convolutional neural networks and what is it that we are going to be doing in this class? So the very first thing every single person knows is we actually have to import TensorFlow because this becomes very, very critical. So I'm going to be importing TensorFlow STF. I'm sure nobody will have a question so far because without importing TensorFlow, writing down any model or any implementation of a deep network is kind of impossible because I need something very, very important. Okay, from TensorFlow, from TensorFlow, I also need from TensorFlow, I also would need something called .keras, which is a submodule, and I'm going to be importing two things. One is called layers, because guess what? One of the most important thing in writing down a neural network is actually importing a concept called layers and using something called models. And I'm also going to be importing something called callbacks. I hope you already know. In the last class, I taught you the concept of something called callbacks. You already know that when a neural network fails to perform consistently, either it improves or either it decreases but remains consistent throughout, then I might use the concept of callbacks. Now what do? Import numpy as np. This is like the most important package that I might need, right? I might also need import matplotlib.pyplot as plt because I want to plot certain things for me, right? Now, these are my import statements. These are the libraries I know that I might need when it comes to working with machine learning or deep learning use cases. Now guys, of course you guys know that we are going to be working with something called MNIST dataset. Okay, this dataset was created long ago where multiple different humans handwritings were analyzed, and we wanted a challenge where computers could kind of understand what these handwritings are, and we wanted to understand whether we can or a computer can identify handwritings as well. So what I'm going to do, I'm going to write down this boundary condition or this tuple value, and I'm going to say train underscore images, comma, let me do it like this. Rather than teaching it to you like this, let me give you guys an idea like this. When you work with a normal machine learning use case, imagine when you work with a simple machine learning based use case. Have you not ever been used to the fact of working with CSV files? Loading the CSV files, uploading the CSV files and then loading it, right? Okay, remember one thing. You don't actually have to do this every single time. The reason you don't have to do this every single time is because what happens is in TensorFlow or while working with TensorFlow, you are going to find that TensorFlow provides some data sets for you just to make your life very, very easy. So we are not going to load any CSV file directly. What I'm going to say is tf.keras, and inside the keras, there is a submodule called datasets. If you write .mnist, and inside this, there is a submodule or a method called .loadData. Now remember one thing guys, you cannot just load the dataset directly here because if you do this, what's going to happen? It's going to load into this nonsensical numbers which are not going to make sense to me. Okay, it's just going to load the data with some numbers which are not easily read by a human being. So what you need to do is, because you know that MNIST dataset is nothing but image plus its label. So it will also give you an image and it will also give you the label. Now guys, my question to every single person is this. When I say image, when I mention the word image, I want all of you to understand that at the end of the day, I will get an array, correct or not? Because an image can be represented as an array. So tell me one thing. I want to split my data into two different sections. Okay. Look at me writing down two different brackets here. And inside this brackets, I'm mentioning a very simple thing. What am I saying? I am saying that can you please help me load train underscore images or images, and whatever the train images are, can you also give me their labels? So what did I do here? TensorFlow's Keras' dataset model automatically gives me a certain section of train images with the train labels. And what do I do next apart from train images? Do I copy the whole thing? Because I have the train image, I also need something called as a test image. And I also need something called test labels. Does that make sense? So when I load data like this, what is going to happen? The data set is going to be loaded in my cell, which is cell number 3. Let me zoom into it a little bit. It's going to load a specific kind of information to my cell number 3, and my train images and my train labels are given. My test images and test labels are given. Now you must be thinking, sir, what if I want to specifically decide how much training I want, how much testing I want to give? Don't worry. Programming is so easy that you can change whatever you want at whatever instance you want to do that. Thank you so much, Samrat. By default, what happens in MNIST datasets, train images and test images, it loads 60,000 for a training dataset and 10,000 for test dataset. But you can change this particular load instance. There is a method in tf.keras datasets to load the data at a specific interval. Okay, meaning, sir, I don't want a specific image to be loaded with whatever the default value you have given me. But sir, maybe I am preferring it to load for, I don't know, like can I load it for 80% for training and maybe 20% for testing? Sir, what would I do, or what changes would I make in this code? Okay. What changes would I make in this code? And sir, would it allow me to make any specific change or any kind of values that I can maybe tell this particular information or tell this data that I want to do a split of it? In case if you want to not follow this particular label, you can either do a train test split method where you load the data directly with the MNIST method, but this time the MNIST methods are just the MNIST method, but we are not worried about that. Let's say I prefer going ahead with the default value of the train data and the test data. I want as much as possible for training and I want as little as possible for testing. That is my intention. But the most important thing I want all of you to remember is whenever you work with an image or whenever you work with a text, I'm very sure you all must have heard of the concept called normalization, right? Normalization is this particular process, right? Do you remember the concept called normalization, not in the database perspective, but from the perspective of uh, the mathematical concept that we've learned, right? I'm going to write down a piece of code called normalization, okay? Normalization of the pixel values. Now, what do you mean by normalization of pixel values? Because my number of pixels are between the range of 0 to 255. What does that do for your computer or for a calculative machine like a computer? Am I giving a range between 0 to 255? Any machine learning program is not comfortable with ranges. I hope you guys know this. In machine learning, while working with decision tree or random forest, you must have been taught that if you take multiple different features and each feature is a own range, like age is a number between 18 to 30. If your salary is a number between 45,000 to 2 crore rupees, so when you pass it to a machine learning model, it does not perform well because it does not know how to converge a neural network. So tell me, in case if I want to do that, I will take the train images will be equal to, the most important thing here is the train image that I'm going to be taking, I'm not going to be taking them directly. I'm going to be converting them into an as type model or convert them into a data type of float 32. Now, every single person knows what float 32 is a. What do you mean by the term data type? And what do you mean by the term 32? I hope everyone is comfortable with the fact 32 is a bit representation of the image or the data. It's a bit representation of that particular data. If I divide the whole operation by 255, what does that? Is that going to change my operation for images between a number 0 and 1? Because normalization is an operation that converts a number between a specific range. If I'm doing it for the train images, what is it that I do for? Like, what is it that make the whole process exciting? I also do it for something called as test images. So if I just take train images, copy the whole thing and paste it here and just convert it for test images. What is it? Okay, let's also train this as test images. So tell me, what am I doing here? Is my operation slightly complicated? Actually, no. I am actually normalizing every single image because it is going to give me a standard value between 0 and 1 and it's going to make my process very, very easy. Now, sir, once I have loaded the data set, I have normalized everything. I really need to know what is that next process that I'm really thinking about. See guys, I am a big fan of visualization. Okay. Visualization is going to help me make a better understanding of how exactly is my data loaded. In case if I want to visualize some samples. Okay. This is normalized value, right? Yes. This is going to give me a normalized output. Because when I divide it by, rather than going with the concept of x min minus x max, I don't have a column to compare x min minus x max. So what you do in an image, the formula becomes just by the overall value. Okay. So again, basics. Let's go back to basics. Let's say I have a column called age. Let's say I have a column called salary. When I say age, can I say 18, 32, 21 and 33? Can I say this is the age? I have 4 data points. I'm going to take the formula of my normalization formula and copy this and paste it here. Okay. What is the value of x? Is it 18? Minus between 18, 32, 21 and 33, which is the most minimum number? 18. Divided by between 18, 32, 21 and 33, which is the maximum number? 33. Minus x minimum is 18. 0 divided by anything is a 0, right? Okay. The normalized value of my salary is how much? 0. Okay, that's great. Move this to the top. Reduce the size of it. Move it to the top. Next number. 32 minus what is the x minimum value? 18 divided by what is the maximum value? 33 minus what is the minimum value? What would be 32 minus 18? Not just the number, 14. Okay. So what? And 15, this should be, I don't know, a very small value, right? So what would be the answer? 0.93. Now I am going to ask you guys, tell me this. Normalization, when you have a column data like that, is easy because I know x minimum and x. Okay. When an image of single channel is given, am I sure that the minimum value is 0 and the maximum value is 255? If you just directly apply that concept here, what will you get? Will it not always be 255 minus 0? So rather than taking a 0 directly, did it make any sense for me to take it like this? I hope you're understanding. In an image, You don't actually bother with the formula directly because you know the mono channel works with 0 to 255. Does that make sense, everyone? And please remember, you're not dealing with a column, you're dealing with a matrix or an array. I hope we got it. So tell me, when I say I am normalizing the image like this, it means I am genuinely normalizing the. Any confusion so far? That's great. Now tell me one thing. Plot.figure, inside the plot.figure, if I take figure size is equal to, I don't know, 10,5 example. What am I doing here? This particular step is called sizing the canvas, correct? I'm telling how large of an image do I want to do. Every single time you load the image, isn't it very, very important to visualize the answer? How the data looks like, what the data looks like, what are we going to be working with it? Okay, I want to visualize, I don't know, a couple of different images. Example, for I in range of 10. Example, what is this going to give me? Is this going to give me a loop that runs how many times exactly? 10 times. Now, if I write a code like this, plot.subplot, okay, plot.subplot, inside this 2 comma 5 comma say I plus 1. What is this going to give me, everyone? Please use your Python skills and tell me what is this line going to do? The plot.subplot 2 comma 5 comma I plus 1. What is this going to give me? What's the utilization of using plot.subplot 2 comma 5 comma 1? What's the advantage of it? Going to give me, okay, listen to me. Is it going to give me a 2 cross, and how many subplots will be mentioned? 10x subplots would be mentioned, correct? Because tell me, the looping convention here for this specific code is for 2 cross 5 grid, and every single time of iteration I go one by one. So I'm going to have a 10 subplot anyways. After this, if I say img is equal to, I take train images of I. Am I going to loop through every single train images of I and dot reshape that image? Because if I want to visualize an image, is it going to be a 28 cross? Look at this particular data. Look at this particular data, everybody. Let me copy this. Let me paste it. How many pixels in the x-axis and how many pixels are in the y-axis in this particular data? Count the number of zeros and 20, whatever the values are. How many do you see at the top? 28 cross 28 pixels. 28. I want my array to be converted to a size 28 cross 28, right? Because if I want to visualize it later on, it becomes my original way of representing in the image. If I do that, if I say plot.imshow, okay, in matplotlib, if you want to work with images, there is a method called imshow. Inside the imshow, can I pass in the image? Okay. If I say cmap is equal to gray, what does this mean? I am telling the program that can you load the image called image and can you show me the entire image in black and white? Are you understanding? I want the image to be seen in black and white or no problem. Okay. If I say plot.axis, okay, and inside this axis, I'm going to write the mention or I'm going to say the word off. Does anybody know? In matplotlib, have you ever seen that there are something called x ticks and y ticks? In a matplotlib, you have something called as the x ticks and you have something called the y ticks. The numbers, the borders, the splits are called x ticks and I don't want anything on the x-axis. I don't want anything on the y-axis. You can even rotate the x-ticks by certain degree, correct? I'm very sure you guys must have done this in your data visualization or matplotlib classes. Okay, that's good. Once I mention just the ticks are to be off, what do I do next? I'm going to write down this piece of code and I'm just going to come over here and I have a small single word called plot.tight layout. Everybody knows what tight layout does. Tight layout makes sure that each individual image does not overlap with each other, correct? It does not look terrible. When you say tight layout, it will make sure every single subplot or values are equally spaced and equally given. So tell me, the data that we loaded, is it genuinely loading the value? So the data that I have loaded kind of makes sense. If you want to put a label on top of it, so if you want to keep it like how do I say this? Like if you want to mention a label, you can also do something like this plot.title. Okay. Inside the plot.title part, what can you do? F double quote, you can say label, right? So let me see if I'm getting the label. Okay. So inside this label, what can I say? NP dot, let's say R max. And inside this, I'm going to pass in the train images, actually train labels, because I'm dealing with labels, and for each individual indices. So label 0, label 0, label 0. Okay. Tell me this. I wrote this piece of code, okay, and I'm running this code for this particular range values. I want to plot a certain bit of label, and I want a specific data to be loaded with a specific indices, meaning 5, 0, 4, 1, 9, 2, 1, 3. Now tell me one thing. If you ever are dealing or working with images, what is it that you need to be careful about? Do you need to be careful about something called reshaping the image? Do you remember in the beginning of the class, I told you one very important thing? And that was, whenever you work with any deep learning based operation, you will have to do a lot of reshaping. Meaning 3D will be converted to 2D, 2D will be converted to 3D, 3D might be converted to 4D, 4D might be converted to 1D. So tell me one thing, whenever you deal with any image, any specific image, do you need to include the channel information also? What channel that image is? Is it a 3-channel image, 2-channel image, or a 1-channel image, correct? So if I want to reshape my image, so if I say train underscore images equal to train images dot reshape, am I reshaping my original value, which is a normalized pixel value of 0 and 1? Remember, what is the most recent operation that we did? Normalization is the most recent operation that we did. Normalization is the most recent operation that I have done, everybody. Great. Love it. Love it. Stay with me. I am going to reshape my image in what? -1 comma 28 cross 28 cross 1. 28 cross 28 is the x-axis and the y-axis, or the x pixel size and the y pixel size. And 1, this specific information 1, this 1 is telling what the model? It's telling that this is a mono-channel image. Are you understanding? This is a mono-channel image. What does this -1 do? If you guys already know the concept of -1 in reshape, is this not going to convert my image into a 4D? Train images dot endim. Can you see my dimensions of image have been converted to 4th dimension? Because how many numbers have I? I have passed in 4 information. Total number of samples, X pixel, Y pixel, and the channel information. So this converts the images into 4 dimensions. Not an image, 4 dimensional in NumPy, NUMPY in NumPy. When you do dot reshape, okay, when you do dot reshape, either you can give the information of the column or either you can give the information of the row. The other side will automatically handle itself. So a lot of you are asking me what is -1 and what is 1. Did I ever? Okay, I don't think I did, but tell me this. Did I not teach you the information of what -1 and 1 does in NumPy? In pandas or in NumPy? Okay, so let's go with. Let me ask you a question. Okay. If I have an image or an array of size 1, 2, 3, 4, 1, 2, 1, 2, 1, 1, 2, 1, how much What are the values you? What's the total value of these matrices that you see here? It's a 3 cross 4. So there are 12 values inside it, correct? Currently, this is a two-dimensional matrix of a 3 cross 4. This 3 cross 4 can be converted into 4 cross 3. Is that possible? Okay. This 2D can be converted into 1D also. But in 1D, how many elements will come? 12 elements will come. So a conversion is possible only and only if the elements are pretty much the same. If you want to convert this into the 1D array conversion will be done in such a way that 4 3s are 12, all the values of 12 will be given. Now tell me one thing. Do you need to inform NumPy that please give me 12 values because my array was a 4 cross 3 12? Do you give that information or does NumPy know this, give this information? Okay, no problem. Okay, so tell me one thing. If I ever want to use the reshape method where I don't specify the columns or I don't specify the row, can I give in -1 so that my array is able to understand it very clearly? So for example, what are the values here? 12 values, correct? Okay. Let me say I have an array is equal to np.array, and inside this I have, let's say 1 2 3 4 5 6 7 8 9 10 11 12. Okay, 12 values. How many values do I have in? Okay, reshape is equal to array.reshape, and inside this I am passing 3 cross 4. Is this operation possible? Going to be this. Did I mention that I want 3 rows and 4 columns? Specifically, I have mentioned what are 3 rows and 4 columns, right? Okay. Now tell me one thing. I don't care how many columns I get. I don't give any concern or care how many columns I get, but I want 6 rows. Reshape will be equal to array.reshape. Sir, I don't care how many columns I get, but I want 6 rows. Can NumPy automatically calculate how many columns I might get? So if I want NumPy to figure it out, can I say, I said, I don't care how many columns you give me. I am least bothered about that. But what I want strictly to be given is 6 rows. I want you to give me 6 rows. So can I say reshape is automatically handled by NumPy? I just gave it -1. If I take the same piece of code, copy this here, and if I give -1 here and 6 here, what are you? Or sorry, how many rows you give me? How many columns do you want? 6. What will be the? Please observe one thing. Please observe one thing. Whatever is the dimension, reshape will always increase with one more. You have 1D, it will increase it to 2D. You have 2D, it increases to 3D. Please tell me, do I have 3D? When I put -1, it made it 4D. Question. Is this -1 mandatory to teach you? Please tell me, is this genuinely necessary? The answer is yes. Each 60,000 sample data point is a 28 cross 28 image with one mono channel. Don't I need to include all? Tell me, I want to increase or include total sample size. What is the overall image dimension and how many channel images? Isn't that what I have done here to include the sample size information? Have include all this concept. I am reshaping my image right now. I'll ask you a question. Let me ask you a question. But sir, guys, when you deal with an array or when you deal with the data in an array, does it give you independent arrays like this? Guys, when a data is shared with you in an array format, isn't it nested every single time? Or are you given comma, 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 comma array like this? How is it given to you? Isn't it nested, everybody? So please tell me this. Are we forgetting the fact that I have this big large array and my images might be saved like this? This is a 3D, but I'm giving an idea. Are you understanding what I'm trying to say? For example, okay, let me make life much more easier for you. Give me 1 second, okay? Give me 1 second. If I show you train images of the 0th index, please tell me the dimension of this. Is it a 3D array? Can you see bracket number 1, bracket number 2 and bracket number 3? Please observe 0, 0, 0, 0, 0. Then there is another bracket opening 0, 0, 0, 0, 0. Then again another bracket opening 0, 0, 0, 0, 0. If I highlight it, uncomment it out and let me show you train images directly here. Give me 1 second. 3. What are you able to see here? Can you see the entire image is given in this representation, which is actually 2. So see, dot ndim. What is that given to me? 2D. Please observe this. Is this how the image has been passed originally by the MNIST data? Love it, love it, love it. What did I do next? I normalized them. When I normalized the images, okay, let me rerun it once again for you. Give me 1 second. Listen to me carefully, okay? When I normalized them and when I calculate the train images dot ndim after normalization, can you see it is still 2D, but because it's only normalized, nothing else has happened. I did not change the originality of the data until yet. It's the same data that was passed to me. Any image will be passed like that, correct? Okay. Once that thing was done, did I plot some of the values? Just the original data I plotted? Okay, good. But tell me one thing. In my original image, I haven't given information about what? That my total train images, okay, this variable train images, is it only one image or all the 60,000 samples? For example, if I print length of train images, what's the total size? 60,000. Now, let me ask you guys a very simple question. When I reshape the array, do I need to include the concept that overall reshape will be with respect to the overall samples also? With respect to 28 cross 28 cross 1, because whatever samples you've given me, I want you to automatically arrange them. That's why I have written. I hope the reason I have put -1 is because I am telling Python program that every single image I want should be 28 cross 28 cross 1. But the problem is my original image is 2D and I have mentioned 4 in numbers inside the variables. Yes or no? -1 I have written, 28 I have written, 28 I have written, 1 I have written. That is why my image is being converted into a 4-dimensional value or a 4-dimensional array. I hope you guys are getting the logic. This -1 is taking care of the indices 0, 1, 2, 3. So once I have reshaped the image, if I say train images of 0, will this -1 take care that 0th index will be the 0th image, first image, second image, third image, fourth image, fifth image? Yes or no? Agree, disagree? If I put down the index here, it will give me that particular thing. So what do I need to do here? If the train images are done properly, what do I also need to do? Which is pending after train images? What do I need to check for? Test images also, right guys? So tell me one thing. If I say test images is equal to test images dot reshape -1, 28, 28, 1, because what? Train images and test images are the same, no? Agree, disagree? They are not a different condition. They are the same condition. So let me rerun the program from the beginning. Run until here we are. Tell me one thing. Did I do this? Train images are done and test image Mike has given me. The -1 figures out what? The dimension and recalculates the indices. It will not recalculate the indices. It will just figure out the dimension based on the dimension you give. Did you get it? It will not reconfigure the indexes. That's not the job of reshape. It is automatically done the minute you give the dimension, because this is one of the beautiful thing about arrays. They are what? Arrays are contiguous memory addresses, correct? I hope everyone knows this for a fact. Array, if you take the word Rudra, Surendra, Sakshi, Rudra will be saved at index 0, Surendra will be stored right after the index 0, 1, and Sakshi will be stored 2. They will always be next to each other. Agree? In memory, they are always next to each other. We don't decide this logic. Array takes care of it at a very deeper level. And when I say next to each other, NumPy actually does it in a binary level. I hope everybody knows in Python we have a value called ID. Did you know this? Okay, let me explain. Suppose if you take name is equal to Rudra. Where is Rudra saved? ID of name. Can you see the memory address here? 6434784368. If I take another variable called name underscore 1 is equal to say Rudra, R-U-D-R-A. Is Rudra for name and name 1 Rudra same? But is the ID same? Is the ID same? Are you going to have the same ID? Are they 6437843668, 6434784368? Run. What do SHARMA? ID of name and ID of name underscore 1. Run. What about? Let me remove Rudra. Run. First of all, tell me this. Did you know that there is something called ID? Okay. Did you know what ID does or what ID did for your code or what ID did for your code or what it does is figure this out. Why is this piece of code guilty? Please don't do that. Do your research and tell me. Guys, so far you have handled the images absolutely. Whatever data of images I needed to handle, I have handled. But what have you not handled so far? Label. Agree? You haven't handled. So let me ask you a question. In this label, every single image will be given a label, right? So for example, if you see this particular thing right here, can you see this particular image has its own label? This particular image of an array will have its own label called 7. This image 3 will have its own label called 3. This number will have its own label called 4. Yes or no? Each image is assigned to its own label. Agree, disagree? Now tell me one thing. In machine learning, you have been taught a concept that if you have multiple labels, what do you do with it? Because the confusion in machine learning is if the label is done with label encoding, which is image 1 is given label 0, other image is given label 2, other 3, other 4, whichever number is higher, that machine learning will give more preference, correct? So that every single image is given equal preference, we use something called one-hot encoding. I hope you know this. Because we don't want a label 9 to overpower every other label, we give something called one-hot encoding because we want every label to be equally represented, correct? Like if I had a capital called Delhi, D-E-L-H-I, Delhi, Bangalore, B-A-N-G-L-O-R-E, Bangalore, and let's say Pune, and say Punjab. Delhi will be converted into 0001, Bangalore will be 0010, Pune will be 0100, and Punjab will be 1000. Got it? Because there are 4 values here, there are 4 values here. Okay, so what do? In my program, I want to work on my one-hot label. So can I say train labels is equal to and test labels is equal to, correct? My train labels will be different. My test labels will be different. What will we do in train labels? In TensorFlow, we have a module called keras. Okay. Inside keras, you have something called dot utils underscore to underscore categorical. Okay. So when you do utils dot to underscore categorical, what does to categorical does if you pass in the train label? And if I write down the same exact code here and paste the concept and write it down here, and instead of this train label, I'm going to call this test label. So what will happen if I do something called to categorical? So let's say train labels of 0. Can you see it is converted into a one hot encoder 000010000? And if you see the length of the train labels, it will exactly be equal to 10. Why 10? Because 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the numbers I am recognizing, no? Totally there. Does that make sense, everybody? What I have done is just converted them into one hot encoding values. Nothing different, nothing absolute. I have handled my images and I have handled my labels. Both of them are handled. Now guys, I'm not sure if you know about this, but you will be hearing this a lot. Data augmentation. Okay. Guys, sometimes what happens, the data that you receive may not be enough for your machine learning or your deep learning example. What happens is, let me ask you guys a question, and I want you guys to listen to me carefully and tell me if you understand. I have a machine learning model with 86% accuracy and a machine learning model with 92% accuracy. Which one do you prefer? Okay. This is what you always say. Okay. But should accuracy be the choice for preference of a model? I have already explained no, it's not. It's actually how good each individual label is represented, correct? How good all labels were represented. My question to you is, if I have 1,000 pictures of dog and 1,000 picture of cat, for my machine learning algorithm to understand the difference between dog and, do I want multiple different kind of breeds of dog and multiple different kinds of breeds of cat to truly understand how different dogs and dogs look like, how different cats and cats look like? Out of 1,000 dog images, if every single picture is of a golden retriever standing in one single pose, is this going to give enough versatility or variation in the data? No. To make variation in the data for 1,000 dog, can I take the image of the original dog and rotate it a little bit to make the algorithm see the data from a different angle? Can I do this like this? To give some variation in the data, to make sure that the variation exists, I can rotate the image left-wise, right side, completely 180 degree, 270 degree, 245 degree. I can rotate the image also. With rotation, can I also do one thing? Randomly zoom in the image and zoom out the image. So random rotation, zoom in, zoom out. Will this create some more data for my machine learning model to look at? Initially, I have 60,000 images. Can I generate 10,000 more images? 5,000 with random rotation, 5,000 with random zoom. This will give my model even more data to look at. Data augmentation is a technique of creating a different kind of data from the same source. So look at this, okay? Augmentation. Guys, listen to me carefully. Data underscore augmentation, okay? If I want to say augmentation is equal to tf.keras, okay? tf.keras. This is like my most important package or submodule. Dot, I am gonna mention something called sequential, and inside the sequential, I am going to say layers dot random rotation, okay? Random rotation, and inside this rotation, I am going to pass 0.1. Sir, can I say 10% can also be given as, can I also say things like layers dot random zoom, okay? Random zoom, and inside this I mention 0.1. So how much percentage am I going to randomly zoom? The overall image is 10%. And what's the degree of rotation? Approximately 10. Are you understanding the degree rotation? So tell me one thing. Every single data that is going to pass through my model, it might have a random rotation also, it might have a random zoom layer also. Why am I doing this? To increase the variation within the data. Agree or disagree? Sir, is this step needed or is it critical for my neural network? No. Sir, can I choose to ignore this step? The answer is yes. If you don't want this step to work, you can ignore it. It's absolutely okay. I have added because I wanted you to see that example. I got the logic. I wanted you guys to just experience it. That's why I have written. So do I use it in the production? I don't know. Depends. I have used it. It works fine. It works really, really good. Okay, fine. Now, sir, comes the time to define my CNN model, my convolutional neural network model. Everybody, I'm going to write a function called create underscore model. And inside this, I'm going to say model is equal to models dot sequential models dot. Okay. Inside the models dot sequential, am I going to pass the first operation called data augmentation? I want the layers to go through data augmentation by itself. The image that comes inside the model should be rotated, slightly zoomed, that data augmentation is done. The first layer is going to be layers dot convolution underscore 2D or conv 2D. Is this my convolution network or my convolution operation? Why 2D? Because is it 28 cross 28 cross 1? It's not 28 cross 28 cross 3. It's a 28 cross 28 cross 1. So isn't it 2D? Mono channel, one channel. Okay. Now I'm going to ask you guys a very neural network. Did I tell you the concept that initially you just build the network, you don't make the network perfect? You are not bothered about creating a neural network in the beginning. You make the neural network and then figure out what works best. So in this convolution.2D, if I will write down something called 32 comma 3 comma, outside this I'm going to take something called activation is equal to, and inside this, because I need to give it the input shape, so I will say input underscore shape is equal to, what is my data like? 28 cross 28. Does this remind it? Okay. Tell me guys, in my layers.conv 2D, this 32 represents, so sorry. What does 32 mean? 32 different kernels or 32 different filters. Are you understanding? There are 32 different filters, 32 different kernels, or 32 different features that I want my image to extract in the beginning. Are you understanding? And each kernel is of what size? 3 by 3. Do you remember? Here we have taken a kernel, 3 by 3 kernel. This is a 3 kernel, this is a 3 kernel. Agree, disagree? So tell me, this is just a vertical kernel, yes or no? Tell me one thing, haven't we taken one vertical kernel? Tell me, on the same image, can I not apply vertical kernel, horizontal kernel, oblique kernel, Sobel kernel, multiple different types of kernel? So tell me, in my new machine learning model or my deep learning model, how many different kind of filters or kernels am I? Because 32 different types of features will be extracted. Are you understanding? In my model, okay, first of all, tell me one thing. Is this number a finalized number? A number should be 32. This is the rule. Sir, no. Can I make this 64 also? Can I make it 72 also? Sir, you can make it whatever you want. I told you from the very beginning. You don't care or give concern about the value. Your job is to make sure that it's the number that you get the right answer. Deep learning is always the art of study. I am telling that my first layer will extract 32 important features. Each kernel has a property to extract a particular feature from image. Yes, last class, when I taught you guys the concept of this particular image like this, did I tell you that each particular layer has its own feature? Let me revise this concept once again. My people, Are you under the assumption that one image can only go through one kernel? Absolutely not. That's a good question. One image can go through 15 different kernel. Okay, that's good. 15 different kernel operation means 15 different features of different size or different type can be extracted. Okay. If you do that, do you also have to specify the size of the kernel? Now tell me one thing. How many features or filters am I putting? 32 for the same image. That's correct, Shiv. For the same one image. Each individual image will pass through each individual layer. Okay. Now, I don't know if any of you want to follow this, but I have a small rule. Do you want to hear it? If you do not want to go wrong, if you do not want to go wrong, use batch normalization. Have you ever heard of the concept called batch normalization? No? Okay. Can I give you guys an idea what that is? So for example, if I put a comma here and say layers dot batch normalization, and I'm going to put a comma. Okay. Now let me ask you guys a simple question. What do you mean by batch normalization? Sir, what is the logic of batch normalization and why would I need something called batch normalization? And sir, what is the reason behind batch normalization? So first of all, okay, let's understand one thing. Okay, let's understand one very important factor. I want you guys to listen to. Imagine I am teaching this class, every single person in this class, deep learning. Every single person in this class is learning deep learning. Now, can I very confidently say that some people are fast learners, some people are slow learners, and some people are still figuring it out. So they're exceptionally slow learners, correct? In this batch of students where I am teaching every single person a class, can I say that the problem here is one student is learning faster, is able to understand what I say in one single line. Some students require me to repeat certain thing 3 times, and some students even after repeating 3 times require maybe revisiting my class maybe twice or thrice, right? Now, is this a problem that can happen in a deep neural network? Okay, my concept is when my neural network needs to learn, some data points are hard for the neural network to understand and some are very easy to understand depending on what the data is. So tell me one thing. What will batch normalization do? Neural network, what does it do? Whatever output you get, okay, whatever output you get from any single layer, it will adjust the output to be a number between 0 and 1. Are you on between 0 and 1? Why? So that the layer answers do not load, they don't become too large for my neural network. What I'm trying to say, each individual layer's output needs to go through what? Batch normalization, and batch normalization. Are you understanding what I'm trying? Is it different from a... Okay. Min-max scalar is a min-max normalization that you learn. Min-max scalar is just a scalar value in machine learning. I am talking about layer normalization, guys. The layers output, one layer that you write, no, convolution layer plus max pool layer, this layer's output values are normalized. Normalization, batch normalization runs on the entire layer. Min-max scalar runs on the logic. They both work in the similar fashion, but batch normalization is a layer normalization. So tell me one thing. Every single time you will apply a convolution layer, what will you mandatorily apply after convolution operation, be it 2D, 3D, whatever it is? Will you apply batch normalization without me asking? The answer should be okay. So let's address this question also. Each kernel is responsible for a particular feature to extract. That means kernel must be predefined range numbers that kernels are going to be taken. In a deep feed forward network and a deep neural network. In both the cases, the kernels that you define in a neural network, are they from a specific range Absolutely not. They are completely random in the beginning. Am I clear? If you have taken 32 kernels, for example, of size 3 by 3, 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 dot dot 3 by 3. Each individual kernel is randomly initialized in the beginning. I hope you guys are once and for all absolutely clear in this. That's great. Okay. You can also decide the size of the kernel. Yes or no? 3 by 3. Okay. Each individual kernel will be responsible for picking up each individual feature. Are you understanding? Meaning, if I have the image of a person, one kernel will focus on the edge, vertical edge. The second kernel will focus on horizontal edge. So the first kernel definitely will be horizontal, second will be vertical. Do I know the order? Will I ever know the order? No. That will depend on the data. So each kernel is responsible for a particular feature to be extracted. Is this a correct answer? Yes. Predefined range? No. Number that the kernel are going to be taken. You decide that. But is this clear? This is correct. This is not. So did you guys get the idea until this much? What did I do today? Did I write just the first layer? I have done nothing but write my first simple. Okay. My layer 1 is written. My batch normalization is done. After the batch normalization is done, what do you import? Layers dot max pooling 2D because it is a 2D image. Now, if I pass 2 comma 2, can somebody tell me what this 2 comma 2 means? When you do max pooling, I want you to take a window size of 2 comma 2. I want you to take a window size of 2 comma 2. Guys, remember one thing. Whenever you do max pooling, always take a window size as small as possible. Remember, if you want your algorithm to perform its peak accuracy, don't take a larger pool window size, take a smaller pool window size. Am I making sense? That's why I have taken the most minimum window size 2. And whenever you do convolution neural network, which is the most optimal kernel size? 3 cross 3. Have I taken? And if you start implementing this logic for no matter what you want to do, you will always end up being the right answer, or you will always end up getting the right answer here. Now, clear everybody? The first layer is clear. If I come to the bottom, what do I write? Can I again say layers dot conv 2D? Again, one more conv. This time I will take 64 and inside this 3 comma 3 and n activation will be equal to relu. Do I need to mention my input shape at all now? Not needed, sir, because you've already done it. After convolution 2D layer, what do you add? Batch normalization. Remember, this is a constant process. Layer max pool 2D. Inside the max pool 2D, what do I do? Again, 2 comma 2. Is it the same operation? Now tell me one thing. This layers.conf 2D I have taken 32 and the other I have taken 64. Sir, am I allowed to do this? Aren't you allowed to do whatever? The numbers are not my priority. Layers are my priority. So can I take one more layer, everybody? Just for simplicity reason, copy this and paste it once again. And I'm going to keep it 64 only. If I write 128, our neural network will be done in 1 hour. So I'm not doing anything. After the max batch normalization, what do I do? Guys, I need to do something called layers.flatten, right? I don't need to do any max pooling layer because I'm already done. I don't need to reduce my dimension anymore. I don't need to get important features anymore. I am done. After batch normalization, do I flatten my layer? After the layers are flattened, do I now apply my feed forward network? So now there will be layers dot. Now I will implement something called layer. My life simple. Can I take the largest dense network 120? the largest possible that can accommodate the biggest flattened array. So 128 comma, what will be the activation? Can I say the activation will still be? I will also implement something called dropout regularization. Have you ever heard of the concept called dropout regularization? No, I'm going to comment this out. What will I write here? Layers.dense. In the dense part, guys, what is the output neuron size? How many labels do I have towards my output, everybody? How many labels am I supposed to predict? 10. So can I say layers.10, comma, activation equals to, now tell me, if you want to do binary classification, sigmoid is the right thing. But if you want to do multiple different classes, you use something called. Tell me, did this complete creation of your? My question to everybody is, my dataset size is still smaller. Do you think I would have taken the risk of even implementing striding at least once? Don't make that mistake. Striding is strictly only when you have a large data set in your disposal, you have versatility in your data, and you want to actually do dimensionality reduction, or you want to reduce some sizes. Until then, am I going to use striding in my data? Absolutely. We used convolution operation, batch normalization, pooling operation, flatten operation, and feed forward network. All the 5 things that we studied, we have implemented each individual of them in my padding. In this particular example, the size of the image is only 28 by 28, so there was no need of padding. But if my image multi-dimensional data, or it's an actual image or a color data, then I would have used padding, because then my size would have been larger. To focus on a specific aspect of an image, I could have used padding, but in our case, we don't need that. Sir, which one is bigger data set for CNN? There are many. Instead of softmax, can we write sigmoid? No, you can't. Sigmoid is an activation function that can only predict 0. Sigmoid's output can either be 0 or 1. Softmax will be equal to the number of labels given. It will depend on the number of labels you have been given in the data. So no, if you use sigmoid here, your answers will be terribly wrong and the answers will not. Sir, like I'm asking, up to how? Up to 2 lakh and higher, striding can be implemented, padding can be implemented, depending on the data as also. But 60,000 is nothing for a convolutional neural network. For a CNN with multiple layers, 60,000 is a nothing. It's just a game for CNN to just go through that data set size. Okay. Plus the layers that we've taken are multiple different layers. So yeah, I think data set size should be considerably a little larger. Otherwise we think quantization is a beautiful thing. Be it PEFT or be it QLoRa. Okay. You quantize it for 32-bit to 8-bit, believe it or not, there will be loss of information. Whether somebody likes it or not, I have eaten and I have gone deeper in generative AI, specifically large language models, and I've used 32-bit quantization to 8-bit quantization. Microsoft came with something called 1-bit quantization. Do you know this? 1-bit quantization by Microsoft. Yeah, right there. Oh my God, you will love this. It's called BitNet. See, first we had a 32-bit full precision value. We came to 16-bit. Then we had 8-bit. Now the Chinese came up with 2.51-bit. Microsoft already has 1-bit and I have used it. And oh my God, this is a fascinating and a most brilliant and a beautiful technology. And the problem is, have you guys heard of a concept called small language model? Like we have a large language model and a small language model. Rather than taking a 675 or a 100 billion model, take a 5 billion model. Your job is enough. You don't even need to do quantization. You can do full precision calculation. And take a small language model and do what? Fine tuning.
Just a quick info, guys. Intellipaat offers artificial intelligence course training, which will enable you to learn skills like neural networks, focusing on CNNs, RNNs, and their application in AI, natural language processing, computer vision, and generative AI. Through this course, you will also master deep learning concepts, AI model building with TensorFlow, transformers, BERT, GPT, LangChain, and NLP pipelines with advanced techniques like image recognition, chatbot development, and much more, all taught by top 1% experts and IIT faculty. And with this course, we have already helped thousands of professionals make successful career transitions in AI and data science. You can check out the testimonials on our Achievers channel. The link is in the description below. And without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take your first step towards the dream career growth in the field of artificial intelligence.
After exploring how CNNs work and seeing their implementation in the notebook, it's time to look at another powerful architecture, the RNNs or Recurrent Neural Networks. We know CNNs excel at analyzing spatial data like images or videos. RNNs, on the other hand, are designed to handle sequential data such as text, speech, and time series, where the order of information matters. Let's understand this in detail.
In our last classes, we have spoken about feed-forward network plus convolutional neural networks, right? Feed-forward network will have its own advantage and its own disadvantage. Convolutional neural networks have their own advantage, have their own disadvantage, okay? Convolutional neural networks are very much capable when it comes to dealing with image, okay? When it comes to dealing with an image or when it comes to dealing with a video, convolutional neural network will do a fascinating job. But convolutional neural networks, they cannot standalone be able to classify, or they will not be able to independently be enough to handle and to do certain tasks all by themselves. So sometimes what happens is convolutional neural networks use feed forward network together to create classification, object detection, segmentation, right? There are multiple other aspects of what convolutional neural networks are capable of doing in real life. Yeah, anyways, feed forward networks, they work on the concepts of weights, biases, and activation function to make your life easy and do what we call as learning, right? In a neural network. When you talk about convolutional neural networks, there are multiple different operations that you need to worry about. Convolution operation, batch normalization, pooling are one of the operations that are common. Apart from that, there is also something called striding, which combined together will be able to make you understand and learn features from the data. That's good. But both convolution neural network and feed forward network, they have a major disadvantage. And that major disadvantage is they remember localized information. Okay. Now let me give you guys an idea. Why do you mean, what do you mean by localized information and what do you do? Okay. See, first I want you to understand one thing. Okay. Imagine you want to remember things for a long period of time. Okay. Example. If I ask you a sentence, I love Spain and I also speak Spanish. Okay. Now, let's say my focus is only this word, Spanish. My focus, my attention is on the word Spanish. My word Spanish goes all the way back to the long range dependency, which is going to be this much, right? So it goes all the way till I love Spain and I also speak Spanish. Spain or Spanish is related to the word Spain, right? But in between Spain and in between Spanish and I also speak comes in between, okay? And I also speak. What happens? Sometimes your choice of word or the word of interest that you want to look at may not be immediately available from the neighboring word. Speak and Spanish. Do they make any sense? Maybe slight sense because Spanish is a language that is spoken But Spanish and speak have no relationship with each other. Spanish and Spain, they have a relationship with each other because Spain, they speak Spanish. But in between, there are certain words which are making me lose the connection between Spain and Spanish. What if I want to handle this condition that one word could have its dependency very far away from the original sentence, but I still have to be capable of remembering this relationship? Then what do we do? What happens in that condition? Well, in that condition, my guys, we are going to be learning something really critical, and that algorithm or that technique is called recurrent neural network. Neural network, we are going to be understanding the idea of recurrent network. Let's say issues with feed forward network. What issues do I have with feed forward network? What are recurrent neural networks? The types of recurrent neural network. What is the issue with it? Vanishing gradient, exploding gradient, and LSTMs. Now let's actually understand what recurrent neural networks are capable of doing, and then let's go forward with feed forward network. See, in a feed forward network, right, you have a relationship mapping between input neuron, hidden layer, and output layer. Okay. A simple example would be, if you really think about a feed forward network, the feed forward network lets you do one thing. And that one thing is, let me explain, right? Imagine there is a cook, okay? And that cook has prepared a certain amount of dinner or certain amount of food on day one. This person has cooked, say, chicken, example, okay? Let's say day two, the person has cooked pizza. And day three, the person has cooked noodles, right? A recurrent neural network will not independently consider day 1 and day 2 and day 3 information separately. What you do is you combine these informations, so day 1's information will pass on to day 2's information, and day 2's information will pass on to day 3's information. So basically what you do, you combine the previous result or the previous information with the current information to make a prediction on the next information. Sir, why is this important? What's the main importance behind why do we need to do this, and what's the reason behind it, right? Let's try to actually get an understanding of this. Imagine you have two kind of chef, okay? You have two types of chef in your in a hotel, in a restaurant. One chef is a very forgetful kind of chef, okay? Somebody who forgets a lot. And the other chef who's able to remember for a long period of time, okay? Now understand one thing. A chef who's forgetful chef can max to max remember what was cooked yesterday. So suppose if pizza was cooked yesterday, today he will cook maybe, I don't know, a burger, right? But this chef can only remember previous day's cooking, the food that was cooked in the last day. Imagine there is another kind of chef, a chef that can remember what was cooked for the last 1 week. Okay, for the last 1 week. Now, whatever was cooked the last 1 week, that memory, that information is known or is aware by the chef. So the chef does not make the mistake of repeating the food item for the entire week. But the forgetful chef can only remember the previous day information, meaning the chef's chances of repeating the information, redundancy, will increase because the chef only remembers what was cooked in the last day or the previous day. So the difference between them both is one keyword called memory, correct? The memory is retained even longer for somebody who remembers for a long term time or for somebody who does not remember for a long term time. Now, sir, how is this related to a recurrent neural network, and why do we care about it? In natural language processing, word order matters. Okay, word order matters. Sir, what do you mean by word order matters? Man eat dog. Dog eat man. From a simple machine learning perspective, these two sentences might have a similar meaning, correct? If I say man eat dog and a dog eat man, okay, these sentences will have a similar meaning when it comes to applying simple statistical approaches like how many man, how many eat, how many dog. But the context of the information is complete. Here, when you say man eat dog and a dog eat man, they completely mean two different conversations. Now, the word order is absolutely important when it comes to any natural language processing task. Okay, any natural language processing task, word order is important. Apart from natural language processing task, can I say time series data? Let me, right? So let's say gold prices in the past 10 years. And let me take an image. Okay, let's take an example here. Okay, guys, the gold price that was in 2025 here, okay, was dependent of the gold price in the last, right? They have some relationship. The previous relationships or the previous answer has the effect on the future answer. This data point was related to 2020. So if you can look at this particular example, my 2025 results were kind of dependent on 2020 results. My 2020 results were dependent on 2015 results, 2015 on 2010, 2010 on 2005, and 2000 on 2000. So tell me, in time series analysis, the order is important. 2000's gold prices affects the 2005's gold prices because of course they need to go beyond a certain range. 2005 gold prices with some other issues are dependent on 2010's prices. So tell me this, when you talk about natural language processing tasks or when you talk about time series analysis, the order is important, right? First, a certain order will come, only then a second order can come. And then only then a third order can arrive. And only then a fourth order can arrive. And only then the fifth order can arrive. I cannot jumble everything and expect the information to be lost over a period of time. If you talk about field, right? They don't have the capacity to understand the order. They don't care if they come in order or not. They just care about pattern recognition. But we need something that can tell me what happened in my past so that I can take a decision in the future. If you want to be able to handle such situations in recurrent or in machine learning, recurrent neural networks are the first beginning steps to make you handle that in the future. Okay. How do we understand this? Let's understand this from a very simple example. See guys, in recurrent neural network, the way a recurrent neural network written is actually in a very simple way. Okay. With this, you will get the idea very, very clear. See, what happens is you have this cell. Okay. This box is called as a cell. This cell will have two output arrows. Okay, one arrow going inside, one arrow going outside. The arrow going inside is x of t, which is your arrow going outside is y of t, is called your output. And then you have a recurrent connection called h of t minus 1, which is called as your hidden state. Hidden, hidden, state, hidden state. Now, don't worry, let's understand each thing basic by basic, line by line, point by point, and everything will become absolutely second. See guys, if you to stay connected to your past, okay, just like how in this class, you guys have become better or you have improved over a period of time because you took learnings from your past, included those learning in the present, and now in the future your scope of improvement is better, or even in the current situation you know for a fact that you have become a better human being because you've made mistakes in the past and you've learned from the past. Okay, so somehow you are connected to your past, some kind of a connection like let's assume memory. You have a memory of the mistakes you did in the past, and because of the memory you have of the past, now enabling yourself to become better in the future, right? So, sir, how does recurrent neural network work in the similar way? How do I connect myself to the past and take the information from the past and become better at it, right? So, very simple. This recurrent, okay, you need to expand. If I expand this information or this recurrent neural network, it will look like this. It would look like a cell number 1, cell number 2, and cell number 3. Okay. Cell number 1, cell number 2, and cell number 3. If I expand this a little bit, okay. Now, imagine you have a sentence called I love. Now, I love ice cream. The order is important, everybody. Agree? Love cannot come before ice cream cannot come before love. The order of the word sentence is absolutely critical. Without the order, it's not going to make any sense. Love, ice cream, I love ice cream, right? So the word will go inside the first. The useful information I will be passed on to another kind of the cell where my input will be love. So the information I needs or holds some importance, right? That importance I will be passed through this particular arrow. Can arrow here? This particular arrow, let me make it look like in a blue color arrow. Some information about I will be passed on to the next cell with love. Okay, so now love also passed inside it. Now I and love, they both hold some information that will go to the next word information, which is ice cream. So if I pass something called ice cream, CREAM, because I and love were included in the information for ice cream, I can now make a judgment that I love ice cream is a positive sentence or a negative sentence. Example, I'm giving you a very simple example. Okay. So tell me one thing. Every single information of the past, including I, including love, and including ice cream, all those information are used using the current situation ice cream, and they are included also, right? Like the connection from the past is already connected. This connection here will pass on the information from the past to the correct. Now, sir, mathematically, how are we able to achieve this? Like, how is a neural network, like a recurrent neural network, capable of handling such information? So, first of all, guys, recurrent neural networks can get a little confusing because every single time a recurrent neural network is passed, they have a two arrow. One is the input arrow and the other is the output arrow. Okay. So, what I'm going to say is x of t minus 1 is going to give me y of t minus 1, and this is h of t minus 1. This is my current time step, x of t equals to 0, x of t equals to 0, and h of t equals to 0, and this is x of t plus 1. This is x of t plus 1 or y of t plus 1, and this is h of t plus 1. Okay. Now guys, let's actually roll back, go a little in the basics and try to understand what a recurrent neural network does, because it's not that straightforward. How do I say this? It will require some understanding. Hidden state, what is a hidden structure, and all of that stuff. We'll come to that. Okay. I want you guys to think of a sentence or a word called time step. Okay. Time step. The first data that you input inside a recurrent neural network would be considered like this. X of t is equal to 0 or h minus 1 or t minus 1. Let's say x of t minus 1. This will be y or output of t minus 1, and this will be hidden state of t minus 1. Then you pass something called as x of t, which is 0. This answer will be y of t, and this answer of hidden state will be h of t. Then this is going to be x of t plus 1, the prediction in the future, y of t plus 1, and this is h of t plus 1. Now, I don't want you guys to get confused with anything else. All I want you to see things, only two things. Now, for every single input, is there a respective output in two direction? One output is the y of t plus 1 or y of t minus 1 and h of t minus 1. Yes or no? For one single input, there are two outputs. One is this and this repeats in every single cell, including xt minus 1, x of t or x of t plus 2. Number 2, what I want you to remember is this. The previous information of the cell, the information of the cell from the past to the present, the data is being transferred by the hidden state. The previous cell information or information that was available in the previous, that information is being passed on to my new cell with the hidden. Can you see? H of t minus 1 is being transferred, which is the previous cell information is being transferred to the new cell. So the new cell will consume this and this. It will consume x of t and h. How this particular thing and this particular thing. Okay. So did I mention anywhere that y of t minus 1 is anywhere in the last 5 minutes? Did I mention that at all? That y or y of t minus 1 is passed? No. If I did not mention, I don't want you to get unnecessary. No. Absolutely not. Nope and no. Y is not passed in the stealth like this or in the hidden. Go beyond a certain level to confuse yourself. It's not passed like that. It is going to make the entire neural network understanding also wrong. No. You don't pass Y. Y not, it will break the entire neural network if you pass. Let's go through it once again. I don't want to confuse you. I want to keep you guys in two single clarity. Okay. First of all, every single input of value in a cell will give you two output. Y of t minus 1 is going to be the first output. H of t minus 1 will be the second output. Is this the next cell, which is this cell, the cell number 2, let's call this cell number 0, cell number 1 and cell number 2. Cell number 1's input is not just one but two input. X of t is one input and h of t minus 1 is other input. And then it will give you two output, y of t. Then again for cell number 2, there are two inputs, x of t plus 1, h of t. And then again they will give two output, y of t minus 1. Everybody, what are these two information that you pass to a recurrent neural network? One is the previous cell's information. One of the input is the previous cell information and the other is the current information, correct? One is the current information and the other is the previous. Okay. What will happen here is, because you are passing the previous cell information, this cell that you see in front of you, the cell number 2, will be able to remember all the way back up to cell number 1, correct? Or cell number 0? Because cell number 1 has information of cell number 0, cell number 2 has information of cell number 1, which in turn has cell information 0. So 2 also has the information of cell number 0. Sense? They are connected to each other. They have memory of. So if I use this particular recurrent neural network in natural language processing, I will be the most beneficial, right? Because in a sentence in English language or any other language, dependencies of long range are more important, correct? Like for example, if I take a paragraph of a sentence, the entire paragraph sentence information could be long range. Let me give you guys a very simple example, okay? Rudra, R-U-D-R-A, Rudra. it has been observed that he is also a fan of mountains. So tell me one thing. My dependency he maps to which sentence, or who is he referred? Is he referred to Rudra? But tell me one thing. To map he to Rudra, are there sentences in between? Loves to take a walk on beach. It has been observed that. To map he back to Rudra, isn't there quite a distance between those? Are you guys trying to understand why recurrent neural networks are preferred? Because long range dependencies are kept across when the sentence of your preference or your choice needs to be mapped back to the. Did you guys get the topic? I haven't yet gone in depth. This was just the intro logic. Long range dependencies, can you think a feed forward network can handle? My question is very simple, everybody. Do you think a simple feed forward network is capable of handling a large range or a long range? Sir, it is not possible. Let me tell you this right now. It is simply not possible and it does not work like that. So in order to remember long range dependency and a very large range dependency, do we say that the best way to understand a long range dependency is a concept called recurrent? Okay, let's actually learn in detail how does this particular recurrent neural network work. So I told you a recurrent neural network has three things. What are those three things? Let's actually look at them. First of all, it has something called as a. Now, this h of t has two arrows going outside. One arrow is called y of t or y hat of t, your prediction. And it also has another input arrow. We call this particular arrow as x of t. There is a hidden state information that passes from the previous cell. Let me call this as h of t equals to 0. And h of t is equal to 0. See guys, and then the hidden state information will be passed in the front. So this hidden state information that it is passing will be passed like this. Let's call this particular thing h of t minus 1. Okay, let's give it like this. Let me copy this up and let me remove this h of t. I don't want h of t to be informed here. Okay, this is the state. Guys, when you say the sentence, I love ice cream, let me copy the whole thing, paste, okay, love, let me make it like this, then I say another sentence, love, and then I say another sentence here called ice cream, okay, called ice cream, okay. Remove this, okay. See guys, the input I does not directly pass inside the recurrent neural network. It doesn't just directly pass like that. For any neural network in this planet to say it is learning something, we need weights, right? We need weights, right? If you want to say that my neural network has learned something, can you just randomly say learning means what? No. So guys, what happens is the neural network or the input x of t is multiplied with a weight matrix called u. There is also another weight matrix and then there is another weight matrix called the w. So tell me how many weights or how many weight matrices are given in a single cell of a neural network? U, V. Now my question to you all is very for this cell number 1, what is the input of cell number? Very simple question, okay? A very simple question. Sir, everything. Let's call this thing as h of t. This is h of t plus 1 and this is h of t plus 2. Okay, Sir, if I want my output at h of t, this particular h of t, this h of t is what I want to do or what I want to consume, right? Can I, rather than writing a cell like this, let me write it like this. Let me write a recurrent. This connection here is called as h of t minus 1, and this is multiplied with the weight matrix W. So can I say something like this? Your h of t, the output or the hidden cell state input that you get, is nothing but a function of input value x of t should be multiplied with the weight matrix U. This and this should be multiplied together plus the weight value should be multiplied with the h of t minus 1 cell input. This together will combine the previous hidden. If you are confused, let me write h of t minus 1. Is it everybody? Is h of t minus 1 coming from the past? This h of t minus 1 has its own weight matrix of the previous value, which is. So now does it make sense? The h of t is a combination of x of t into u plus w into h of t minus 1. State, your previous hidden state h of t minus 1 has its own weight matrix called a w. If you take h of t minus 1 into w plus u into x of t, will that give you the... So tell me one thing, hidden state is a combination of current information plus previous information. Can I say it like that? Okay. Sir, what about y hat of t? What about my prediction y hat of t? Y hat of t. Can I say that y hat of t will pass through something like this? V is the weight matrix here multiplied by h of t, and if you pass it through some activation function phi, this will give me the output value y of. So tell me the logical explanation for h of t minus 1 or h of t and y of t. These are the formula, or this is the number or the way my information is being passed on or transferred to the y state. So tell me one thing, guys, I have a question. In my neural network of a simple recurrent neural network or a cell of a recurrent neural network, my input value h of t or my hidden state, it is dependent on my current input x of t and u and my previous state h of t minus 1 and w. Now my question is very simple. Sir, when you say h of t minus 1, what do you actually mean? Guys, do neural network works on anything apart from numbers, mathematical numbers? Do they work on anything apart from a number? No. So sir, this hidden state of t minus 1, how will it carry the information? Can I say it can carry the information like this, 0.234, like this? It will carry the previous cell's information in a numerical format. Your current input can also be a number, agree or disagree? Because when you say I love ice cream, do you think computer accepts the word I directly? Will a computer be able to understand the sentence I directly? The answer is no. So allow me to elaborate a recurrent neural network. Do you think encoding is something which is very, very critical in a recurrent neural network? When you say the word I needs to be converted into a number like 0.369. Love should be converted into another sentence called 0.1124, and ice cream should be converted into another sentence called 0.691293. Can we call this particular thing as encoding, everyone? Here you guys are clear. See, I am going point by point, guys. I am not making the whole recurrent neural network confusing to you. I'm trying to go line by line, point by point. So understand it with me, okay? Don't jump into conclusions right now. Just wait for a second. First of all, the sentences I love ice cream, they cannot go inside a cell structure directly. You can't just put I inside it and expect the whole answer to be amazing, right? It can't happen. So tell me, when you say, sir, you have passed the hidden state information from the past layer or the past cell, does this mean it is actually a number? the number could be larger, so the effect in the cell will be larger. If the number is smaller, the effect of the cell information, if the previous hidden state number is a larger number, the effect it will have in the current cell also will be larger. If the cell from the hidden state is a smaller number, then the effect it will have on the previous cell also will be smaller. Is it? Are you guys able to sort of understand the power or the signal strength? If the signal that comes from the previous cell, it's not very strong, my hidden state will not consider the previous input to be a very strong input. Now, my question, when the signal is passing from one point to other point and other point to other point, the signal carries the strength of the previous information also, right? All the previous information, my signal is currently carrying the strength. Yes. By the time I come to the most recent kind of cell, I will have the previous values averaged, or I have the information from the previous cell also to make a prediction in the future, right? That's the philosophy behind recurrent. In this, I want to teach you one more topic. With this, your idea will become absolutely clear. See, first of all, have you ever heard in mathematics something called as one-to-many mapping? Many-to-one mapping? Many-to-many mapping? Have you ever heard of the concept called one-to-many, many-to-one, one-to-one? Okay, I'm going to show you an idea. Can you see here? One many-to-one mapping and many-to-many mapping. Can you see in front of you? Okay, let's look at some examples of one-to-one mapping. Okay, one-to-one mapping. Guys, listen to me. Have you ever heard of a concept called parts? In English, have you heard of a concept called parts of speech? Okay, let me explain it to you in back people. Yeah, okay, copy this and to teach you right now. This is more important. Okay, cut, cut, and cut. Guys, imagine you are using 4-cell recurrent neural network. Okay, this is cell number 1. This is cell number 2. This is cell number 3. And this is cell number 4. And this is cell number 5. How many cells of recurrent neural networks do you have? 5. When you say one-to-one mapping, every single input should have an output arrow also. Agree? If I pass the sentence Janet, in single word sentence Janet, Janet is for every input of the cell, I want to generate the output Y, that Janet is a noun. Then I pass the information in the next cell. Will is also an output which is an auxiliary sentence. So ox. Back is a verb. The is a determinant and bill is also a noun. So can you see, for each individual input, I want to generate an output of the same cell, and this is called. So for every single input cell, I want to generate an output. So which one will, what kind of neural network mapping will you use? You will use something called one-to-one mapping to generate the input, and for the same input. Okay, let's look at another one. Let's look at another example. Apart from one-to-one, do you see there is something called one-to? Okay, so tell me, what do you, if I want to say that one-to-many mapping I have, what would you relate it with? Like what would I say that one-to mapping will be related? So one-to-many mapping. So say I will say one-to-many mapping. Sir, what do you mean by one-to-many mapping? Okay. What will be the input? Like if I show you a screenshot of this, okay, give me 1 second. Let me copy this and let me paste it here. Okay. So tell me this. Let's say I want to build an AI. Okay. That AI does what? It is able to give you, say for example, I want to this image will generate the text caption. A place worth staying. You gave an image of you to put on Instagram and it generated a caption. What did you pass in the input? You only passed in an image. But did it generate something called as a caption, a text caption, a place worth staying? It gave you multiple different responses for one single response. That sir, can RNNs handle image? The answer is yes. Not alone. CNN plus RNN together can handle images. Okay, so don't get confused. We can do crazy amount of things in machine learning. Don't worry about it. But for now, for single input, do I have for one single input, I was able to generate multiple different output. This is called one-to-many mapping. Apart from one-to-one mapping, do you have also something called many-to-one mapping? So can you see here? There is also something called many-to-one mapping here, if you observe carefully. Sir, why do we use many-to-one mapping? So let me give you guys an idea. If you put a sentence, I really hated the ice cream. I really hated the movie. The actor needs to take money from me for acting classes. Tell me, if this is the review that I have passed, what will be the output of this review? Is it a negative review? No matter what sentences you input in the last layer, the output is only of one type: positive, negative, neutral. Do you see many-to-one mapping? Multiple sentences were added, but the output of only of one category: positive, negative, or neutral. Now, sir, apart from this, do you also have another kind, many-to-many mapping? Now guys, tell me one thing. What do you mean by many-to-many mapping? Meaning your input sentences or your input also is of many type and your output also is many type. So can I say it like this? If you say in English, I love its holy time. So let's say laddu. You say I love laddu. In Hindi, it would be mujhe laddu pasand hai. My input sentences were many sentences, but my output sentences were also in many sentences, correct? Because I have converted my sentence of English into Hindi. To say here, the order is, if I put the sentences in a way where what say, I would say something very, very important, right? So the word can have a many to many. The English sentence converted to Hindi sentence, or even if you want to convert it to say any other sentences. Liebe laddu, right? So ich liebe laddu, say for example, I converted this in Hindi to German. What happens is, if the three sentences are in the beginning will map to three sentences, no problem. Or the three sentences can map to multiple sentences, no problem. So this example would have a many. Okay, good. So tell me one thing, you guys got the concept of one-to-many mapping, many-to-many mapping, one-to-one mapping, and multiple different kind of mapping. Why did I teach you this concept? Why one-to-one mapping, many-to-one mapping, many-to-many mapping? Every single time you build a LSTM cell, is the output cell y hash of t or y hat t important every single time? Example. Let me give you an example. Listen to me carefully. See, if you want to build a recurrent neural network to understand what is the sentence classification, positive, negative, or neutral. I love ice cream. When you pass the sentence I and then the sentence love and then the sentence ice cream, don't you want prediction only at the output state, whether it is a positive sentence, negative sentence, or a neutral sentence? But I just need to pass the data from I, love to ice cream, and ice cream to the output. Am I making? In a recurrent neural network, you don't always require the output of y hat of t, because sometimes, depending on the goal, a recurrent neural network cell will just take the previous hidden state, input state, hidden state, input state, hidden state, input state, and one output, positive, negative, and neutral, will pop up. So I hope you are understanding that. Not necessary that every single time this y hat of t is mandatory in every single cell. I hope I'm making sense. So a recurrent neural network is so versatile that I can pass in the input sentence, I can pass in the previous hidden state, and I can get the answer y hat of t. And then from this cell, I will get a new hidden state, which is going to be my h hidden state. So there are two inputs to the neural network and two outputs. Okay. Is it mandatory that you have to pass the y information to the previous cell or to the next cell? No, it's not needed. But sir, for the first cell, there will only be one input, right? No. Can you take a default or a random value for the first hidden cell? If this is my first cell, the first ever cell of the neural network, can I say I can either take the previous hidden state as 0, or I can give it some random hidden state, which can later be fine-tuned by the model, and then I can pass it down to next cell. Then this cell will again pass it down to the next cell. Then again this cell will pass it down to the next cell. I hope you are understanding. Now, in any, the most important here is this: the knowledge or the learning in a neural network can be saved in the value of weights. Weights are the number or the values that save the intelligence of a model. In every single cell, did you find that there are 3 weights? There are actually 3 weights: U, V, and W. So tell me one thing. If you really think about the back propagation of a RNN layer, do you think the back propagation will be slightly complicated? Because think about it. My output was dependent on the previous cell, which depends on both my input and my hidden state. The output y hat of t that I got is dependent on not just my previous hidden state, but also my current input, correct? Now tell me, is input dependent on anything? 0. No. Is input value dependent on anything? Absolutely not. But what about my previous hidden state? It was dependent on its previous input and previous. That's great. But what about my previous hidden state? Again, it is dependent on this and this. So are you able to understand that to change the gradient or to understand the effect of the hidden state or input on this, you have to go all. There is no way you can calculate this and this in the beginning. This is one of the reasons why the algorithm is called BPTT. The full form is back propagation through time. This is called back propagation through time. It's like you going back in the time to check what weight values caused what values to change in my current output value. So you go all the way till back, and the math behind it is, I'm not going to say hard, but yeah, it is complicated. No, you don't call it just back propagation, you call it BPTT, back propagation through time, meaning you know for a fact there are so many dependencies in a recurrent neural network and you go back. Now you must be thinking one thing, and my question is this, guys, if you add 2 things in sequence or 3 things in sequence, what is the biggest disadvantage that you're... See, if you pass some things in sequence, what is the biggest disadvantage you have in a sequence? If any one of the cell is giving wrong answer, right after that cell, everything else will be ruined, correct? Listen to me carefully. Assume you have a pipeline system of transferring water from the river source to the house. Okay. If any one of the pipeline allows leakage of poison into the water, anything after this, the pipeline will be ruined or the water source will be ruined. Before this, it was pure. After this, it was not pure. Disagree? Just like this, there is a big problem in recurrent neural network. One of the biggest disadvantage of recurrent neural network is a value called exploding gradient. Exploding gradient. Sir, what do you mean by exploding gradient? See, very simple. Listen to me carefully. Guys, if I ask you guys not from the mathematical perspective, I want you to forget the math for now. I want you, when the data is passed from cell number 1 to cell number 2 and cell number 2 to cell, hidden state values could be a number or hidden state value. Now I want you guys to understand one thing. You guys learned the logic right now a second ago that if I have an input in my matrix or my cell called x of t and my output here is called y of t and this is called h of t, example, okay, this is h of t that I'm passing, or h of t minus 1, you can call it t minus 1, t minus 1 and t minus 1, example. My current cell that I'm interested in is this, right? This is this is y of t and this is h of t and this is x of t. So tell me one thing, observe carefully. My h of t is nothing but some activation function f with u is here, v is here and w is here. So tell me, it's u into x of t plus w into h of t minus 1. Can I? You already know for a fact that my y hat of t is nothing but a function of activation function of v into h of t, correct? Here, the activation functions like ReLU or any other activation function is used. In y of t, you usually use something called sigmoid or softmax, okay? But my point is this, your h of t minus 1, because it is a number, can that number be very, very large and very, very small? Can that happen? Small. Okay. If the number is very, very large from h of t minus 1, are you sure and guaranteed that h of t will also be a large number, because a very large number is getting multiplied and added together with h of t minus 1. See, previous h of t minus 1 is multiplied with the weights, x of t is multiplied with. Okay. Now listen to me. When we say multiplication, the most important thing you should be focusing on is the weights are the most important criteria in any neural network. Is it? What do you mean by that? If you take a very, very large number, 900, but the weight value is 0.001, is that going to have any? Guys, suppose if you have a very large number, 900, but the weight value is 0.001, what do you mean? The answer is going to be such a small number, right? So 1, 2, 3, 4, 0.09. So tell me one thing, if the number is larger, of course the effect will be larger, but the most important aspect if my neural network are nothing but my weights value, correct? So my recurrent neural network will be able to perform at the optimal capacity if the weight values mentioned in the U and the weight values mentioned in the W are balanced. But you know what happens, my people? While doing forward propagation and backward propagation, these weight values sometimes become large. Because weight values become large, the overall answer becomes very, very large. And they explode in nature. What do you mean by explode? The answers and the numbers become so large, incredibly large, that the prediction becomes absolutely wrong. Okay, tell me this. If the weight values are what do you mean by exploding? So now my question is, When you talk about exploding gradient, specifically about exploding gradient, tell me when you multiply two numbers together and one of the number is a weight value, and if the weight value is a larger number. My question is very, very simple. Okay, it's not a very complicated question, but a very simple question. Weight values are important in the output analysis, correct? This value, the green color value that you see here is my, okay, good. Now let me ask you guys a simple question, okay? If I write it down in the most easiest of the sense, okay, this. Sir, if I want my neural network to, I want the weight to be in a certain range. Is my understanding correct? I have a certain expectation of the ranges in the weight values. I don't want them to become crude. Okay. Now, for every neural network, when the neural network is actually learning, when you say learning, you actually have to implement something called, I will say that a neural network has to learn. Learning is the most important aspect of a neural network. When you say learning, it means it is going through back propagation. When you say it is going through back propagation, what I'm essentially doing is, am I not changing my weight or updating my weight? I am basically interested in updating my weight value. So tell me one thing, my previous weight value W plus, my new weight value W plus, isn't it old value W plus, or which is old weight value minus learning rate into loss function divided by with respect to that weight? This is the equation of gradient descent that changes my, how do I say this? My question is this, are these the gradients? Is this derivative, the del loss by del W is what I say gradient? These are my gradient values. The loss function, how much is my loss function changing with respect to weight change in one particular equation? This is what it means, right? The sensitivity in a neural network, remember, okay, let me revise your memory. My output value is 85. This is my Y predicted value. My actual value is 100. What is 85 minus 100 or 100 minus 85, everybody? 15. My Y predicted value is dependent on both the weight 7 and the weight 8 of my neural network, correct? How much sensitive is my Y predicted answer or Y actual answer if I change W7? If I change W7, if I increase it, my error decreases. If I decrease my weight 7, my error increases. Is this the relationship between weight 7? Okay. My question to you all is very simple. Okay, listen. Okay, this is a little bit of important math, so try and understand. Everybody, okay, imagine I have a x-axis and a y-axis. Okay, listen to me carefully. I have an x-axis and I have a y-axis. Suppose I have a line that looks like this. Okay, 0, 1, 2, 3, 4 and 5. 1, 2, 3, 4 and I have a line like this. Okay. For every 1 degree change you make in the bottom, you move only 1 centimeter in the bottom. How many centimeters do you move in the y-axis? 1.9. For every change of 1 centimeter in the x-axis, in the y you move by 1.9 degree. Agree? So how sensitive is 1 degree change to y? Thank you so much. Next, what about if I make a 2 degree change, am I answer getting 3.9 degree? Are you guys understanding the sensitivity factor that I'm telling you? Okay, good. Now tell me, if I have another line, green color 9. For every 1 centimeter that you moved on the x-axis, what is the change in the y? 0.2. For 1 degree change in x, 0.2 in the y. For 1 degree change in the x, 1.9 in the y. Is the sensitivity different depending on the error of my neural network? Neuron 1, neuron 2, neuron 3, neuron 1, neuron 2 and neuron 1. This output neuron will be able to give me y predicted answer, correct? Because of the y predicted answer, I can calculate the error, correct? My error is dependent on the y predicted answer, and my y predicted answer is dependent on weight 7 and weight 8. If I just change weight 7, can I calculate the changes? If I do in weight 7, how sensitive is my error if there is a small change in weight W7? Isn't that written like this? Del W by del W7? This is the mathematical way to find out the sensitivity my error has if W7. Understand something important. So tell me, my question is, if I'm doing back propagation through time, if the gradient values are larger, if the back propagation gradients are larger, won't at the end of the day, my weights will be larger because my updated weight will also be larger because my gradient. And because my weight is larger, any number multiplied with a larger weight also results in a larger number. Are you understanding the relationship? What happens to a larger gradient? Let's talk about it. Larger gradient. Did you miss the sign which is called negative sign here? Tell me, is this a positive number or a negative number? What kind of? It's a negative. A gradient which is larger or a gradient which is smaller, it will make a change in my W plus, but not the way we expect it to be, correct? Not in the way we expect the change to be. Meaning, tell me this, for any gradient calculation that I do, okay, the gradients can be larger and the gradients can be smaller. Larger gradients would mean larger effect, smaller gradient would mean smaller. Is this clear? A larger gradient would mean there is a larger effect of sensitivity of the weight with respect to its loss. A smaller gradient would mean that there is a smaller effect of this. Okay. The problem with exploding gradient or vanishing gradient is only one thing. Sir, what do you genuinely mean by exploding gradient? What is being exploded? What is that one meaning? Remember one thing, in recurrent neural network, when weights in each time steps keep increasing, and increasing, everybody knows this answer. But what people don't realize is, but sir, what is the relationship between them? Let's understand the relationship between them. Okay. I want you to keep these equations in front of you. Okay. Both of you. Let's keep this number and this number and this number. Okay. 1 second. Let me move this. Let me put it here. Okay. So tell me this. Sir, this value or this equation is going to give me the updated weight value for a gradient or a back propagation that I do, right? I get a new value. This updated weight value is more affected by the old weight value subtracted by some learning rate multiplied by some gradient, correct? Meaning, whatever gradient you calculate, larger or smaller, will be normalized because you're multiplying it with the learning rate. Everybody agrees? Usually, the learning rate number is 0.001 or 0. Learning rate is a very small number. Usually people take it at either as 0.01 or either 0.01. So no matter how large you are going to be sort of balanced and normalized here. So from your previous weight value to the updated weight value, this 9 could become max to max 8.75 or 8.3, meaning the weight numbers will be closer to the weight values of the old weight value and the new weight value. They will be closer to each. The old weight value, if it is 10, then the updated weight value could be more than, I don't know, 9.4, 9.3. It's not like the previous weight value is 10 and now suddenly the new weight value is 2. You're understanding what I'm trying to say? Each step, when the neural network learns, the weight value decreases. All right. So see, exploding gradient, gradient or vanishing gradient is a two kind of problem you have in RNNs. What it does is, for RNN, there are two kind of problems you will encounter. Okay, vanishing gradient and exploding gradient. In vanishing gradient, what will happen? Your gradients become larger and larger and larger and larger. Neural network will go bad. In vanishing gradient, sorry, in exploding gradient, your gradient value becomes larger and larger and larger and larger. In vanishing, they become smaller and smaller and smaller and smaller. So you need to balance your weight values. Just keep this in mind. It's okay. You don't need to go in depth about it. It's all right. No problem. Okay. So tell me, in our RNN problems, what did we identify? We've identified two things. What are those two things? If you can see here, this is a very simple structure of a recurrent neural network. If you can see here, U value, W value, V. So these are weight matrices, U, V, W, U, V, W, U, V, W. Your previous input step is going to be W. Your current input step is going to be X of T. Your output will be V. Not needed that every single time you need an output here. You don't need that. Ignore it. It's not, okay? So tell me one thing, guys. Apart from recurrent neural networks or the back propagation through time, see what happens here is back propagation through time is used to update the weights in the recurrent neural network. What do you mean by weights? You need to change the U, you need to change the V, and you need to change the W, all three of them together. RNNs typically predict one output per each time step. Conceptually, BPTT works by unrolling the network to get each of these individual time steps. So from previous E4 to E3 to E2 to E1 to E0, unroll until the very last. Then it calculates the error across each time step, and then we accumulate and roll back and update the weight values. You guys already know this, but remember one thing. The problem with issues or the issues with recurrent neural networks are two things. One is the vanishing gradient problem. They've already written it. See, the gradient reaches very close to zero. Because it reaches close to zero, there is no update in the model. And in the other part, there is also something called exploding gradient. Do look at it. You will get the idea. The problem solution for both exploding gradient and vanishing gradient is a network called LSTM, long short-term memory model. Now, let me tell you something. Long short-term memory model was written long ago, but it is still such a relevant and such an important algorithm. So what I'm going to do for you is I'm going to be explaining you the concept of LSTMs very, very neatly. Because the problem is, in theory, RNNs are supposed to work for a long text, but in reality, they don't. Because over a period of time, either my gradients explode or either my gradients vanish. They become smaller and smaller. So the long range dependency, I may not be able to do very, very well. That is why what we do to solve the problem of understanding long range dependencies, we have a solution to that. And the solution is a model called LSTM, or long short term memory model. Sir, what is LSTM? Now, if I show you LSTM, I want you guys to understand that this is looking complicated, but it is not complicated, okay? Sir, what does this LSTM and what is this LSTM looks like? See, do you remember you had one cell of, this is just one cell of LSTM. You will take multiple LSTMs. How many inputs do you see in the LSTM? 1, 2, and 3. How many inputs do you see? 2. How many outputs do you see from the LSTM? Only 2. This and this, correct? This is the same thing. So this is not an output. C of T and H of T, correct? You have 3 input to the LSTM layer. And how many output from the LSTM layer? 2. Do you see the activation function? Sigmoid, sigmoid, and then two other activation function called tanh. Let me ask you, imagine you have a filter that will filter only 0 to 1 values, a filter that will filter -1 to 1 value. So if you pass any data to the sigmoid activator here, a sigmoid activator here, or a sigmoid activator here, output will have a number between 0 and 1, correct? Output will have a number between 0 and 1, correct? Output will have a number between 0 and 1. But if you pass the data through a tanh function or a tanh function, will the number be between -1 and 1? Here also the answer will be between -1 and 1. Are you understanding the flow of the data? The flow of the information flows. Okay. Do you see this multiplication symbol? Okay. Have you studied something called element-wise multiplication or Hadamard's product? 1, 2, 3, 1, 1, 2 multiplied by 1, 2, 1, 3, 2, 1. What is the output here? 1 1 the 1, 2 2 the 4, 3 1 the 3. 1 1 the 1, 3 1 the 3, 2 1 the 2. Can I say this is the Hadamard product? Do you see this multiplication is also element-wise multiplication? Meaning the value or the data that you get in this C state, which is called cell state, and here they both need to be of the same. Then you will get the output from the cell structure, which will be the same data. Then this particular data that you get from this cell state is also added with this together, and this is what becomes a new cell state. I'm not teaching you LSTM, I'm just giving you guys the idea. Are you understanding what I'm trying to say? You have to always understand one thing, okay? In machine learning or in any neural network calculation, try to understand how does the flow of the data works. If you're able to figure out how the flow works, congratulations, 90% of the problem. You don't need anybody else. You will be able to figure out everything. Good. So tell me guys, did you guys get the law? If paragraph 1 simply has, I love this movie, rest everything else will be 0, 0, 0, 0, 0. Are you understanding what I'm trying to say? I do not like the movie, then 0, 0, 0. Paragraph 3 will be completely filled because there is complete length, but then every other sentence will also be filled with 0. This is what you call as a padding of natural language processing. Confused? Okay, it's like an empty space. So tell me, max underscore features is equal to 1000. Guys, you have to build a vocabulary in order for recurrent neural network to work. How many unique sentences do you want to add in my natural language processing based task? What is the size of the sentences I'm creating? What is the size of my vocabulary? How good or how large am I creating my vocabulary? 10,000 sentences. Each individual words, each individual tokens, unique tokens, distinct tokens would be 10,000. And maximum length is. This means what will be the maximum length of the text I will consider after padding? Now tell me, is this making sense to you? What is maximum length? What does this mean? Or maximum length equals to 100. In any paragraph, suppose if you have a paragraph of 500 different tokens, or there are like multiple different lines. How many from the beginning will I consider for my analysis? Only the first. Are you understanding? The max length equals to 100 means this is to standardize my entire process. Tell me one thing, guys. When you deal with a textual data or when you deal with any text data, isn't the length of the data completely versatile? It is different, of different length, of different dimension, of different size. I will only include the top 100 position. I'll give you guys a very simple analogy. Imagine you want to go party in the night and you want to take permission from your mom. You go to your mom and you tell her that, Mom, I have something to ask. Even before you give her the entire context, she will tell you, you cannot go out in the night. Have you ever wondered what happens and how does this happen? Because your mom's neural network is more effective than you, or the one that you can build in your planet. From your facial expression, she will tell you that what do you want to, what's that you're expecting from her. The logic applies everywhere. Even before, rather than taking the entire sentence for my analysis, you give the model first top 10 values, it will understand whether the sentence will be positive, negative, or stuff like that. So based on that idea, you pass in something called max length, and pretty much this is what's the number, right? Okay. So what I'm going to do here is, once I have given the idea of the maximum features and the maximum length, I am going to take my X train value and I'm going to take my Y train value. I am going to take my X test value and I'm going to take something called as a Y test value. And I am going to do IMDb dot load data, and inside this number of words, there is a specific label, or sorry, argument called number of words is equal to maximum feature. Basically, it will ask you what is the library or vocabulary that you want to create for your entire training model. So can you see here, guys? I was able to load the entire data set. I was able to load the entire data set just directly. Correct? I don't need even a CSV file or a URL file to directly load the data, because majority data for me to try things out is already given in the data sets package. Now tell me everybody, I have loaded all my data, but immediately after you work on any natural language processing task, the first operation you are supposed to do is padding. Even before pre-processing, padding has to be done first. I'm going to tell you why this is the case, but you have to follow my process, okay? So if I take the X-train data and if I take the X-test data, sir, how do I perform padding operation? We will do that later. Validation is done later, Munna. We don't do it at the time of creation. We do it at the time of running the model. We just load the model, we split it while we do train test split. So that loading philosophy or train test split responsibility falls on the train test split module. You don't have to do a validation split in the beforehand. Okay. Now guys, if you ever want to do padding, okay. Oh, all right. I might create a Spotify podcast. I'm very sure if nobody would support me in the future, at least my students are the one who will always end up supporting me, right? So if I create a Spotify podcast, I would then open up all the fun stories from childhood, and then I would like sort of repeat them. But thank you, Miri. That's such a sweet feedback. Think according to the point of view of spiritualism, age is just a number. Yeah, of course. I agree. Age is just a number. I understand. So from TensorFlow dot keras dot pre-processing, I am going to import something called as sequence. Guys, remember one thing. The most important thing right now is, in natural language processing, if you ever want to do padding, you cannot do that without the help of sequence. I'll tell you how. Xtrain equals to sequence dot, look at this, okay? I'm calling in the sentence or the module called sequence dot pad underscore sequences. And very simply pass in the Xtrain data, comma, and pass in the maximum length that you want to pass. The maximum length that I want to pass is the maximum length that I have considered. Are you guys understanding here? That the maximum length I am going to be using for my neural network to include is only 100. So the max length I have also passed equals to 100. The same exact logic, if I copy it here and if I paste it here and if I go and say Xtrain, would become Xtest. and then max length equals to max length. Guys, do you see what I did here? If I take my x train value and print it to the 0th index, right? If I print it here, see now, do you see here the padding? If I take the length of x train, how much is the length? 100. But can you see here the padding operation is done successfully? And yes, x train in this case means the entire data. Understanding or not? The x train here means the entire training data, and the y train here means the entire training data. And the data split is 80-20%. Are you understanding? Automatically, when you import things from data sets, Keras data sets, the default split is 80-20. On some data sets, it's 70-30, but majority of the data sets is automatically 80-20. So we don't need to calculate it all by our own. Okay. Sir, maximum length can be taken by any number apart from 100. Do you want to take it as 120? You know what? Let's take 120. So did I take a padding length of? Is it working? 100%. Is it going to stop? No, it's working. Okay. I'm going to ask, when you have a data like this, age, salary, CIBIL score, and target is whether you get loan or not. Okay. Now you have data sets like 23 is my salary, my age, my salary is 1,20,000 a month, my CIBIL score is 820, my age is 31, my salary is say 8 lakh rupees, my CIBIL score is 821, and my age is 35, my salary is 6 lakh rupees, my CIBIL score is 820, my age is 27, my CIBIL score is 25,000 rupees, and CIBIL score is 720. Loan is yes, yes, no, yes, and no. Yes, 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 no. Okay. So now, if you split the data into two portions, this will be X data, this will be Y data. If you split the data into train and test also, this is my train data and this is my test data. This portion of the data, the one that I'm highlighting in red, isn't this what we call as X train? Okay. This data is called as Y train. This data is going to be called as X test, and this data is going to be called. Now, we are actually going to build our RNN. Okay, we are actually going to be building our RNNs. Sir, how do we build an RNN? Very simple. The first thing that you need for building this code is going to be writing down a sequence called model RNN underscore RNN will be equal to. Now see guys, if you look at this particular sentence or the import statements, I have made one small mistake. I haven't imported something very critical that can help me build the model itself. And by far, so far, you must know what I'm talking about. I am talking about layers and models. So from TensorFlow, pretty much this is going to be consistent, right? .keras, I am going to be importing .preprocessing. Okay, sorry. We've already imported preprocessing. From TensorFlow.keras, I am going to be importing both layers and I'm going to be importing both my models. These two things are going to help me make any kind of a layer that I want to have in the future. So in my model RNN, what is it that I'm requiring to do? I will say models dot sequential. Now, if you guys already remember, sequential is an API of TensorFlow where you can stack the layers by yourself. If you remember, in one of our previous classes, we have used sequentials model to build one by one by one. If you remember, in one of our last classes, I helped you build a hyperparameter tuned model. And there I also took something called sequential, because sequential to a TensorFlow means, hey, this guy will keep adding layers, and those addition of the layers you will stack one by one. So if I say model underscore RNN underscore add or dot add, inside this add, what I'm doing, I am going to be calling myself a layer. Layers dot embedding. And I'm going to pass in something called max features, comma 32. Now let me explain it to you. Don't worry. It's a very easy concept. It's not going to be very, very hard. See, the first thing that I did here, my people, is This particular line here is creating a sequential object called model RNN. The sequential API tells this model RNN that, hey, remember, later on, somewhere in the program, the guy or the user will keep adding a layer one by one, and he will add the layers using the method .add. Whatever he adds, whichever layer comes first, that will be given first priority. Whichever model layer he adds later will be given second priority. So what happened here? I created something called as a model.sequential. Not a problem, very simple thing. Now, guys, there is one more layer called embedding layer. Now, half of you must be thinking, okay, Rudra, what does it do? See, guys, the job of an embedding layer is for every single sequence of data that you pass, right? I, have, and, the, or something, right? Every single word, it is automatically tokenized, and each token is converted into a vector representation. If you guys remember, I showed you an example that if you say the word I love ice cream, I was able to convert I into a dense vector representation of 5, love as a dense vector representation of 5, and ice cream as a dense vector representation of 5. Do you remember? I showed you an example where each individual word can be converted into a dense vector representation. If you remember, agree? So what happens is, sir, how do we convert a dense vector representation? Like, how do you know what number you need to convert? Guys, what have you passed here? Have you passed here something called maximum features? Yes or no? Look at what you are passing in the model. You are passing layers dot embedding max features, comma 32. So when you pass in maximum feature, which is 10,000 is your vocabulary size, what happens to your embedding layer? Your embedding layer will encode a number between 0 and the maximum feature -1. This would be the number between which your dense feature representation will work. So for example, if my maximum feature is 500, your numerical representation for dense feature would be 0 to 499. Understanding what I'm trying to say? The integers or the layer is going to encode it in any numerical format between 0 to 499. What about 32, everybody? What about the number 32? The dimension of the vectors will be of size how much? What will be the dimension of your vector? What will be the size of your vector representation? It will be 32. So what you are basically doing, you are creating a layer. You are creating a layer. Throw sentences in this portion and output will be the vector representation of those sentences. Understanding? Understanding what I do? So review, recap, everybody, a quick recap. Sir, what is it this my embedding layer is going to do? What is my embedding layer capable of? The embedding layer is capable of transforming every word index, every single word that you take, it will pass through the layer, and once the layer is passed, or once you pass it through the layer, output will become a 32-dimensional fixed vector embedding. Did you get what I'm trying to say? Every single word index that you pass, the sentence that you pass will be converted into a dense vector. Now everybody, sir, what do you mean by sparse vector and what do you mean by dense vector? Guys, this is my favorite interview question. If you guys don't know, this is one of my favorite interview questions. What is a dense vector? What is a sparse vector? If I show you an example of a matrix like this, 1 0 0 0 1 0 0 0 1, is this a sparse vector or is this a dense vector? Do we call this as a sparse vector or do we call this as a dense vector? This is called as a sparse vector, a sparse matrix. Why sparse? Majority of the matrix is empty. Majority of the matrix is empty. But what about now? 169216. Is every single value filled? Is every single value utilized? Is every single space utilized with the number? This is what you call as a dense representation. Understanding? This is called as a simple dense representation. Now tell me this. You guys were able to do what? Create an embedding layer where your maximum feature is 0 to maximum feature minus 1, meaning the integers that will be encoded will be between 0 to maximum feature minus 1, which is 9999. This is your encoding type. This is what I've written here. This one single piece of line is going to make sure that every single text will be converted into number. Every single text will be converted into a number, and I don't need to worrying about converting into a token, converting into a number. No, automatically that is handled by this piece of code. Now, if I say model underscore RNN is equal to or dot add, sorry, what am I going to do here, guys? I am going to add layers dot, I am going to write something called simple RNN, not cell, simple RNN of size 32. Now, in TensorFlow, you have something called simple RNN. Simple RNN is the most simplistic of the RNN cell that you can apply. The number of neurons in the RNN cells are 32 also. Meaning, how many cells one after another am I keeping? How many cells have I created stack by stack, one by one next to each other? What's the number? 32 cells, one after the other. Now let me ask you a question. Sir, if you have created a dense vector representation or dimensional 32 dimension vector, do you have to keep the number same? The answer is no. This embedding representation and the model representation have no reason for each other. Any reason for size 32? Love this question. Haven't I taught you that everything in mathematics and in deep learning, it goes by the numbers 8, 16, 32, 64, 128. Haven't we all practiced this since the beginning of the time? So rather than giving a standard number 9, 14, 27, 34 and 68, rather than going randomly like this, we can always create a standard to how we move forward with the neural network. So this is just some of the practices that we do in the neural network. So that is what you must have seen also, Munna, that I have built so far a layer of 64 size, 32 size, 16 size, 8 size, then 4 size, and then the output is neuron is 1. So this is sort of like the practice that you follow. Okay. There is no specific reason why I'm writing this. Correct? So guys, in this representation of my neural network, which is an RNN, what will be my input size and what will be my output size? My input size or my input shape would be the sequence length that I'm passing, which is dense representation of 32 with 32 neurons. This is how my output layer is going to work. Now, once you define this, what do you do, guys? Do you have an output layer in this? Even if you have written the recurrent neural network, where is the output layer? Don't we want an output layer? So tell me one thing, model underscore RNN dot add layers dot, guys, I want to create a dense layer, right? Because at the end of my output, I am looking for a classification. My activation is equal to sigmoid. Why sigmoid, everybody? Why am I writing a layer in layer.dense where my output is sigmoid? Because at the end of the day, I want my prediction like how? Classification. That is it. How will you connect a 55 vector with 32 neuron? Is this my RNN? Let's say I feed an RNN a number like this. I love ice cream. Now tell me, I want to prove and predict whether this is a positive sentence or a negative sentence. So do I need an output on these two cells on the top? No, I don't need an output on both the cells. I don't need them. I only need the output here. No, positive or negative. My output will come only from this direction, positive or negative. Now tell me one thing. It's a simple question. Now this is not a very complicated situation as such. If you take the sentence, I love ice cream, and you convert I into a 32 dimensional vector. Can I pass in a 32 dimensional vector? If I don't want to pass a 32 dimensional vector, can I increase the vector size to 52? If I don't want 52, can I pass in a dimensional vector of 98? Guys, does the size of the dimension of the vector matter? Not much. You guys can survive without that. Now tell me this. This is a 32 size vector. This is a 32 size vector. This is a 32 size vector. Now do you understand how am I able to connect my input to this? Get the logic? So what did you do? You took each individual sentence, converted that to a dense vector representation and passed it to the RNN. So do I even bother with the size 32 here and the size 32 here? Niente. No. In an RNN, you have a sentence, you have a sentence, and you have a sentence, or you might have a word, and you convert that into this, okay? Every single sentence, every single word has been converted into a dense vector representation, and a dense vector representation, okay? Now, once that particular thing happens, and what happens is you pass that dense vector to the neural network. This neural network is only going to have one output, which is positive and negative, and there will be no output here. There's only one output, positive and negative. Once you pass the data in each individual cell, now tell me, you might have one more question. Suppose, sir, if I have an RNN of the size 32, how many neurons have I taken in the RNN, guys? 32, yes or no? Okay. Then if you pass in through this particular data, there is only 32 neurons, and my padding size is what is my padding size, everyone? The pad size is what? 120, correct? So tell me, 32 sequences will pass here. But what about the other sequences? If 32 set of sequences will pass over here, what about others? What will you do with others? I have a simple question. Very simple question. And I'm asking you in the most simplistic of the sense. If your input neuron size is 32 and your padding sequence is 120, what happens to the other? Let me explain. What is the input RNN structure? Do I have an RNN with 32 size next to each other, right next to each other? 1, then 2, then 3, and dot dot dot, 31 and 32. These are your connections of RNNs. Okay, I'm going through some basics right now. Everybody, have you heard of the concept called tokenization? So the first sentence is I love ice cream. I love ice cream. Ice cream. The first step is the entire sentence is one, correct? The entire sentence is one. The next step would be to break individual sentence into individual token. I love ice cream. Everybody, this is the first step called tokenization. After tokenization, my recurrent neural network goes through something called integer map indexing. It's also called word to index mapping. Index mapping, mapping. Sir, what do you mean by word to index mapping? Have I created a vocabulary of 10,000 words? Everybody, 10,000 words. Have I done 10,000 words? This particular process that I'm teaching you right now will apply to generative AI, natural language processing. It will apply to anything that you deal with text. So what I'm teaching you right now is ultra super basics. So I want you guys to just stay quiet for like 5 minutes and keep your ears up. If you have a vocabulary, and if I increase the vocabulary, tell me one thing. From this vocabulary size, do I build vocabulary, and then vocabulary will have the words and I will have the indexes? Yes or no, everyone? I will have both the indexes and the word. So say the zero index word is, say for example, wrong, W-R-O-N-G. Just like that, for example, if the word I maps to the input sequence 42, love, L-O-V-E, love, maps to the word, I don't know, 76, example. So let me write it down nicely. My handwriting isn't that great. I will map to the sentence mapping 42, example, comma, love will map itself to the number, what did I say? 75, right? Okay, 76. Okay. So, and ice will map itself back to the word 103, suppose. And cream will map itself back to, or ice cream, oh yeah, there's a hyphen, right? Ice and cream also will be separate. Cream will map itself back to, I don't know, the word 215, example. So did I create the word to index mapping? I love ice and cream individually. To my embedding layer, the embedding layer that I have written here. Do you see this particular thing called embedding layer, everybody? This embedding layer? This embedding layer. To my embedding layer, you know what I will pass? I will pass the number 42, 76, 103, 215. I am passing the words only. I am passing the word. But rather than passing I, love, ice and cream, am I passing their indexes? Am I passing each individual indexes? Now my question is simple. Each individual word index will be converted into a 32 size dense vector representation. This will be one 32 size dense vector. This will be a 32 size dense vector. This will be a 32 size dense vector. Did you understand? Now tell me, did you have to write a program for this at all in TensorFlow? Did you have to tell TensorFlow to do all of this? No. Did TensorFlow take care of all of this by itself? The answer is yes. This is why TensorFlow is one of the most powerful things. If you repeat the word, dictionary does not allow one thing, and that is mutability of keys, correct? Meaning, if you have a word called love, and if you have a word called amore, okay, they both mean the same thing, but they both have different sentences. So the word index 1 would be love, and the word index 2 would be amore, right? But if you repeat love once again, the key need to be unique in dictionary. Everybody knows this, right? In a dictionary in Python, you cannot have duplicate keys, but you can have duplicate values. So new key 3 and love will be created. But in TensorFlow, repeated words are never given extra key or a new key. Understanding? A new word, a repeated word is never introduced itself in the dictionary. It's not allowed. You don't get it. Now everybody, if I come back to this particular layer and run the layer, is the layer going to make any sense now? Any reason 32? Rather than taking my input neuron size as 5, the other neuron as 8, the other neuron as 30, the other neuron as 65, the other neuron as 87, in programming, can I handle it like this? 2 to the power of something. I will first take 4 neurons, then 8, then 16, then 32, then 64, then 128, and go on and on and on. Could I have a standard process in my programming to keep my neurons in the size like this? Every single neuron that I take, I have either taken the neuron size dimension as either 16, 32, 64 and 128. Do you guys remember? When I was teaching you guys hyperparameter tuning, I did this entire exercise. I went through the entire exercise. To me, hands-on programming is more important than theory. Frankly, I'm not gonna lie to everybody here, okay? Let me be upfront with you guys. If any day, if you ask me theory versus hands-on, I will always prefer hands-on. But guys, theory builds foundations. Because we did that, in those sequence, we were able to understand that we were able to build a neuron or every single neurons to the power of something, correct? This is why we do this, okay? Now, the question that I asked everybody was that if I have a RNN cell connected to each other side by side of the size 32, how many neurons do I have here? 32. 32 neurons. And each individual sentence padding that has been done with a padding of 120. Agree, disagree? My entire 120 sentence has been converted, correct? Do I pass this 120 in my answer, or do I convert 120 in a 32 size vector and pass the vector? Please tell me what's the answer. Do I pass the 122 size letter or sentences, or do I convert them into a standard 32 size vector and then pass? We convert them into a 32 size vector and then pass. First of all, if I have a large paragraph, everybody listen to me. If I have a large paragraph, from the entire paragraph, do I only take 120 first words? This is what I call as my maximum length. I have a large paragraph. I convert this into a 120 sequence. Okay. When I say 120 sequence, even if my paragraph is larger, Do I deliberately choose to ignore the last line? I am not taking the last line at all. I am only taking the top 3 lines because they are 120 characters, 120 words. Agree, disagree? Sir, isn't there an information loss here? The answer is yes. But tell me one thing. Usually speaking, the first 120 characters are sometimes enough to give you the idea whether I'm saying positive about the review or negative about the review. Agree or disagree? Even if I don't take the last one, I'll give you guys an idea. Okay, listen to me carefully. I love Delhi. It's a very nice city with numerous food options. With numerous food options. I love this city because it has nice parks. Example. So let's say you said a sentence that I love Delhi because it is a very nice city. It has numerous food options, right? And I love the city because it has a lot of nice parks. Example. Now, if I take only the top 2 words, I love Delhi, it's a very nice city with numerous food options. I love Delhi. This sentence, isn't that giving me information about what the context of the conversation is? What is it the guy trying to talk about? Is this guy saying positive things about Delhi or negative things about Delhi? So tell me, rather than taking the entire sequence of the word, would I take like a portion of it and try to get the gist of the conversation? Okay. I am very sure you guys have taken a wrong assumption for padding. Okay. First of all, my sentence is larger and I have only taken a segment or a portion of the entire word. So now the entire sentence that I gave, do I need the entire information? Do I require the information completely about the entire sentence that I have this? No, you don't. You have only 2 sentences that I consider, and that would make my RNN absolutely. Is it possible to divide every 120 word vector and then pass? No, you can't do that. This is not possible. I mean, it's possible, but you don't do that. It's possible. I'm not saying it's not possible. It's definitely possible. You can do it, but usually it's not done, Munna. Okay, it's not done. You don't do that. After my neural network has run, everyone, I want you to listen to me carefully. After my model has been run, do I have to do something called model underscore RNN dot compile, everyone? Do I have to do model dot run or sorry, model RNN dot compile? And inside this, the optimizer that I'm going to be passing is the Adam optimizer. The loss will be, since I'm doing a binary classification, what do? I say binary cross entropy. Binary cross entropy. And what will be the metrics? What are the metrics? If you remember, we have always passed the metrics as accuracy, if you remember. Now, once the model.compile is done, do I have the history, HISTORY, history of RNN is equal to model RNN dot fit. So here we are taking for sentence, if data is coming from online, then in case how we will handle. I will also teach you that. Even if it comes online, aren't you breaking the sentence into maximum length of 120? Suppose if you have created an app, on that app somebody is typing. Even if somebody types a 120 long character of positive or a negative review, it does not matter. Guys, what does padding do? I love Bharat. This is my country. Okay. I love eating, what do I say? I love eating healthy food, but sometimes I have cheat days. I love yoga and I also do social work and I love it. Now, tell me this. Let's try to understand this. How many sentences or how many tokens do I have in the word this? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Suppose this is the given data set in my problem statement. This is what on which I have to run my neural network. This is the data on which I am going to be working. The maximum length, the first thing before you do padding is to calculate the maximum length data. Which data set has the highest length in terms of sentence length? Is it 1, 2, or third? The last one. I love yoga and I also do social work and I love it. Now tell me this. Either I can take the maximum length, max underscore len, maximum length of 6. So can I say I can take a maximum length of 6 here? I said I want the maximum length to be 6. 6, 6, 6. What did I do here, everybody? Uniform batch size. So you do take a batch size, but that remains uniform. Okay. Comma, explanation, special characters are not included. In tokenization, they are removed. Question mark, at the rate, exclamation, they are removed. It's not to be included. It's to be excluded. We don't need it. Padding is used. Suppose, what is the maximum length that I have taken? My maximum length is equal to 10, for example. What is the maximum length? 10, not 6. I am saying 10 now. So can I say this sentence can automatically take 10, the 10 inputs here? Can you see here? Observe. This is the 10 input value and this is the 10 input value. Did I require any padding in this sentence? Did I require any padding in this sentence? No. What about this? Did I require any padding in this sentence? No. But now, will I require padding in this sentence? So 7, 8, 9 and 10. Are you clear with the concept of padding, everybody? Padding is not for the longer sentences. Padding is, if there are shorter sentences, how will I fill the rest of the numbers? That is what padding is. All right. So tell me, if I pass in the data X train data, comma Y train data, what else do I need to pass in this? Do I need to pass something called epochs? How many epochs do I pass? 100. What about next? What about the batch size? Should I pass it 32? What about the next thing? Oops. Yeah, what about the next thing? Validation underscore split. What validation split do I give here? What validation split do I give here? 20. Verbose equal to 1. Am I done? Run it. Validation. Yeah, spelling. I cannot believe sometimes that I have become a data scientist when I'm so terrible at spellings. But it happens, right? Everyone cannot be perfect. Okay. So I think we've run almost. We are done. And we are done. Okay. So guys, our neural network is trained, it's run, and we are ready to test and validate it. Okay. So now that we have run the neural network, okay, and we have actually run the entire cell, which is the history of recurrent neural network, and we have compiled a neural network. Right after compilation, what is it that we do? Everyone, if you guys are aware that after running a neural network, what is it that we actually check for? Don't we check for something called as the test loss? No, we don't print the summary. We print the test loss. So if I print test underscore loss underscore RNN, comma test underscore accuracy underscore RNN is equal to model RNN dot evaluate, and in the evaluate part, I will pass in the X test and I will pass in the Y test. So if I pass in X test, I pass in Y test, what answer do I get? The overall accuracy improvement has been close to be 80%. I'm assuming it will reach 80. Yeah, 78.93. And the overall loss that has been decreased throughout the model is 1.122. Now, you guys know that this is not something I personally prefer, and I've always been very vocal about it, that you know what, plot.figure, always plot the model versus validation loss graph. So figure size is equal to, let's say 10, 5. Okay. Plot. Guys, what do you plot? History underscore RNN. How do I do it? History, HISTORY, history underscore RNN dot history of, if I take two different things, history of, first I will measure the loss and validation loss. So I'm going to take copy loss, paste loss here, and I'm going to call this as my label is equal to training loss for RNN. Okay, but let's just keep it training loss itself. Let me copy this. Let me paste it in the bottom. Instead of loss, now we will take something called as a validation loss. Copy this and paste validation loss. So apart from training loss, I will say validation loss. After validation loss is plotted, I will say plot.title. And inside the plot.title, I'm going to say that this is a loss versus validation versus loss graph. Validation versus loss graph for RNN. RNN. And plot.x label. X label. Inside the plot.x label, I'm going to call this as epoch. And plot.y label, I'm going to call this particular thing as loss. Do you want me to plot legend? I will also plot a legend. That's great. And plot.grid will be true. And run this. Tell me, wow, this is such a terrible graph. 6, 7,5. Okay. Wow, this is not as what I expected it to be, but it's okay. Because of the size of the epochs, did our model perform well? Not much. Do you see the output? The loss is decreasing, but the validation loss is increasing. Yes or no? Can you see? History RNN, validation loss. Why is this happening, everybody? The reason this is happening is because how many epochs have I given? Only 10. Meaning the recurrent neural network did not learn the patterns behind the data that well. But it's okay. Since this is only for us understanding, we understand. Tell me, what about accuracy? Let's take accuracy, copy this and paste it. This is accuracy, training accuracy. And what about validated accuracy or validation accuracy? Copy this and we will paste it in the bottom here. So validation accuracy here and validation accuracy here. Accuracy here and Control Z, sorry. Yeah, it's in the bottom. The validation accuracy here. So validation accuracy here and run this. What about your validation accuracy? Not that great. Not that great, right? So the RNN performed, but not that great. It did not perform to our expectation. We wanted it to perform to a certain level, but it did not perform to the level that we wanted it to perform because the number of epochs that I've given is lesser. Agree, disagree, everybody? I have tried my best, but this is the maximum it was able to perform. Now, guys, imagine you want to make predictions. Okay. Let's say you want to make predictions. So predictions underscore RNN will be equal to, let's say, model RNN, which is what I have written, which is model underscore RNN dot predict. Can I say, I want you to predict, okay, say PREDICT, predict from X test. So from X underscore test, which is my test data, from sentence number 3 or review number 3 to review number 10. So if I want to make a prediction like that, so for I comma prediction in enumerate of, let's say, predictions underscore RNN. Okay. So for all these variable, if I say sentiment will be equal to, sentiment will be positive if the prediction that I have calculated is going to be how much? So the prediction that I calculate will be up to or greater than 0.5, which is my threshold value. Else it will be negative. So negative, right? It will be negative until here. So I will print F double quotes of review for the ith index plus 1, because in Python we go with the negative indexing. The predicted sentiment would be, I think I can say something like this. Pipe operator predicted underscore sentiment would be sentiment, and pipe operator, the actual sentiment that I have would be something like this, right? So the actual sentiment, ACTUL, actual sentiment would be positive. So actual sentiment would be, wait, how will I say it? Actual would be positive if the Y test that I have for the index equal to 1, else it would be negative. So if, Okay. Wait. Is that correct? Wait. So negative, positive, negative, positive, and positive. So I will say this is positive and this is negative. Okay. Run this. Okay. So tell me this. Okay. Tell me this. I hope you guys know that this is called slicing in Python. Okay. Let's say pd.dataframe. pd.dataframe. Did I import pandas here? Oh, I did not import pandas, right? So let me import it here. Import import pandas as pd. Run it. Come over here. pd.dataframe. pd.dataframe. Inside this, let me take a value like this. Name. Control Z. Let's say name. Okay, I'll include Jagdish. Jagdish. Let's say Toby. Let's say Pallavi. Let's say Aparna. Let's say Shiv. Let's say Praveen. Okay, Praveen. Let's say age. So what would be the age? Jagdish is 23 years old. Toby is 45 years old. Oh no, Toby, sorry. 30, no, we'll make him 16. Toby will make Toby 16. What will make Pallavi? Pallavi is 6 years old. And Aparna is 5 years old. And Shiv is yet to be born, but we'll put him as 4. And who else is remaining? Praveen is remaining. Praveen will be 12. Okay, we'll give it like this. So now that we have given such answers, tell me, if I print my pd.dataframe directly, do I have these answers? So tell me, if I take this the variable as a is equal to and print a of 2 to 4, if I print, only Pallavi and Aparna got printed, no? Only the second index and the fourth index got printed? Yes or no? The slicing part. Do you see? I'm choosing a specific row. Jagdish Bade Bhaiya. Yes, Jagdish is the big brother, the elder brother among the entire family, of course. So now tell me, I have taken only 3 to 10 data set. Yes or no? Do you guys know what enumerate does? Everybody? I hope you guys learned what an enumerate does in Python. You guys know, right? It will give you the value plus index both. So tell me, all I'm doing here is for the value comma prediction in enumerate, I am saying the value will be positive if the prediction is greater than 50% probability, else it is negative. And that's it. I'm printing it. So see, my actual sentence is negative, my prediction is positive. My actual sentence is positive, I predicted positive. Actual sentence is positive, the predicted sentence is negative. Actual is negative, I predicted positive. So my model is performing terrible, right? That is of course known because the number of epochs that I've given here is incredibly lesser, right? Only 10. Not so good. How can we fix this? I increase the size of the epoch. I increase the size of the batch. It will be able to perform better. I'll give you guys an example. What is the batch size that I've taken here, everybody? What is the batch size that I've taken here? 32. If I make this 64, look at the result, okay? Give me 1 second. Let me rerun the whole thing once again. Give me like 2 seconds. Let's see the difference in if I change the batch size, does it do something else? Let's try to get that understanding. So let's wait for the prediction, okay? Okay, nice. So give me 1 second, guys. Let's get the answer to this. I want to try something. I want to show you guys a little something. Let's get the plots ready first. Oh yeah, the epochs are going to take some time. In the very beginning, I told you accuracy is not a good score of a model's performance. Do you remember? It's also the labels on how individual labels it performs. That is also important. If you have a model with 83% accuracy and a 92% accuracy, just because it's 92%, are you sure the precision and recall for the label 0 and 1 is good? No. Sometimes the balance of 0 and 1 in 83% is better, and that is why it is good. Is early stopping the only way to check the best number of epochs and batches? Okay. So Toby, early stopping is not a way to check best values for epochs and batch size. That's not the job of early stopping. Early stopping is built so that imagine you have given the model for 500 epochs. You want your model to run for 500 epochs. But the model has reached learning saturation in 300 epoch itself. The model says, enough man, I have learned the patterns. How many more epochs do you want me to run? I have learned my lesson. You will say, no, 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 there is 200 more. So when the model runs or understands everything by 300 epochs, you will stop it. So tell me, the last epoch you saved, isn't that the best epoch for the model? You got what I'm trying to say? That is the maximum you could push the model. So yeah, that's how you know it. Got it? Nice. Okay. Good. Guys, until the epochs, okay, they have run, is it? Okay. How about now? Do you see a clear difference in the loss? Forget the validation loss, but there is good training loss. There's a steep training loss. What about accuracy? Steep training accuracy. What about now? What's the overall accuracy like? The overall accuracy has been somewhere close to 0.7809. So can you see here? Significantly better? No. I mean, terrible, still terrible. But yeah, there is a slight hope. The problem here is the batch size cannot do anything until and unless you increase the epoch size. Make sense or not? Until and unless I increase the epoch size to maybe 100, maybe 200, maybe 500, I don't know. So guess what? Your epochs need to be increasing. They need to be larger in number for your life to be simple. Now tell me everybody, did I run a simple RNN and I got this answer? Everybody, I was able to run a simple RNN and I got this output, this weird looking crazy output, which I'm not very happy about, but there is not much I can do because the CPU that I have is terrible. Wait, let's also check runtime. Let's actually check runtime because I think oh yeah, we have a T4 GPU also. Give me 1 second, guys. Let's try 50 epochs. If we can get like a better answer, I can do a tuning on this. So let's say if I have like a 50 epoch model, okay, my value is connected. Let's see if the epochs runs faster. Let's hope for the best. So maximum feature, downloading data, training Y-train, padding done, model done. Now this is the epoch. Okay, consistently better. Do you see the difference between the GPU? The epoch size and the speed has actually increased, right? That's one of the beautiful things about GPUs is they make things work faster. Nice. So let's let the whole thing run for a second. Any source tool in Excel, YouTube. Can we also classify the score as 0 is negative and 0 to 0.5 is neutral and 0.5 are positive and activation to be changed to softmax? Yeah, you can do that. But you have to be careful when you do this because you're going to get some very terrible results and it requires a lot of tuning. You need to do a lot of tuning. And at the second thing, if you only have a positive and negative label, trying to identify neutral with the probability is very complicated, very, very hard. So to pinpoint that is very, very complicated. But you can do it. Yes, you can. Apply softmax, not sigmoid, and you should be able to get 3 label: positive, negative, neutral. Okay. So run. I'm very sure that the epoch size of 50 is definitely going to do better than an epoch size of 10 because RNNs usually require larger epoch sizes. They don't work with basic epoch sizes or smaller epoch sizes. They don't function that powerful. 47, 48, 49, 50. We are almost done. And we are done. One more epoch. And finally, test loss 81%. It will be more. 80.98, 1.55. Okay, validation loss, validation graph. Okay, positive, positive, negative, positive, positive. Okay, a slight improvement of about 1.1%. Can you see? Meaning this neural network is an easy neural network that will go with a minimum to minimum 300 to 400 epochs. Minimum. It will require 300 to 500 epochs in this model to at least let it start running something. Understanding? Getting what I'm trying to say? Everybody? Good. Good. So tell me everyone, you just wrote a program for recurrent neural network. In practice, where do we need to run epoch size of about 500? How do we do it in order to maximize time? Okay. So imagine you are trying to build a machine learning model that understands the positive sentiment and the negative sentiment. If you have two different sentiments, you have data and you have a positive sentiment and a negative sentiment. When the data is given to you as developers, what happens is you are going to be running multiple different model types, correct? RNN, LSTM, GRU, logistic regression, XYZ, isn't it? You run multiple different models. Whichever model is giving you consistent and reliable result for both label positive and both for label negative, you will choose that. Let's say LSTM was able to perform the best. What you do is once you know that LSTM is performing good, then you go ahead and hyperparameter tune the LSTM model for perfect accuracy. Understanding what I'm trying to say? Pinpointing the epoch, pinpointing the batch size, pinpointing the number of neurons that you want to give. You put effort into the model after realizing that this is performing better than everything else. Once that model is done, you train the data on LSTM, you save the model, correct? You save the model, and once you save the model, what do? You upload it on the server, and then the server instance will take this inference. Are you understanding? In practical settings, this is how you work. You don't just run a model on a random algorithm and expect the results to be great. We don't do that. We run the model, we check whichever is the best output, and then we proceed from there on. You run it on your Jupyter notebook, you put that on a server, your job is done. End of story. You don't have to worry about anything. Okay, good. By the way, guys, I'm just a little bit curious. How many of you have actually thought of running AWS or Azure, Microsoft Azure or Amazon Web Services? Did you guys ever think about it that I might or you guys might need to learn this as well? If all these models of sentiments, churn, prediction, risk, etc. are already built and loaded, what do data scientists do in an organization? Just a query? No. Let's say 2020, one of my favorite cars, Verna, was launched. Okay. Now suddenly, after 2020, we are currently in 2025. Do you think that there is no scope of improvement from the previous version of the car to the new version of car? There is always a scope of improvement, everybody. Always a scope of improvement. If you have a data science based model, LSTM based model that was built by the previous data scientist, haven't you added new data, new information, new analysis, new features, and you can absolutely build a new model? So remember, in any organization, specifically for data scientists, you don't have time to breathe. There is so much work. Model building, model validation, model testing. Forget that. You also do code testing by yourself. So this is the thing. You always will have something to work on. And by the way, just letting you know, since I come from finance background, did you know that we don't just use classification, regression based model? We also do time series analysis, customer segmentation, anomaly detection. My department, the department that I work for, that I lead, is credit card fraud analytics. So we do fraud analytics, and that is one of the hardest thing to do. In understanding fraud analytics, like it's very hard to do fraud analytics, right? To understand who is possible, what is a possible fraud even before it's happened. Think about it. And we have to do this with a very good accuracy. It's not easy. We are always constantly changing our model, monitoring the model. We are constantly taking the customer data. We are trying to fix customer data. That's crazy amount of stuff that we do. So any kind of credit fraud that happens in our country, and by the way, I mean, if I can be kind enough and tell you, India has one of the best banking system in the world. Let me just tell you this right now. I have worked with American banking system. I've worked with European banking system. I've worked with majority of the banking system of the planet. Indian banking system is the best. It is so rigid. It is so controlled that you cannot mess with the banking system. You can't.
Just a quick info guys, Intellipaat offers artificial intelligence course training which will enable you to learn skills like neural networks, focusing on CNNs, RNNs and their application in AI, natural language processing, computer vision and generative AI. Through this course, you will also master deep learning concepts, AI model building with TensorFlow, transformers, BERT, GPT, LangChain and NLP pipelines with advanced techniques like image recognition, chatbot development and much more, all taught by top 1% experts and IIT faculty. And with this course, we have already helped thousands of professionals make successful career transitions in AI and data science. You can check out the testimonials on our Achievers channel. The link is in the description below. And without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take your first step towards the dream career growth in the field of artificial intelligence.
Now that we've understood how recurrent neural networks work and seen their implementation, let's address one of the main challenges: the difficulty in remembering information over long sequences. This is where long short-term memory networks or LSTMs come in. They are a special type of RNN designed to retain information for longer periods and overcome the vanishing gradient problem, making them highly effective for tasks involving long-term dependencies. Let's see them in detail in the next section.
Can we please quickly understand what is vanishing gradient problem and what is exploding gradient problem? The problem with recurrent neural network. What is one of the biggest problem of any recurrent neural network? A recurrent neural network will have multiple different situations, multiple different states. One of these states is while working with a recurrent neural network, while training the model, what happens is you usually use activation functions to solve your problem. Now, in a recurrent neural network, when you unroll a recurrent neural network, it will look something like this, right? It has its own feedback cycle. It sort of rolls like this. This is where your input values are, and this is where your hidden state is. And this is where your output is. Y1, Y2, Y3, whatever you want to call it, right? This is your output. What happens is while you work with a recurrent neural network, while performing back propagation, you know for a fact that while performing back propagation, we calculate something called gradients, okay, which is loss function. So for example, eta loss with respect to, I don't know, eta weight 7 or del weight 7, del weight 2, del weight 3. There are multiple weight values inside the unrolled neural network. While calculating the loss function, every single time you go backward, the gradients become smaller and smaller and smaller and smaller and smaller and smaller until they become so closer to zero that before you even go forward in the neural network, the effect of gradients have no effect. There is no possibility of the weights being updated. We already have learned this. I'm just reminding you that you guys have learned this. If you remember, I taught you the concept of a normal feed-forward network where your output prediction is dependent on weight 7 and weight 8 of the neural network. So if you remember using the chain rule principle, the loss function is dependent on the Y predicted output. Y predicted is dependent on weight 7. So if you remember, the backward we go in the neural network, the loss function that we calculate with respect to weight 7, weight 8, and the more we go backward in the neural network, the gradients become smaller and smaller and smaller until you do not see any effect in the gradient at all. Meaning they become so small that updating weight makes no sense. They are just so smaller. They shrink in such a way that their losses and any other calculations not going to make much sense because the derivatives are so small. That is what a vanishing gradient is. Sir, what about exploding gradient? Completely reverse. When you do the back propagation and try to solve the problem for gradients, they become greater than 1. Meaning they become so greater at the time. So I'll give you guys a very simple example, right? Let's say a number which is, how do I say this? Yeah, 2 to the power of 50 or 0.2 to the power of 50. What is the difference between both of them? 2 to the power of 50 is an extremely large number and 0.2 to the power of 50 is a number approximately closer to 0, correct? It's an incredibly great number. It's an incredibly small number. So tell me, what is the most craziest thing that you're dealing with? Either the weight value is too large so that the overall gradient size is so great I cannot calculate it, or it's very hard to calculate, or a size of the weight value so small that no matter what you do, a higher weight number is only going to make it closer to zero. So what happens is, you can also think of it like that uh, the more neural networks you own or you have, that many unrolled neural network to the type or to the power of weights. So weight to the power of number of unrollment could also be one of the instances why loss function is calculated. So the point I'm trying to make is, in gradient, exploding or vanishing gradient, you will have two things. Imagine you are holding an item in your hand which can explode at any time or which cannot explode at any time. Rather than doing the job it is supposed to do, it could either be destructive or it could either be a completely nonsensical, unimportant tool. So recurrent neural networks are one of those tools where you don't know when will it explode or when will it vanish. So this evident risk you will always carry when you're building a normal vanilla recurrent neural network. When I say vanilla, I'm talking about simple. A simple recurrent neural network will always have that risk. Okay, a recurrent neural network in theory is supposed to maintain sequential order of the text, at the same time remember text for a long period of time. You said a sentence and the sentence looks like this: I have been to Spain. I love Spanish. You see, the relationship between Spain and Spanish, I want to retain over a period of time. Now, in theory, recurrent neural networks can do this well, but in practical setting, this actually never happens. The reason is, the longer the sequence you give, the chances of exploding gradients and vanishing gradients occurring at in your problems are also larger. And also larger the sequence, recurrent neural networks actually fail over a period of time, because recurrent neural networks have no context of something called memory. So the more the sentences is, the lesser and lesser do I forget or remember the old sentences. So if the sentence size increases, maybe I'll be able to remember this much. But older text messages, I keep forgetting because my memory span isn't so much. Now this was one of the most big problem when dealing with textual data. Because the problem with textual data, everybody, I want you guys to acknowledge this. Don't you think when we humans deal with text, we deal with millions and millions of text lines? Imagine if you want to buy an insurance for yourself, haven't one single insurance profile has like 9 to 10 pages, and each page has like minimum to minimum 8 to 9 paragraphs. If you ever want to write a machine learning algorithm to help you understand what is it mentioned in the insurance document, man, are you not dealing with each individual word, and each individual word is so large that no matter what algorithm you apply, the previous words are going to be missed, but I want them to be remembered. In such conditions, what is the best possible situation or scenario for me to use? So for this problem, my people, in recurrent neural networks, when you encounter vanishing gradient and exploding gradient, to solve this problem, scientists came up with an algorithm called LSTM. Now guys, I want you guys to understand one thing. Without LSTMs, we would not have the baseline understanding for transformers. And without transformers, we would not have GPT today. So they are both equally connected to each other. Remember this, they are well connected algorithms and well connected concepts, right? Sir, what is LSTM? LSTM, my people, is long short-term memory. Long short-term memory, okay? The full form of LSTM is long short-term memory. Long short-term memory deals with the problem of vanishing gradient and exploding gradient gracefully, meaning it is able to handle, it is able to deal with long short, it's able to deal with vanishing gradients and exploding gradients, also retain long-term memory in the text and a short-term memory in the text. This is one of the reasons why it is one of the most powerful algorithm even till today. Even today, LSTMs are very powerful techniques and algorithms to handle long-term images. Okay. Sorry, long-term sequences, what I'm talking about. So in order to deal with this, how does a LSTM actually work and what is the baseline philosophy behind LSTM? Now, I don't want you guys to feel a little, how do I say this? Overwhelmed with the diagram because it's actually very easy. But yeah, I'm just gonna show you guys an example of this particular diagram here and we'll try to understand how this works, okay? Maybe I show you like a better diagram. Yeah, not this. Let me copy this. Tan H, sigmoid, tan H, sigmoid. Yeah. Copy image and paste. Okay. If you guys are able to see this image, this is what each individual cell of a long short-term memory looks like, or LSTM cell or the LSTM cell block looks like. Now, guys, if you guys want to understand what LSTM actually does, okay, we got to address the point of what LSTM actually does. So rather than going through this diagram, I think I would rather teach you the diagram in my own sense. So give me 1 second. Let me draw like a better looking diagram. So wait, let's take a black color cell. Okay. Let me do this. Let me do this. Let me do this. And a cell like this. Okay, this is looking fine. Okay, fine. Let me move this a little to the bottom. Okay, fine. All right, so now I will draw the diagram slightly differently. Okay, so I will take a small box here. So, okay, Control Z, 1, 2, 3, and 4. Right, so I will copy this, paste, move this towards the left, paste, move this towards the left, and paste, move this one towards the left. Okay, so wait, move a little to the left, move a little to the left, a little to the left. Okay, let's also take one more box. Let's take a box a little larger, and done. Let me copy this as well. Copy and paste and paste and paste. Maybe control, yeah. So move this somewhere here. Move this somewhere here. And one more somewhere here. So I need to remove this. Okay. Now move everything to the left. Balance this out with the center point. Okay. Or maybe I could just copy paste these center points, right? Yeah, this makes more sense. Copy paste. This would be another one. Paste. This would be another one. And this would be another one. So 1, 2, 3, and 4. Okay. Now I can introduce a pointwise multiplication. So Control Z, a pointwise multiplication. And there is also something called as a pointwise addition. This is what the update gate. Right, let's also take 4 values. Okay, so let me also add a tan H activator here. Somewhere here. See, straight, down, down. See, straight. Okay. a pointwise multiplicator here, and we will have the updated output, which is the updated short-term value. So let me copy this and let me put it in the bottom. Control Z, not straight. Okay, straight and straight. Okay. Now let me make this a little larger, and let me make this a little bit more extended. So Control Z and one more. Okay. Now move this to the left, balance it out here, and done, and extend it until here. Okay, great. Now, how do we use it? Okay, we will take two straight lines. One line will pass like this, and move this line a little to the top. Yeah, makes more sense now. Let's take one more line, starting with the same exact logic and starting here. Okay, maybe move this a little bit on top too. That's fine. So now every single value of this will connect to 1, or maybe I can make it even better, right? I can make this in red actually. So red line is the updated weight line. So h of t minus 1. Now I will pass h of t minus 1 here, h of t minus 1 here, h of t minus 1 here, and h of t minus 1 here. That's correct. Okay. And I will take another green line here, and this would be my short-term memory value, which is actually my input value, and this is going to be passed directly here. So green line connection, a green line connection here, a green line connection here, and a green line connection here. Okay, this is good so far. Now I will also take a cell state, but I will take it in a red color bar. So this is going to be a continuous value. So this, a pointwise multiplicator, and until here, or rather, I would just say that this is the value that passes on. So Control Z. So maybe this is the value that passes on. Logically speaking, it should pass on as it is, right? So let me erase this box. Actually, it let the cell state continue outwards as it is, and we will be able to pull one of the updation state, which is this value here, have a pointwise multiplicator, and one of the pointwise multiplicator will give me both the state output in the outward direction. One is the current time step, and the other one is going to be the updated time step. So again, one bottom and one to the right. So this is going to be the updated output. So let's call this h of t, and this is also h of t c current. Okay, that's good. Let's take and pull from the value here, take a pointwise multiplication and be done with it, right? Okay, so now let's say sigmoid activation function, a normal sigmoid activation function, a tanh activation function, a sigmoid activation function, and a simple tanh activation function, right? Tanh, sigmoid, 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 tanh. Okay. Now the output from here will connect to sigmoid activator, a sigmoid activation, a tanh activation, because this is the updation stage, a tanh activator. Now all of this tanh activator will go to a pointwise multiplicator. How much to forget? Go ahead with this. I need to have a pointwise multiplication, which is also going to be in black. So again, this is going to be plus and this is going to be a multiplication. So both tanh and this needs to update itself. So this will go to a pointwise multiplicator, which is right here, and this needs to go here. So both the arrows will point here. This is one of the arrows, this is one of the arrows, and this is one of the arrows. And then they will add themselves together. So they will be matching here. So it will go upwards. And then from the cell state, actually it goes in both the directions. So wait, 1 and 2. And again from this state, we add the value towards the bottom and we add it here. So there is a multiplication from both the output gate and the updated gate, which is the cell state update. Values are pulled in and you get the output. That is correct. So now proceed forward with the value. So this is going to be my output. Understood. Okay, good. All right. So let me expand this once again and the green state. So guys, this is a crude implementation of my LSTM cell, but this is sort of looks like, yeah, it does look like a circuit, right? Yeah, but don't worry. This is an easier thing to understand. It's very beautiful actually, right? Okay. Guys, this is how a simple LSTM cells look like. Each individual cell looks like. Okay. Let's write down some technical terminologies, some names of my cells or my values in a simple, uh, how do I say this? In a simple LSTM cell. First of all, do you see this upper value, the upper red color line that is passing through directly straight, the upper long-term line, this thing? Guys, in an LSTM layer or in an LSTM cell, this red color line is responsible for retaining long-term memory. If I want to remember long-term dependencies in a text, example, if I say I have been to Spain and I love Spanish, Spain and Spanish mapping, remembering that Spanish or Spanish is because you spoke about Spain. So whatever long-term memory you want to keep, it is in this particular thing. We call this thing in technical term as a cell state. Okay. We call this particular thing as a cell state. So the line that you see on the red color thing is called as a cell state. Okay, that's great. This red color line, so cell state can be written like this: C of t minus 1 coming from the previous time step, right? If you remember in the RNN, I taught you guys a concept. If you come from the previous time step t minus 1, current time step t, future t plus 1, same thing. Coming from the previous cell, c t minus 1. This particular thing, the red one, is called as h of t minus 1. This h of t minus 1 is responsible for something called short-term memory. Short-term memory. This particular thing, the green color thing you see here, is actually your current input. Your current input value is going to be your x of t. So tell me one thing, what did you identify? The red color thing that you see in the top here is responsible for long-term memory, remembering older texts, long-term memory retention. This red color thing is responsible for. This h of t minus 1 is what you call as the short-term memory. And this x of t, which is this current input, is what we call as the current input. Whatever you're adding to the network or to the cell is current input. Until here, you guys are clear what these three lines are? Long-term memory, short-term memory, and the current input value. Okay? Long-term memory, short-term memory, and the current input value. That's great. Each individual boxes that you see here, these boxes, my people, are called as gates. Gates allow information to flow. But based on certain rules, they will allow the information to flow. Imagine you have a pipeline. Imagine you have a pipeline that is allowing water to flow through something. So imagine you have a pipeline here. This pipeline passes through, and then there is this valve or valve that you see. Now, depending on how much you open the valve, it will allow that much water to flow. Imagine these gates are like those valves. They will allow the information to pass, but depending on how much you have allowed the information to flow. Okay. So first thing first, the first gate that you see here, this particular gate that you see here, this gate is called as forget gate. What gate? We call this gate as forget gate. The second gate is called as the input gate. The third gate is called as a cell update gate. And the last one is called as the output gate. If you can see, each individual cell has its own name. Forget gate, input gate, cell update gate, output gate. And you have this weird looking multiplication, addition, multiplication, addition, and all of that stuff. Now let me tell you a little something, okay? Little something important. This h of t minus 1, this h of t minus 1 and x of t minus 1, which is the current input, this h of t minus 1 is the previous input, right? This h of t minus 1 comes from the previous cell. Is my understanding correct? The ct minus 1 or the cell state t minus 1 and ht minus 1, where do they come from? They come from the previous cell of the neural network or the previous cell. If this cell is my beginning or the first cell, what will be my ct minus 1? 0. What will be my ht minus 1? 0. But if this is not my first cell, this is my second cell. So my previous first cell's input will be ct minus 1 and ht minus 1. And what is ct minus 1 carrying? The long-term memory. The long-term memory. What is ht minus 1 carrying? Short-term memory. And what is this x of t is carrying? This x of t carries the current input. The x of t is carrying the current input. So if my current input is like this, I love ice cream, ice cream. So I will be previous LSTM cell, love is the current LSTM cell, and ice cream is the future LSTM cell. Are we understanding? I's information will pass to love and love will be my input. Understanding? In I love ice cream, the sentence I love ice cream, the sentence love will be the current input. And if your current input is I love ice cream ka I, then your cell state and your short-term memory will be 0 because this is the first sentence you are dealing with. Agree? I have a small question. My question is, word order matters, correct? Word order matters. M-A-T-T-E-R-S. Meaning, man eating hot dog. Hot dog eating man. Essentially speaking, these two sentences have similar composition, but the order is different. Is order changing the entire context of the conversation? When I say a man eating hot dog and a hot dog eating man, the first sentence is easy to understand, but do you see the second sentence is terrifying? A dog, which is very, very hot, is eating a man. Now, this makes no sense, but still, it has some sense to it. So, word order matters. So, when you pass it inside the LSTM layer, whatever is the number of words that you have, that will be the number of LSTM cells, correct? Man eating hot dog. So how many words there are? Sentences. Man eating hot dog. So man eating hot dog. So how many cells will you take to understand this sentence? 3 cells. How many cells will you take? 3 cells. First should be man, that will go inside the LSTM layer. Then the current input will be eating and the current input will be hot dog. They will go one after another. They will go one by one. That's great. Okay. So guys, to make your life easy and make your life even more simple, let me go step by step and I want all of you to understand one thing with me, okay? Like understand what I'm trying to teach you. So let me do this. Let me go step by step, okay? Let me take the entire network, okay? Move this a little to the left and copy this. And I will paste it in this particular page. Okay, that's good. Guys, what I'm going to do is right now, just remove everything, okay? In this particular cell that you see here, okay? In this particular cell that you see here, I want you to observe one amazing thing. And that amazing thing is, let me erase everything. Guys, in the entire network, this particular cell or this particular value here that you see, give me 1 second, let me just. The thing that you see, the red color line that you see here, we call this particular thing as a cell state. And this is h of t minus 1. This is c of t minus 1. We call this as the cell state and we call this as the hidden state. Okay. Observe one thing. In the hidden state or in the cell state, are they being multiplied with any weights? Is there any weights being multiplied, any weights being added in this particular number, multiplication and addition? Is there any association, dependency on weights? Actually, no. Because there is no multiplication of this value with weights, no matter how big the sentence is, no matter how small the sentence is, vanishing gradients will not happen, exploding gradients will not happen, correct? Because when you don't multiply with any weight value, there is no possibility of the number becoming smaller, no possibility of number becoming larger, correct? They are very simply simple multiplication and simple addition. The cell state is responsible for understanding long-term memory, a long-term memory. While retaining long-term memory, I am not doing any multiplication or addition with weights because there is no relationship I have with weights. There is no chances of vanishing gradient, no chances of exploding gradient. Hence, my life becomes much more easy. This is easy. That's great. What about hidden state? This hidden state has no multiplication, no addition, correct? Even in the cell state, there was some multiplication and some addition. But in hidden state, that also does not exist. There is no concept of multiplication, no concept of addition. No concept of multiplication, no concept of addition. So what is this hidden state going to do? It is going to represent the short-term information. This is going to keep my long-term information. This is going to keep my short-term information. Sir, what do you mean by long-term information? What do you mean by short-term information? What do you mean? Let me make you understand what do I mean. Guys, do computers understand the meaning of the word cat loves playing with laser? If I pass this sentence to a computer, does a computer understand this directly? It's not possible. So tell me, do I have to convert my cat loves playing with laser into some kind of a numerical encoding? I have to convert cat loves playing with laser into some kind of numerical encoding, meaning convert this sentence into a number. Convert this sentence cat loves playing with a number. There are so many different kind of strategies available for converting text into a numerical format. Sir, which is it? The most easiest one is something called BOW. Not the bow, bow, bow. The full form is bag of words. The second thing is called TF-IDF. The full form is terms frequency, inverse document frequency. With TF-IDF, there is one more TF-IDF thing called CTF-IDF. The other kind is called word to vector, and then simple encoder decoder model. Let's not go too much in depth what bag of words, TF-IDF, word to vec, encoder decoder model does. I am simply telling you, if you want to convert the sentences into number, for example, cat will become 1, loves will become 1, playing will become 2, width will become 3.12, and laser will become 1.229. Example. What did I do here? Did I convert my sentence cat loves playing with laser into a categorical or a continuous variable feature or a numerical feature called as tokens or word values? Let's call this encoding. So when I say long-term memory and short-term memory, at the end of the day, are they all going to be nothing but a simple number? A mathematical number 9, 10, 18, 20, 25, 26, 97, 42, 43, minus 27, 86.72. Long-term memory and short-term memory, at the end of the day, will they be a number? The answer is yes. Higher the number, larger the effect. Smaller the number, smaller the effect. Understanding that's the rule of mathematics. If you give me larger the number, the effect also towards the end will be larger. If you give me smaller the number, the effect also in the future will be smaller. Making sense? Simply speaking, when I say long-term memory, it is nothing but a number that is coming from the previous cell state, and short-term memory is also a number that comes from the previous state. Until here, is everyone clear? What is this cell state? What does it do? Cell state is a long-term memory, hidden state is a short-term memory, and there is no weight to be dealt with here, and that is why there is no vanishing gradient problem and no exploding gradient problem. We deal with it slightly differently. So now, since we know how this particular thing works, how about we do a little bit of math, my people? Meaning, how about I teach you the concept of math, of how this particular thing works? Okay, let me copy this. Everyone, give me 1 second. Let's remove the unnecessary details. Long-term memory, let me remove this. Since you guys already know this, let me remove this. Let me remove this. Let me remove this long-term thing. Let me remove the short-term thing with the arrow. Let me also remove the 0. We don't need this. Equal to. And what else do we remove? We will also remove cell state, this, gates, information, all of that stuff. We don't need it. Okay, good. Let's deal with or understand the first gate in my entire LSTM layer, which is called as the forget gate. So I'm going to remove everything here, okay? I'm going to remove everything here so that the idea becomes more simpler for you. Let's remove this. Let's remove this. Okay. Let's remove this as well. 1, 2, 3, 4. Okay. Are you guys able to see that currently I am only and only focusing on the input gate? Let's remove this also. Yeah. I am currently only and only dealing with one of my first gates. We call this gate as a forget gate. Okay, that's great. Guys, when you pass in the previous hidden state or hidden state from the previous, this previous hidden state, they need to or you need to pass some weight values into it. Okay, you can't just directly pass, you need to pass some weight values into it. So can I say that this is a previous hidden state? So the weight value associated with this can be called as WF, the forget gate that we are talking about. Forget, I'm talking about forget, Upesh, forget. This is the weight associated with the forget gate. And this input value, which is the current input x of t, also needs to be multiplied with its relevant weight called u of f. Can you see? I am having two weight values here. The output that I get from the forget gate is an output that will look like this. F of t, which is my output, which is the output from the forget gate, will be sigmoid activation function multiplied by u of f multiplied by x of t plus h of t minus 1 will be multiplied with w of f. And all this number, if you pass it through the sigmoid activation function, will that be the output from the forget gate? That would be the output from the forget gate. For example, listen to me carefully. For example, listen to me carefully. If I want to show you like this, sir, currently my weight value, input weight value, W of F, this W of F, the weight value of W of F is, let's say, 2.30. Is this a random weight value that I have assigned everybody? 2.30. The input weight value is 1.30. My previous cell state output, my previous h of t minus 1 output, for example, let's say it is 1 and my current input is also 1. Can you see here? I said that cat loves playing with laser. So cat encoded value is 1 and my previous hidden state value is also 1. Input value is 1. My weight value is 1.30, 2.30 and a bias term is also added here. So the random bias value is 1.70. So tell me, how will I multiply according to this formula? As per the formula, let me copy this and let me paste it here. As per the formula of f of t, my output will look like this, everybody. F of t will be nothing but sigmoid activation of What is my hidden state value, everybody? 1 multiplied by what is the weight of this particular thing? 2.30. Agree, disagree? My value of my hidden state is h of t minus 1 is 1 multiplied by the weight value w of f is 2.30 plus what is my input value? 1 multiplied by what is the weight value of the input? 1.30 plus what is the bias value? 1.70. So input value x of t is multiplied by u of f. H of t minus 1 is multiplied by w of f. Is the number making sense? H of t minus 1 is multiplied by 2.0, which is this particular value. So all I have to do is rearrange the terms. This one will go here and this one will go here. So this is u of x x of t. This is h of x x of t. Make sense? What is going to be the output of this, everybody? 1.30 plus 1 into 2.30 plus 1.70. What is the answer? 5.3. So sigmoid of 5.3. Let's say define import numpy as np, and let's say import or define import numpy as np, and let's say define sigmoid and x, and I will say return 1 by 1 plus np dot exp, exponent of minus x, 1 by 1 plus e to the power of minus x. This is fine. Define tanh of x, return np dot tanh, and we will return x. Okay, so tanh and sigmoid. Okay, sigmoid of 1, tanh of 1. Okay, sigmoid of 1, tanh of 1. Okay, fine. What is sigmoid of 5.3? What is the answer of sigmoid of 5.3, everybody? If I pass 5.3 through a sigmoid activation function, what will be the answer? 0.9950. 0.9950. 0.9950. Now tell me, the output here is 0.9950. The output from the forget gate was 0.9950. Let's assume the previous long-term memory number is a number called number 3, or so it no, that's not the whole thing. So let's say the previous cell state value from the long-term memory is 2. Example. Tell me 2 multiplied by 0.9950. What is the answer? Is the answer 1.99, everybody? If I multiply the previous cell state value, which is 2, aren't you multiplying, everybody? The output that you got from the forget gate, which is 0.9950, you are multiplying with the previous cell state value, which is 2. You got the answer as 1.99, meaning the forget gate is doing what? Forget gate is built for one thing. It will determine how much percentage of long-term memory is to be allowed to pass. Understanding what I'm trying to say? From the previous long-term memory value that you gave me, how much of this long-term memory am I supposed to pass? How much of the long-term memory should be allowed to pass? To control that, we have something called as the forget gate. It is actually supposed to be called remembrance gate, but weird names, people give it weird values. It's called as forget gate. So tell me one thing, from the previous memory of 2, how much are you allowing it to pass? 1.99 are you allowing to pass, correct? Understanding what I'm trying to say? From the previous cell state of 2, or from the previous memory of 2, you only decided to remove 0.01 value. So you can say that how much of the previous long-term memory am I supposed to remember that control is taken care or handled by forget gate. Moving on. Sir, thank you for giving us the idea on forget gate. But my life is not sorted because how many other gates are we dealing with in a recurrent neural network like LSTM? Multiple different types. So what am I going to do? I'm going to copy this as it is and I'm going to paste this in the bottom. Now tell me, once the input gate is done, what other gate are we dealing with? Sorry, once the forget gate is done, what other gates are we dealing with? Cell update and input. Cell update and input. So tell me, now you already know that the previous long-term memory was 2, the previous hidden state value was 1, my current time step value is 1, the forget gate output value is 0.9950, 0.9950, and the output that I passed is 1.99, correct? For now, sir, I have learned what a forget gate does. I got the idea what a forget gate does. But what are we going to do now? What's the understanding that we are going to be doing? For now, I want to tell you a little bit more on something called as the cell update state. So what I'm going to do, I'm going to remove this. I'm going to remove this. I'm going to remove this as well because this is done. Okay. So this is done. I'm going to remove this, and this one as well. And I'm also going to remove everything from the side. So no need of this, no need of all of this, and no need of any of this. Okay. I want you to focus on a kind of gate called cell update gate or a cell update status, right? Can you see here? Yeah. The cell update state, that you see here, right? This cell update state is going to help me with something very, very important because your job itself is not done. Your forget gate is just giving you the idea of how much to remember, what percentage of the long-term data to remember. But what I need to do is, sir, this variable or this value also will have its input. Agree, disagree? So just like from the previous cell state, we have this cell update state, and this cell update state is passing through something called tan h. Agree, disagree, guys? See here. We had something called W of f, U of f. There was a mathematics formula, right? This particular cell state, the weight value will be called as del W of C and U of C. Okay. Let's say you pass it down to the cell update state. You will get an output called C tilde. The output that you got from this forget gate was called f of t. Correct, everybody? It was called f of t. The output that you get from the cell update state, you call it as a C tilde. C tilde. C tilde. C tilde is nothing but tan h into U of C multiplied by x of t plus W of C multiplied by h of t minus 1. Can I say this is the output? So as per my formula, the C tilde would be equal to tan h of U of C multiplied by x of t plus W of C multiplied by h of t minus 1. Okay. I have a question, interesting question by Mike. I love the way he's put the question. It's brilliant. Actually, I like it. This is a good question. But won't the forget gate be 1 or 0? So you will forget all of CT minus 1 or let it all through. Okay. I believe you guys have forgotten what a sigmoid activation function looks like or what a tanh activation function looks like. I believe it's my responsibility to remind you what sigmoid does. This is a sigmoid activation function in front of you. Let me also take tanh. Sigmoid activation function's job is to bring any number between the range of 0 to 1, correct? If this is the value of x that I want to calculate, What will be the value of y, everybody? Will this be the value of y? For this value of x, this is the value of y that I got, correct? Is sigmoid activation function always going to give the output as 0 or 1? Is it going to be sigmoid activation function output can be either 0 or either 1? No, it is between 0 and 1. Now my question to you is 0.6. Is it between 0 and 1? Is 0.6 representing 60%? Is 0.6 representing 60% of something? So tell me, if I have used something called sigmoid activation function here, isn't that to standardize my output so that how much percentage of the information to allow to pass, that value can be calculated here? Wherever I want to control the percentage flow of the data, how much to allow, how much to not allow. In that condition, sigmoid is the perfect activation function because it will always be scaled between 0 and 1. No matter how large the value of x is, the number will always be between 0 and 1. Are you guys clear? The question was, but won't the forget gate be 1 or 0? Is the answer correct? Will it be 1 or 0? Absolutely not. It will be a number between 0 and 1. It won't be always 1, always 0. No. So will you forget all of C of t minus 1? Again, no. It is a number between 0 and 1. Let's look at, so if we are calculating market segmentation acquisition in percentage, we will use sigmoid. If you ever want to calculate your output as a label 0 or label 1, you can use sigmoid. Sigmoid is the right way to do that. Market segmentation mein, if the labels are 2, for sure you can. Now let's come to tan H. The beauty of tan H is the output can be between -1 and +1. Agree? The difference between sigmoid activation function and tan H activation function is what? Sigmoid activation function is a number between 0 and 1. But what about tan H activation function? It is a number between 1 and -1. Are we clear? Sir, why are we using tan H activation function? Guys, the reason is because I have an extra range from -1 to 0. Are you understanding? I have extra flow of information that passes to me, which can be negative numbers, but they can be any number negative between -1 to 0. Make sense? So please keep these two concepts in mind and please come back to my reality, my old topic. So tell me, is this how a cell update state will be written? Yes or no? Okay. Now let's say your WC, your weight of the cell state is 1.20. Your UC is 0.60. Your bias value B is 0.10. What will be the answer, everybody? Tan H of what is U of C? 0.60 multiplied by what is my input? Is it 1? Is it 1? My X of T is 1 plus what is my W of C? 1.20 multiplied by what is my HT minus 1? 1 plus 0.10. What is the answer, everybody? 0.60 plus 1.20 plus 0.10. Add everything together. It would be 1.9. 1.9. If you pass 1.9 into tan H, what answer do you get? 1.9, if you pass it inside the tan H activation function, what do you get? 0.9562. 0.9562. Is the understanding correct? Now tell me one thing. You multiplied the weight values with the previous hidden state. Hidden state is short-term memory and my current input, and I am passing it to something called cell update state. Keep this as it is. Keep this as it is. What is it that my cell state is doing? What is the benefit of my cell state? Okay. You had the previous long-term memory which became 1.99. The previous long-term memory was 2. You converted it into 1.99. Now, Before you pass it the long-term memory to the next cell, you want a new long-term memory value, correct? Before passing the data to the next cell, don't you want to calculate the new long-term memory value? The updated long-term memory value that is allowed to be passed to the new cell, including the information with the current data, which is x of t input, including the current information, whatever you are passing in the cell, considering the previous long-term memory, don't you want to calculate how much and what will be the new long-term memory value that I can pass to the new cell? Yes or no? You need to update the new long-term value that you want to pass it to the new cell. To do that, you will take help of two different gates. What gates? You will take help from two different gates. One is going to be called as my input gate and the other is going to be called as my cell gate or cell update gate. Okay, so give me 1 second. Let me paste it here. So tell me, you calculated something called C tilde, which is what the cell update gate does. Tell me one thing, can we do the same thing with the input gate, everybody? If my input gate, specifically I'm talking with respect to input gate, say for example, my U of C or my weight value, which is C, which we call as W of C, I'm going to call this as W of I. So the formula will look exactly the same, but the way we do it will be different. So W of I, and this will be U of I. The output from the input gate is gonna be called as I of t. So you call this particular information as I of t. So I of t is equal to sigmoid activation function of U of I multiplied by x of t plus W of I multiplied by ht minus 1. Is my understanding correct? So can I take this C tilde method, which is the one that I've written here, move it a little bit to the left here and make another line here, and I calculate something called as U of I, I of t. I of t is equal to sigmoid of U of I multiplied by x of t plus W of I, let me bracket this up, plus W of I multiplied by h of t minus 1. So guys, for simplicity reasons, okay, for simplicity reasons, always add a bias, guys, always add a bias, plus b plus b plus b, okay, always add a bias. Okay, towards the end of it, please add the bias by yourself. That bias will always exist. We cannot skip the bias. It's not easy to skip the bias. Okay. So let's say this W of I is a number called 2.30. This U of I is 1.70. And the bias term is, let's say, 0.30. Example. So what will be my output like? Will it be U of I, which is going to be 1.70 multiplied by 1 plus 2.30 multiplied by 1 plus 0.30. What will be the answer, everyone? What will be the answer? 4.3. And the sigmoid activation of 4.3 is how much? 0.98661. So sigmoid activation function of I of t is 0.98661. Agree, disagree, everybody? We got I of t and we got C tilde. So tell me, what do? You will now take the value which is I of t, 0.98861, multiply this with C tilde. What is the C tilde value? 0.9562. So if you multiply C tilde with I of t, you get the answer 0.9562 multiplied by 0.98661. 0.9433, correct? The output that you got from both the operation, which is this blue color line, is 0.9433, correct? The cell update state that you see here, which is this C tilde, the cell update state is how much potential long-term memory to remember. Okay, what is my new long-term memory will be? The new updated long-term memory, what will be the value of the new long-term memory is calculated by the cell state. The new long-term memory, the new updated long-term memory is calculated by the cell state. How much of this new long-term memory you calculated should be allowed to pass through is calculated by the input gate. Did you understand? New long-term memory that will be passed to the new cell is calculated by the cell state. How much of this new long-term memory should be actually allowed to pass through is calculated by the input gate. I hope you guys got the logic. Suppose there is human number 1 and there is human number 2. New long-term memory by cell state, but how to pass it by input state? You just passed it, no, Pallavi? So the input hidden state minus 1, how much? Yeah, that is how much. How much of the new cell state should be allowed is this number. 0.98861 is the percentage of the new cell state to allow. That much value to allow is what you calculate in cell state. Okay, but wait, we'll understand it even a much more better way. When person 1 receives 100 rupees and this person wants to pass it down to his brother, will you keep 10 for yourself or 30 for yourself and pass 70 to the other person? Imagine a broker. A broker will receive the money from the customer. To pass it to the owner, he will keep 30 rupees himself and pass 70 rupees to the other guy. So tell me, isn't cell state identifying how much do I need to pass to the customer or the owner? How much of the money to pass to the owner? But the decision making that should you keep 30 rupees with yourself, 40 rupees with yourself, 70 rupees with yourself, isn't that done by input? Your cell state will create what? It will calculate the number that what will be my new long-term memory. My new long-term memory, what will be that number? That number will be 0.9433. And out of 0.9433, how much should be actually allowed to pass? Isn't that calculated by input gate? So your input gate and cell state will work together as a family. Got it? Now listen to me carefully, guys. What is my previous long-term memory? 1.99. Is it 1.99? Is the previous long-term memory when I passed through the input gate, forget gate, is 1.99. This 1.99 you add with 0.9433. What will be the answer? What is 1.99 plus 0.9433? What will be the new cell state? New cell value? 2.933. Are you understanding that from my current input, the current input you're adding, the current input's influence to the new cell state is only 0.9443. So the new cell state is 2.933. I hope you guys got the logic very, very clear. That this two gate, input gate and cell state, told the LSTM layer that from the current input, what and how much is it important? How much new information I have received? What new information I can add to the previous long-term memory? Did you get it? Yeah, it is interesting. It's just that for the beginners, it's not a very easy thing to understand. But I'm doing the math to math comparison. So pretty much you guys will like it over a period of time. Don't worry. But I hope you guys understood the concept of 3 gates. I taught you forget gate, input gate and cell gate. I hope you guys got the logic between all of that. Forget gate will tell you how much information am I allowed to pass from the previous long-term information to the new updated long-term information. When the forget gate will tell you from the previous long-term memory, how much of it should I actually allow? So forget gate will do that. Cell gate will tell you what new information I have, potential new information, updated new information, and out of this updated new information, how much I will actually allow to pass. If I add everything together, that will give me the new updated cell state, correct? The one that I'm supposed to pass to the new value. So far, we have learned what is a short-term memory, what is a long-term memory, where do they flow from, on the top, you allow to pass long-term memory. In the bottom, you allow short-term memory. You also have something called the current input x of t. And then you pass it through the forget gate, you pass it through the input gate, and you pass it through the cell state. Can we use ReLU instead of tanh? No, absolutely not. The reason is very simple. Sigmoid activation function and tanh activation function. Clearly, the choice of activation function must be for a reason. The problem with ReLU is it will only allow positive numbers to pass, correct? Anything from 0 to positive infinity, ReLU will allow to pass. But what about my negative gradients? To handle those negative gradients, your tanh is allowing very strict numbers between -1 and 1. The problem with leaky gradient or leaky ReLU is the leaky ReLU follows something called as the alpha. If alpha is equal to 0.2, 20% is the angle change in the alpha. So it will be between 0.2, negative 0.3 to positive infinity. Do I dynamically change the alpha in the neural network? Do I have to take this headache also? No. So let me pass anything between -1 to 1, it will automatically handle all by itself. Are you understanding what I'm trying to say? I don't want my alpha to be of a leaky ReLU to be changed every single time when I'm doing back propagation. No, let it pass a standard -1 to +1. Understanding? It will not allow my gradients to explode to positive infinity, meaning the numbers won't become larger, or it will take a larger number. It will remain standardized between -1 to +1. So your outputs are guaranteed to be between -1 and +1, which are easy to handle. The best pipeline of the banking that you have is amazing. All the way from regulations to technology that they use. Amazing. Amazing. The income tax department already knows that you have submitted a false income tax return, but they let you go. But in their dashboard, they already know. They know you have submitted a lesser amount for your income tax return, but they don't go and find you or they search for you because you have done it for a lower ticket size for 20,000 rupees, 30,000 rupees, maybe 4 lakh rupees. They are not going to go ahead and say that, you know what, it's okay. They're not going to come behind you, but they know. They will always know. Nobody knows this. If you know this, good, but they already know that yes, based on what you got in your bank account, based on what you have sent and the income tax return that you're filing, definitely you've done something. There's a discrepancy there, but they don't contest that, they let you go. It improved after the scam of 1992. The Indian banking system became more technological savvy after a lot of scams happened in our country and we became better at it. Swiss Bank is just the world's piggy bank. If you want to save your, I'm not going to say hard-earned money, but if you want to save your black money and don't want any country to subpoena the records, so Switzerland does not respond to subpoenas, right? So if you want to keep yourself protected like that, Switzerland, and nobody puts it in Switzerland, they put it in Caymans now, because even Switzerland responds to US subpoenas. So if United States request for account details from a Switzerland bank account, they have to respond back with the metadata. It's a rule now. So Caymans don't do that. So people put in Caymans or a couple of other like Saint Martin and stuff like that. So that's become like a tax haven for every other billionaire and millionaire. Okay. So now that we have done RNN here, how about I can run LSTM as well on this? Can we run an LSTM as well on this? Can we try running an LSTM? Can we do it? So tell me, model underscore LSTM equals to models dot sequential, sorry, S capital, right? Models dot sequential. So tell me one thing, what did I do here? Models dot LSTM is models dot sequential. I'm going to show you something awesome. Wait, let me copy this and let me paste it here. Is this my RNN code, everybody? I will change RNN to LSTM. I will change my models to models.sequential. And model.add, guys, for any LSTM RNN cell, you need the embedding layer, correct? Layers.embedding max features 32. Now tell me one thing, in model underscore LSTM and model underscore LSTM, sir, what do we do with simple RNN? You just replace the simple RNN with LSTM. That's it. You're done. To make you understand even better, I am taking the dense vector size as, or the neuron size as 64. Am I allowed to do this? Am I going to do it? But this code will not work. Why will it not work? I have imported a submodule called layers. Can you see here? Layers. Inside the layers, I have everything, right? Inside the layers, I have everything. So if I import layers.lstm, will it not work? It's not a single standalone LSTM that I'm importing. See, if I run this, did it run? Give me any error? No. Did I need to add any tanh? No. It will run. I hope you got it. Yeah, this is also model LSTM. Are we clear until here? So the same exact logic will apply. So if I, after creating the LSTM module, I was able to do what? Model LSTM.compile. So I'm going to come over here, go to the bottom and paste it. So model underscore LSTM, model underscore LSTM. So wait, LSTM, and this is also LSTM. Is this correct? Do I need to change anything here? Model LSTM.compile, model LSTM.fit. This is history of LSTM. If I run this, how many epochs am I going to run for this? 50 epochs. So for all the 50 epochs that I run, I'm going to run the whole thing and I'm going to get the answer. If I run on Jupyter, it consumes my laptop CPU, so must be used on Colab. Yes. Run it on Colab, not on your Jupyter notebook. Okay? Got it? Please try this out, guys.
With a solid understanding of LSTMs and how they manage long-term dependencies in sequential data, let's move to a completely different yet equally powerful concept in deep learning, that is autoencoders. Unlike LSTMs, which focus on sequence prediction, autoencoders are designed for unsupervised learning tasks such as data compression, noise reduction, and feature extraction, making them a key tool for representation learning. In the next section, we will cover autoencoders in detail.
Guys, one of the ways in deep neural networks or in neural networks, we also have its way of doing dimensionality reduction, and the name of that technique is called autoencoder. The way you can perform something called as dimensionality reduction in how do I say this, in deep learning, is we have a technique called autoencoders. Now, what is an autoencoder, sir, and how does an autoencoder work? Well, guys, don't worry. We are going to learn everything about what an autoencoder is, how does it work, and what's the beauty of autoencoders, right? All of this we are going to learn one step at a time. I work with the most terrible data that is known to human being, and that is financial data. I'm not sure if you guys know this or not, but financial data are the most, or is the most unstructured, highly unsanitary data that exists on the planet. So the most amount of data pre-processing that we have done, I think there is no better data pre-processing guy than a financial expert, somebody who's worked on financial data. Okay. But doesn't PCA give you new feature? It doesn't just drop features. Okay. So again, don't get confused with principal component analysis and recursive feature elimination. Principal component analysis will combine the features and will give you one new feature. Recursive feature elimination will drop features. There is a difference. PCA will give you new feature, but what do you mean by new feature? A, B, C. Suppose there are three features and you got two features, PC1 and PC2. ABC combination together is PC1 and PC2. So in the most easiest sense, you can say that recursive feature elimination plus principal component analysis together will help you avoid any overfitting you might observe in the future. Got it? Okay. Explained variance ratio. Explained variance ratio means, tell me one thing, guys. You have feature number 1, feature number 2, feature number 3, feature number 4, feature number 5, and feature number 6. And this is the 6-dimension data. You converted this into 3-dimension data. So principal component 1, principal component 2, principal component 3. PC1, PC2, and PC3 Principal component 1 is able to give you 60% of the understanding, PC2 20% of the understanding, 6, 7, 8, and PC3 20% of the understanding. So tell me, feature 1, feature 2, feature 3, feature 4, feature 5 is completely 100% of the data, correct? PC F1, F2, F3, F4 is 100% of the data. Principal component 1 is able to explain how much percentage of that understanding? 60% of that understanding is explained by principal component 1. What about other 20%? Other 20% is explained by PC2 and the other 20% is explained by PC3. Did you get it what I'm trying to say? This is what you called as the explained variance ratio. Which principal component is giving me the what idea? It explains the variance of the data. It does explain the variance of the data, but it also explains the variance plus the information. So what happens is, out of my entire data set, principal component 1 is able to give me the maximum understanding of the entire data, correct? Then principal component 2 is able to give me the data. Then principal component 3. So explained variance ratio actually uses variance to calculate how much importance each principal component is holding. So you're not wrong, you're right. But there is also one more extra set of information, which is the actual information itself. That is also explained by explained variance ratio. Got it? So RFE can be applied before LDA also. Yeah, of course. Principal component analysis and linear discriminant analysis or factor analysis, any three if you want to use. These three are just another ways of handling dimensionality reduction. You can apply recursive feature elimination before PCA also, before LDA also, and before factor analysis also. It will work. It will work equally effectively, right? All right. Now, since you guys are clear with dimensionality reduction and everything is clear, okay, which one do you prefer? I have no preference. You should have no preference. It will completely depend on the data. So, one of the most important question, as PC1 is 4 different features and all 4 features may have different unit, then PCA will also work, of course. I hope you guys do know that before applying principal component analysis, you standardize the data. Okay. When you did hands-on with the principal component analysis, did you just take the original data and directly apply principal component analysis on it? Did you do this? That is not possible. It doesn't work like that. So tell me, when you take or apply principal component analysis, wouldn't you have normalized the data, standardized the data, scaled the data? Only after that you must have applied PCA? Okay. If you don't apply normalization or standardization, you can't have two features which are of different unit, different directions, different values. You can't apply PCA directly on it. You need to normalize it, bring everything in the same range and then apply it. I hope you know what I'm talking about. You have to do some data preparations before you put it in PCA. Otherwise, it's just not going to work out. Okay. Now, guys, autoencoders are very, very critical. Okay. Now, I don't want to give you guys some basics, but yeah, let me give you an idea what autoencoders do. Okay. See, guys, autoencoders are unsupervised machine learning algorithms that takes an image as an input and tries to reconstruct it at using as fewer number of bits from the bottleneck, also known as latent space. Now, this definition must have done absolutely nothing for your clarity, because to you, it must look like, what in the world is this definition trying to tell me, right? What is it that it's trying to give me? It's trying to give me no idea. It's trying to absolutely give me no idea. There's an original input called number 2. I look at the output number 2 here, it's a little bit blurry, and in between there is something called encoder and decoder. Well, everybody, like I said, look at the whiteboard and we'll try to get everything clear. First of all, everybody, let's go step by step. We don't have to rush into anything. Autoencoders are what exactly? Autoencoders are unsupervised learning algorithms. You know what they do? They apply backpropagation. Okay, apply backpropagation. In such a way where the number of inputs are equal to the number of outputs. Autoencoders are unsupervised learning algorithms. they apply back propagation in such a way that my number of input and my number of output will be same. I want you to forget every single thing about whatever you know in deep learning. Imagine you never met me. I have never taught you deep learning. You've never learned or heard about deep learning. I want you to think like you're a child who's learning deep learning for the first time. I want you to do this. Now, do you see very important information in this particular graph? Whenever you want to build something called autoencoder, you have an encoder model and a decoder model. First of all, do you see this? You have two new things, encoder model and decoder model. Guys, in 25th or 2025, in the year 2025, encoder decoder models are the boom. B-O-O-M, boom. What do you mean by boom? Encoder decoder models are the ones that are causing the AI to transform itself into new spaces, new peak, new technological advancement. So remember, this is also going to be an introduction to you guys to explain you the concept of encoder decoder. Well, don't worry, it's a very simple thing. Imagine you speak, I don't know, Punjabi. Say you speak Punjabi well. A native Punjabi speaker, somebody who knows Punjabi, let's say your mom tells you something in Punjabi. Okay, she tells you in Punjabi and you also understand and hear her in Punjabi, and you're able to have a conversation. The encoder decoder model here is the language itself, because the language is known to few people. So if you are able to communicate with your child, the child is able to communicate back with you because the language itself encodes the information in a language called Punjabi, which is received by the student or the kid. And the kid is able to understand what the encoder want and is able to respond back. Are you understanding what I'm trying to say? You basically encode something, pass on the details, then the decoder decodes that details, right? And then maybe you're able to return back. It has something to do with that, but we'll try to understand it in depth. Okay. Anyways, so if you look at this particular data, you have an encoder and a decoder model, but can you see that the input data size that you pass is exactly the output data size that you have, correct? The input size, if it was 5, the output will also be 5. If the input is 100, then the output also be 100. If the input is 800, then the output also will be 800. There is no mismatch in the input and output. Did you get the idea clear? That my input size and my output size, they always need to be equal, first of all. Okay, good. Now, keep this in your brain, in your mind for a while, okay? Keep this in your mind for a while. I'll try to explain it to you in a very simple way. So, sir, what is autoencoder has? Autoencoder, encoder, what does it do? First of all, before even jumping into anything, I'm going to explain it to you like this. What are the components of the autoencoder? What components of autoencoders exist? Number one, encoder, and the other one is called decoder. Okay, encoder and decoder. Guys, what is encoder decoder? It's very simple, guys. Encoder is a part of the network that will take the input and it will compress the input in a smaller, more compact representation. Guys, in autoencoders part, you have two components. Component number one is going to be called as the encoder part of the principle of autoencoder, and then we have something called decoder. Encoder is a part of the network that will take the input and it will compress it into smaller, more compact representation. Let me explain it to you in a much more nicer way, right? I must have a diagram that can explain it to you in a much better way, right? So let's say, okay, this is a much better representation of the data. Okay, copy and paste. The input data that you're passing to the encoder or the encoder layer, okay, it will take data into your model and it will convert the data representation of 6 different data points. How much is my input data size? 6. How much did it compress it into? 3. Can I say 6 got converted to 3? It was able to compress the information of the 6 data point into a representation of 3. And the decoder, which is the output layer, will then take this 3 compressed information and recreate all the 6 information pack. Are you understanding what's happening, guys? What they are doing is they are taking this large data, this large information, they are compressing the information, and that compressed information is then used to decompress the original information back. Are you understanding? What is autoencoder doing? Autoencoder is taking this large input that is incredibly larger in size, compressing it in such a way that the representation becomes smaller, and then that same representation is used back again in the output layer to give you the output back. Let me give you guys a very simple example. This will become absolutely clear, okay? Imagine you have a picture. You have this very high resolution picture of Mona Lisa, right? So let's say you have a very high resolution image of Mona Lisa. Now tell me one thing. Usually you guys would apply something called convolutional neural network, right? To understand the image, to understand what features are existent in the image. Agree, disagree? You would pass the Mona Lisa, this famous picture, this famous painting, through something called as convolution layer, give it multiple different images of Mona Lisa so that it could understand what that image is representing. Now tell me one thing, rather than doing it, can I pass it through something called as an encoder block that would look something like this? Look at this. This is like my encoder block. I want you guys to look at it very carefully. The topic may not make sense to you right now, but it will make a lot of sense in a second. Give me 1 second, okay? It's like after teaching deep learning multiple times, I believe I'll become like this artist or painter of some sorts, because I have so many technical diagrams to draw. Okay, so let me keep it here. Okay. Everybody, I want you guys to look at the example that I'm giving you a little bit more carefully because this is critical. The original information is being converted or passed on like this. And then this also passes on to this passes on to this passes on to this. And then this passes on to this will pass on to this will pass on to this, and then again this will pass on to the entire image. So back again to this will pass on to this, and this will all again pass on to this. Okay, that's good. I'm proud of my creation right now. Okay, so this is my encoder block. Okay, this is my encoder block. This would be my bottleneck, or also called as latent space. Give me 1 second. This is what I can call as latent space, and this is also called as bottleneck. And this right here would be my decoder stage and decoder stage. Okay, I had an original picture of Mona Lisa. When I have the original picture of Mona Lisa, will I have like the ultra high quality, like the HD, HDR plus quality of Mona Lisa? Like the image is the maximum quality of Mona Lisa, correct? The most clear, the most cleanest picture I can find of Mona Lisa, I will have that at my input value, correct? Now everybody, the job, the responsibility of a encoder decoder model, or the job of auto encoder is this. From the original picture of Mona Lisa, am I going to compress the information of Mona Lisa in such a way that I now have this dense representation, this compressed representation of Mona Lisa? Mona Lisa, which is 900 pixel by 900 pixel in size, has now become only 200 pixel by 150 pixel. Are you understanding what I'm trying to say? You have a 900 pixel by 900 pixel image, original image of Mona Lisa. Now tell me one thing, over a period of time, can I train my neural network to extract only the important information from the original image? Listen to me carefully. Can I train my neural network in such a way that from the entire image only extract the information that is important, and this information can then later be used by the decoder to reconstruct the original image back? Do you understand the challenge, everybody? I give you an original image of Mona Lisa. I tell you, you are only allowed to keep 150 pixel by 200 pixel information of the Mona Lisa. Then from this compressed information of Mona Lisa, you are supposed to build the original Mona Lisa back. Isn't that hard? Isn't that complicated? You will lose a lot of information. You are going to lose a lot of possible information. But tell me one thing. Look at this presentation that I'm teaching you. Do you see that the original input image 2 is very, very clear, but towards the output, the reconstructed output is very, very blurry? The original input is very high definition, very, very crisp, but the output image that I got is very, very blurry. But tell me one thing, was I not able to reconstruct my original input back? I was able to take my input, compress my input, extreme compression of my input. I could put the input again back to the decoder, and my decoder was able to construct the original image back. It is blurry, it has some lossy answer, but it was able to give you the exact answer in the beginning. I was able to reconstruct with some losses. Okay, sir, why are we doing this exercise? Why is it more important? I am not interested in either the encoder. I am not interested in either the decoder. My interesting point is, aren't you interested in the middle value, guys? The value called as the bottleneck or the latent space. If I train my neural network so well on, say, image data, guys, listen to me carefully. If I take images of all horses, example, or pets like dogs or cats or whatever you want, after training the neural network for like hundreds of epoch, will my neural network learn that if I want to compress dogs or if I want to compress cats, which portion of the dogs and cats can be compressed so that they can be constructed back and deconstructed back? Isn't the bottleneck layer is where the magic is happening? Which information about the dog are you keeping in you or with yourself so that you are able to construct the original data, the original image back from the input value of the image? This is the gold mine of neural network computing. This is what I'm interested in. But my question is simple. Did you get the logic of what an autoencoder will do? It will take your original data, it will compress the data in such a way that you get a latent space or a bottleneck space. That bottleneck space will then become the input to your decoder, and the decoder will reconstruct back the original image that you had in the beginning. Did you understand the basic core philosophy behind autoencoders? The beautiful thing about autoencoders is this. From autoencoders, I compress a large amount of input into this small space of input called latent space, and this latent space will again go back to my output, and I'm able to reconstruct the original thing back. Observe one thing. The input size and the output size, are they same? Whatever image I put as an input, I am getting the exact same image as an output. Yes or no? Got it? Now let me ask you a question. Guys, basically what autoencoders is teaching us is that when you take any data, it is possible for that data to go under something called extreme compression, correct? That data can go under some compression technique, and this particular data can be used to get the reconstruction of the original image back. Meaning, you pass the input to the bottleneck layer, the bottleneck layer will pass it to the decoder, and decoder will be able to process the original image back. So tell me, to save time, energy and computation, can autoencoders encoder model be used? If I want to save certain amount of time, energy and space constraints, suppose if I have a lesser computing power, if I have lesser time to understand something, can I not use encoder decoder model with a convolutional neural network and pass in this latent space variable or this latent space for it to understand something? Very much possible. So tell me, if I ever want to use encoder decoder model, what will I do? Encoder will encode the value in making such a small representation of the data, and this will be given and passed on to the decoder. How space constraints is taken care? Tell me one thing. Space or memory has become very, very cheap nowadays, correct? You can literally buy a 50 GB worth of, I mean, I don't know, you can buy a 10 TB worth of hard disk for what, like 20,000 rupees something, right? Change. So memory is cheap. The Problem is processing has become expensive, right? Computation has become expensive. If you want to compute millions and billions of rows of operation, it becomes complicated. So we are not worried more about the memory of the operation. We are worried more about the processing of the operation. That's more important, right? So let's not worry about the memory constraint or time or space constraint. We are more interested in, can we take the original data and compress it in such a way that I will be able to sort of deconstruct it later. This philosophy, this idea is more important to me. Understanding what I'm trying to say? You can literally take 100 GB movie, convert it into 50 MB. I mean, won't you be excited? Like your brain will go haywire because 100 GB worth of data, you are able to compress it in what, 50 MB. Will you be like going crazy? Like so many things you could be achieving, so many things you could do. That is exactly what I'm talking about. Got it? This is exactly what I'm talking about. Okay? Imagine you have an input data where you're passing the feature. Feature number 1, feature number 2, feature number 3, feature number 4, feature number 5, and feature number 6. Suppose if you have a pipe like this, if you take a pipe and the outlet of the pipe is like this, the water will spread all across, correct? If you take a pipe and you compress the output, your water will spray out very, very quickly out of this jet sort of a spray thing, correct? Now tell me one thing. My input nodes are larger, my output nodes are lesser. Guys, as per the logic and the rule of neural networks, what would happen? Feature 1, feature 2, feature 3, feature 4, feature 5, feature 6, with their respective weight, W1, W3, W5, W6, with their weight values, will they not compress each other with just the representation of these three nodes? So the A1, A2, A3 is nothing but combination of feature 1, feature 2, feature 3, feature 4, feature 5, feature 6 multiplied their sum weights plus biases together is the combination of A1, A2, A3. So now tell me, I have a small question. If you give it enough forward propagation, backward propagation, forward propagation, backward propagation, forward propagation, backward propagation, will my weight values change in such a way that I will now become so smart at taking the feature values and only taking the right amount of ones to compress the feature inputs into this bottleneck layer? Will you not become smart to understand, because neural networks will understand patterns and behaviors? So your weight values, your bias values, and the input values, all of them, when the neural network is trained enough, it will understand that for which feature input, which values do I need to save so that it becomes more dense representation or compressed representation. Agree? This dense representation, then what will happen is, because you want the original output back, can you have a loss function? Meaning, I'll give you an example. I will give you an example. Listen to me carefully. Listen to me carefully. So let's say your input value is 5, 4, 5, 6, 7, and 9. This is the input you have given. In the first forward and backward epoch, you compressed the information and the x1 value became 2.97, 2.97, 3.11, 2.16, minus 1.79, minus 3.29, and 4.12. Tell me this. When the first forward propagation happened and backward propagation happened, ठीक है, Li of theta comma phi is equal to negative E of z, which is Q representation of Q theta, which is going to be for z x of I, is going to give you the log likelihood of log p phi of x of I with respect to the z value, reconstruction of Kullback-Leibler. So Kullback-Leibler of Q theta of z by x of I. Give me 1 second. Let me write the Kullback-Leibler again. So the KL of Q theta, this is going to be represented with z because that is the reconstruction loss of x of I. We are also going to have it performed an internalization operation on P of z. So this is the loss function I am talking about. Okay. This loss function is not going to make much sense to you right now, but I want you guys to just take a deep breath and I'll explain it to you. Okay. See, when I reconstruct back my original image, the one that I passed and I got the original image, there should be two things you should be constructing. Can you see this piece of the function here, minus e of z to this part? This part of the loss is called as reconstruction loss. And this is called KL divergence. Now, guys, the question is very simple. Okay, I want you to listen to me carefully and let's go step by step. Okay, when you did the first forward propagation and the first backward propagation, my output was 2.97, 3.11, 2.16, 1.79, 3.29, and 4.12. But my original values are 5, 4, 5, 6, 7, and 9. Now, my question to you all is this. Are you going to be thinking that, oh, loss is easy to calculate, 2.97 minus 5, you got the loss answer? Actually, no. The problem here is every single feature we combined, yes or no? We combined every single feature, so we don't know what is causing the 2.97, correct? The 2.97 is caused by some weight value and some input node. But then this input node is also responsible for this output. This input node is also responsible for this output. This input node is also responsible for this output. Yes or no? All three nodes are important for the output, but because these three nodes are responsible by their own weight value, so do we have to go all the way back to the input? Agree, disagree? Also, guys, do you think loss should include only individual value, or should I combine everything together, and on everything, how much am I able to get overall? How much am I not able to get overall? This loss is called as the reconstruction loss, because guys, whatever original data I had, after extreme compression, will I get the same exact quality of the original data? No. How much quality loss has happened, that can be calculated using something called reconstruction loss. Am I making myself clear? Whatever I was able to have my original image, my original data, I was able to compress in this bottleneck, and my bottleneck was able to, get the output x1, x2, x3, x4, x5. How much is the overall loss? You calculate this as a reconstruction loss. So loss function has no direction, loss function has no agenda, and loss function definitely does not have an objective. If you tell me the loss function's objective is to decrease loss, it's like saying, how does a motor start? And you start saying boom, boom, boom. It's like that. So what I'm basically trying to say is, of course, the objective of loss function is to reduce loss, but I'm not saying objective from that perspective. The question is simple. I'm saying loss function has no direction. I hope you are clear that there is no forward and backward direction a loss function goes with. Loss function will have no agenda also. There is no agenda for the loss function. Objective, maybe I can do. What are you looking for in the loss function? That's more important. What are you looking for? Okay. In any neural network, okay, that you're working on, you have to be very careful about one thing. Very careful about one thing. How will I be able to calculate my loss? So it's like this. There are few people on the planet, if you ever have a conversation with them, they will always come back to P&L statements, profit and losses, right? Every discussion with them will always convert themselves into a P&L, discussion, because, they all want to talk about how much I have gained and how much I have lost. Overall, that's the most important criteria to discuss. When you talk about machine learning or neural network, you also need to calculate how much did you gain from the neural network model and how much did you lose from the neural network? How much information was lost? Now, this information is very, very critical for you, because this becomes important, that how much losses have you encountered or you had to encounter while you were working on a model. Now, because you want to calculate the gains, the knowledge or the losses in the model, we have something called as loss function and we have something called as cost function in neural networks, correct? Everybody, you know for a fact that loss function is different and cost function is different. Remember this, okay? Now, why do we need a loss function? A loss function is needed because in every single step of my neural networks learning, epoch number 1, epoch number 2, epoch number 3, epoch number 4, every epoch, did I say my losses were 96, decreased to 88, decreased to 72, and decreased to 62. Any loss function on this planet, any loss function on any neural network, it will have to decrease in magnitude. Are you understanding? Point number one. The loss function will always be a larger number in the beginning. By the time you train the model, its expectation is to become smaller and smaller and smaller. Point number one. So, to solve the problem of exactly that in autoencoders, how do I handle it? Well, it's complicated. Just like how relationships and friendships and professional life is complicated, this is also complicated. How is it complicated? Tell me this. The output x1 bar came, or the result x1 bar happened because w1 was multiplied with a1, some other weight matrix was multiplied with a2, with some other weight matrix was multiplied with a3. Now the problem here is you guys are thinking that there can only be one bottleneck layer. My question is, can I have one input layer and multiple bottleneck layer? Yes or no? Let me ask you guys something. Guys, tell me this. Have you ever pushed somebody so much that they've literally lost it in their life? They've literally lost their peace of mind. If you've irritated somebody so much in your life that if you irritate somebody so much at once, well, they will be definitely be very, very angry or upset at you. But tell me one thing, the strategy that you should follow to irritate someone is, if I take my input layer, listen to me carefully, this is my input layer. Okay, this is my encoder layer also. Think of it like my input plus encoder. Rather than doing extreme compression, can you do it first minimal compression, then one more layer of compression, then the extreme compression, and then when you're decoding, you decode it to the normal minimal compression, then again like the other extreme compression, and then you have the output layer. Can this also happen in autoencoders, everybody? Not just you have to have only one bottleneck layer, but you compress the data slowly by slowly that you don't miss out on too much information. Are you understanding what I'm trying to say? Did you guys get the logic I'm trying to say? You don't consider that autoencoders will only have one bottleneck layer. No, 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 no. That's not true. What you do is, first you take the input data and compress the data to some lower level analysis or some lower level compression. What will happen with a lower level compression is, my input value will get compressed to some lower level information where I have not lost too much information. I am not lower, I'm not losing too much information. Then that information will be passed to another layer, to another layer. Then this information will be passed and will be converted to extreme representation. Then this extreme representation, you pass it to the next layer, then again next layer, and then again next layer. So my question is, everybody, the intention I wanted to teach you was, tell me, because lower compression to I have to reconstruct, even I don't have to reconstruct directly the original image. My reconstruction or also is very, very less, correct? See, this is the extreme compression data and my original reconstruction is also a smaller size. Then the reconstruction is a smaller size and then the reconstruction is happening. So am I getting some time? Am I getting some space? Am I getting some energy to reconstruct also slowly? I don't have the responsibility of reconstruction suddenly everything at once. I will also get some time to reconstruct back. So tell me, if this is how you take an autoencoder, will the reconstruction loss, which is this portion of the loss, will have peace of mind, ease, life will be beautiful? Understanding that slowly and slowly my loss function will go lesser and lesser and lesser and lesser and lesser, and it makes my life easy until here. Did you get the logic, everybody? Okay, let me tell you where autoencoders were used. Guys, have you seen the constellation image captured by the Hubble telescope like 5-6 years ago? You remember they captured the edge of the universe? If you guys know, right? So there's a telescope, okay? They were able to capture the edge of the universe. Now tell me one thing, if you are capturing universe, what will be the size of the image? It will be large. It will be very, very large. They need compression on it, right? They used a compression strategy that could make a human observe that image really, really well. So compression becomes like a very important criteria in technologies, right? It's like super critical. So just like that, autoencoders are also taking the original input, but this time you compress it a little, you compress it a little, compress it even extreme, then decompress, and get back the original image. But remember one thing, please remember, whatever compression you have used, that is the exact same decompression you have to use. If you used two compression and only one decompression, your autoencoder will not work. Whatever your encoder is, the mirror image should be your decoder. Understanding? You cannot take multiple different layers in encoding and decoding. Guys, it's done. Autoencoders will lose their peace of mind and they will not be able to perform the way they are supposed to perform. Got it? Autoencoders can compress literally anything: audio data, video data, image data, and text data. Any data on the planet can be done. Can we use different rate of compression in different layers? No, you can't. Different rate of compression is actually not handled by us. It's handled by the neural network directly. So we cannot control the rate of compression. We can control the dimension of compression, meaning the size of compression technique that we use could be done differently. But I'm not sure if rate of compression can be handled. Okay. Autoencoder works very simply. So when you had an input layer and the layer looks something like this, right? So let me go ahead and explain it to you like this. You had an input layer that looks something like this. I have my input layer, which is this, and then I want to compress it further. So then you compress it until this much. This is the compression that you have followed. This is the compression that you want to do. Then again, you go ahead and you do other compression, which is a much smaller compression. Then you do the final smallest compression that you wanted to compress the information. You don't directly compress the data to an extreme level of compression. You don't do that. That's not a great thing. You then decompress it back because you need to build like a mirror image. Your input and your output should always be equal. This is like one of the most basic things that you need to follow while building autoencoders. Everybody knows this. And then I build like the second layer, which is like the mirror image. And then finally the input will match with the output, right? So what did you do? You had the encoder layer, which is basically going to be like this layer. And then you have like a decoder layer, which is this layer. And finally, you're going to be calling this as your bottleneck. The reason I'm calling this as the bottleneck, because finally speaking, at the end of the day, your final input was compressed into this size. So always you will end up calling this as like your final bottleneck layer. But what happens is basically you went from the input to a low level of compression, to a further low level of compression, to the lowest level of compression, then decompression back, again a decompression, and then the final decompression, and you will get the output. So the input and output flows very, very simply. Now guys, remember one thing. This is also something that you guys should understand, that the math behind autoencoders is not very straightforward. Actually takes its inspiration from the initial paper of multi-layer perceptron, plus there are multiple other concepts like KL divergence. There's also something called reconstruction loss, reconstruction parameterization, which is like another concept in deep learning which is highly researched. So autoencoders became famous and are still famous due to a lot of amazing technique that they follow. What of the other things that they are capable of doing? But remember, it's the concept that makes more sense, and that's exactly what we are going to be following. Okay, this is exactly what we are going to be doing in our class. Now guys, to give you guys an idea about autoencoders, let's actually deconstruct or compress a data and then recompress it, or basically get like the original image back. So there is a compression and decompression process that we are going to do. I am not interested in the technology as much, but I'm interested in the way it functions, because there are two kind of data scientists on this planet, or there are two kind of people on this planet. One who build things, other who apply things. I'm going to give an example. There is somebody on this planet who came up with the idea of how to manufacture a cement, or how do I manufacture a pen, or how do I manufacture an ink. And then there are other people who know how to apply cement, or how to take a cement, make it even more stronger, and build houses, offices, parking lots, safe houses, bunkers, whatever, XYZ things. So there are two kind of people. One who will come up with the idea, second who know how to apply the idea. Personally, I feel that people who know how to apply things are more practical because they are able to take somebody's creativity to another level. Now, what do I mean by that is, I've taught you the concept of convolutional neural networks, recurrent neural networks, long short-term memory models. We've spoken about like feed-forward network from the very beginning, right? The most important thing that you need to understand is you guys have learned all this technique. Now, of course, I am not claiming the fact that you suddenly should know how to apply this technology. You suddenly somehow should know how to work on, I don't know, a very complicated data set, but these are like building blocks. I'm very sure you guys have worked on Lego, right? You can literally build anything with a Lego set, right? So think of all the concepts that you're learning right now as like the foundational logic for you to build something in your professional career or something to build in the future. So the intention in this class is not to understand how exactly an autoencoder works, but I'm also going to give you an idea on look at the way it is actually applied. That's more the intention that I have for you guys to look at, then look at the code, because programming anybody can do. It's the logic that makes more sense. So hands-on part will be covered like that. Like I wanna take you guys through it like that. Okay. So anyways, I'm glad you guys are able to understand what I'm saying. Okay. Let me go ahead and connect my Google Colab notebook and let's see how the whole output is gonna look like. Okay, I think it's connected. I don't need a T4 because I think it is a GPU. I will change the runtime to 8 TPU. Yeah, we might not need, or maybe we can continue with T4. It's okay. All right. So guys, let's try to understand about autoencoders. Like I said, you do not have to worry about anything when it comes to programming because everything else is taken care by the library TensorFlow and we don't have to worry about it. Anyways, let's say you start any machine learning or deep learning use case with starting with the thing called import numpy as NP. So import numpy as NP. This is like the most basic thing. Again, import matplotlib.pyplot as PLT, right? So these are the two simple libraries. Oh, also, let me make your life a little bit more easy. We worked on such a fascinating data set called MNIST dataset. We are going to load exactly that. So from TensorFlow, dot keras dot datasets import MNIST. Okay. I am also going to say from TensorFlow because I need it in the future. So from TensorFlow dot keras dot models, I'm going to import something called as a model because I need to work on it. And what do I need? I need an input layer, a dense layer, and okay, so wait. Okay, let's figure it out together, right? Let's figure it out eventually. How do we want to work on it? I know we will need layers for now, no problem. But for now, data pre-processing. Data pre-processing. Okay. I have a simple question and I want you to look at it and try to tell me if this makes sense or not. When we loaded our model, do you remember we loaded the model like this, x train comma x label, and we had something called y train and y label, sorry, x train and x test. Do you remember we loaded the data set slightly differently like this, and then there was like images label, images data, training data, and then training labels. We had split the data like this, training images, training labels, testing images, testing label, while we worked with something called CNN. Do you remember? You remember that if I want to work on something called autoencoder, do I even care about the label? Like, am I concerned about label as much? Am I trying to do some kind of a supervised learning phenomena here? Absolutely not. I have no interest in the label. I just want to load the data and then my output will be the original input or the image that I'm passing. Whatever I am passing, which is the original image, my output will be exactly that. Making sense? So can I say MNIST dot load data? This is like the simple thing. Xtrain comma underscore. By the way, guys, I hope you know this or not. But did you know that Python allows underscore to be like this variable name which can be ignored? Like if you want to ignore anything, just put underscore in front of it, Python will ignore it. Getting what I'm trying to say? So see, whenever you have this underscore, basically you're telling Python that, hey, you know what? I just want to ignore you, right? You just wanna, I don't want to work on that. I want to ignore you. I don't want to consider you as an important aspect. I don't want to work with you. I don't want to include you in any of my calculations later. So that is why you get the naming convention called underscore. Are we clear? Now, I want to visualize the data. Since I don't want to work on this data size, which is larger, I want to visualize this. You already know this for a fact, but still, I'm just going to plot it. So let's say plot.figure, and inside this, I'm going to say figure size is equal to, let's take a figure size of 20 comma 4. Let's take a simple figure size. So for I in range of n, because that is the amount of numbers of data you want to display, let's say axis is equal to plot dot subplot, and I go all the way from 1 to n to I plus 1, all the way till that particular value, plot dot im show. So plot dot im show, image show, and inside the image show part, I will take the xtrain value. Now, let me also think about it. So for every ith iteration, right, I will reshape the value to 28 cross 28 because the original MNIST dataset sizes are 28 cross 28, right? And of course, I want to plot this in a grayscale image. Then after that is plotted in a grayscale image, ax dot get axis, let's say get underscore x, is it get underscore x axis? I'm assuming, okay, yeah, get x axis is dot, let's say set visible, set underscore visible is equal to false. So if I do this, the same will happen with y axis. So for that particular subplot, no x, no y, set visible is false again, and plot dot subtitle, and what am I saying, is going to be added as sample loaded MNIST data, handwritten data, and plot dot tight layout, and I am going to say plot. No, I don't need grid, right? I don't want grid actually. If would want to work on it, maybe I don't know. Let's take a larger size, I guess. Okay, fine. Okay, all right. So, I don't know. I mean, this is just a simple visualization of the data that we've loaded. Of course, you guys know that in Jupyter Notebook, you have this beautiful feature that if you say xtrain model of 0, so do you see that if I load the data set, which is the first value, can you see the number 5, like a very small number 5 that's opening up on Jupyter Notebook? If you click on show data, it will show you the entire array. You're understanding, guys? Like it will also give you the idea. So see, hide data. So if I say xtrain of 4, so can you see the label is 9 or the image is 9 of 345. See, it's 1, 3454. It's number 6. I hope you're understanding. 3454th value is actually a number called number 6. So you can also visualize the data like that, but I personally think that Pythonic way is better because you are able to visualize, say if I want to plot like 20 data together, I want to see all the 20 values together. So see, I'm able to like print all the 20 values and make sense out of it. So I'm able to print everything and it's kind of giving me the entire idea. So anyways, guys, like this code here is just to visualize the data I want to see. I'm going to, of course, keep it n is equal to, like, I think we should keep it at 9. So just these are the data sets that I'm loading and I'm kind of getting the idea what the data looks like. I've just simply converted them into an array or an array format into a 28 cross 28 pixel format, and I'm simply loading the data. That's pretty much what I'm doing here. Nothing complicated here. But while teaching you CNN, do you remember that in CNN, I taught you the concept called normalization of the pixels? Do you remember that because the pixels are ranging from 0 to 255, what happens to your program? What is the shape of this data 28 cross 28? So I hope everybody knows that MNIST dataset will be able to have a 28 cross 28 size image. Okay, you know what? Let me just plot it for you. Give me 1 second. MNIST dataset images. So let me open up. Okay, yeah, and copy this. Look, the MNIST dataset, the original MNIST dataset, when you download, the pixel size you get is maximum 28 by 28. Are you understanding? All I'm doing is I'm taking the array format and I'm converting that into a 28 cross 28 pixel. I'm just telling Python that can you please, while you're printing, consider that as like a 28 cross 28 pixel image so that you are able to plot everything from 0 to 28, and 0 to 28 I'm able to look at the image at as a whole. It's simply telling the image to just plot it down in a simple 28 cross 28 pixel dimension. Like what that's pretty much what I'm trying to do. I'm not changing anything as per like as such. Like the maximum that I'm doing is I'm just telling the code that hey, all I want you to do is just convert this array that I'm giving you, which is this data set that you've loaded from some particular file, some particular server. I want you to consider that array, which is the image array, which is of course how every image in the planet is saved, and I want you to convert that in like a possible value. Right? That's pretty much all I'm trying to do. So in Python, specifically in Matplotlib, you remember we had something called plot.tick. So you have something called plot.axis and we say something called off in Python. This is simply a variable called n and the value of that variable is 9. Okay, that's great. Plot.figure, figure size equals to 20,4. Am I sizing the canvas? I'm basically telling how the plot's dimensions will look like. This is not a very in Matplotlib, this is called sizing the canvas. Basically, you're telling the machine, the computer that how long do you want the canvas? 20 means it's 20 inches tall, the dimension. So width is going to be 20 inches. It's considered pixel multiplied by 100 and then it will be 4 inches in size in the length. 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 So 20-inch is the width of the data and 4 inches would be the length of the data. The number is multiplied. So 20 is multiplied with 100 in the pixel calculation and that pixel becomes like the 20-inch width. Okay, just a little something to show you guys because I don't want to code and program and then waste a lot of time. But okay, so let's say 5,5. Do you see this graph, this bar graph that I'm teaching you? Okay. If I change 5,5, what happens to my entire image? Did it become a square image? Yeah, it became a square image. I changed my 5 to 10. What is it that you changed? The width or the height? I changed my width, not my height. Okay, what if I make it 5 and I make this 10? What did you change? Did you change the length? Not the width, because width remains the same, but the length has changed. You're understanding? So if I say 20,5, you want an image to be highly widthy, or I'm not sure if widthy is any word, but you want the width to be larger and you want the length to be shorter. And every single time you want the image to have a specific size and dimension, you can call it using the plot.figure, figure size is equal to this. So I am going to write down a loop or for I in the range of n. So basically what am I doing? I'm going to run and loop my code for all the 9 iterations. Okay. I am going to run the loop for 9 iteration and plot.subplot 1 comma n comma I plus 1. Guys, I mean, this has to be the most simplistic definition, but I'll still explain. Am I creating a subplot which will be of nothing but size 1 cross 10, 1 row 10 column? And every single time I run from the position, so tell me in Python, doesn't index position start with 0? Like everything starts with 0? So I will be taking from 0 plus 1th position, right? Like I want to run from 0 plus 1th position because my indexing starts at that. Meaning this 5, this 0, this 4, this 1, this 9, then 2. So what I'm doing is select the ith position in the subplot function. It will take 3 arguments, guys. Okay, so let me make your life easy. Subplot will tell you what rows do you want, what columns do you want, and what is the index of the subplot that you want, okay, which is the current subplot that you have. So 5, 0, 4, 1, 9. I am simply passing the same value, but because the ith operation will always start at 0, I am simply giving it the 1, 2, 3, 4, 5. Because there are 9 plots, it starts at 0. I'm just saying 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plots. Okay. Tell me one thing. Plot.imshow. In your career, if you ever want to show or open up an image in Matplotlib, the image show feature is the IMShow feature. And inside that, am I not tracking every single iteration for I is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8. And I'm reshaping it as a 28 cross 28 pixel value, right? Here I'm simply reshaping my image as this 28 cross 28 pixel image. And what do you mean by plot.gray or plot.cmap equals to gray? It will convert my image. The way I will see that image will be a grayscale image, correct? I will be able to see the image as a grayscale, yes or no? Okay. Sir, what is this x.get x-axis dot set visible false x y-axis? Do you see any x-axis information and y-axis information? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4. Basically, if I do not want any x ticks or x ticks, ticks ticks, or if I do not want any y ticks, so what I need to do, I can do something called take the y-axis and set it visible equals to false. So there will be no x tick and y tick. Got it? What do you mean by x tick and y tick is basically, so let me show you a graph, right? Image or matplotlib, right? Matplotlib graph. Are you able to see the 0, 0 0.25, 0 0.50, 0 0.75, 1, 1.25, 1.50, and then 2, 1.75? So some number voltage and some number time together. I don't want any ticks. I'm setting them possible. So any X ticks that you have in the image will be loaded. Got it? And after that, I'm simply just telling my code that can you put up like this big title called sample loaded MNIST data, not on each individual image, but on the overall data set size. So can you see here, guys? Here, can you see sample loaded MNIST data on the entire image? I just wanted it to load like this one super title. So that's why it's called subtitle. It's called super title. Got it? Is the tight layout because I wanted equal spaces between the code. Even if I don't mention it now, the code will run the same way. It's just that the sample differences between them will be higher. Look at the difference, okay? In the tight layout part, the differences between each images is shorter because it's trying to sort of accommodate for everything. But yeah, you get the idea, okay? Why you use ax instead of plot? Tell me one thing. Have I not taken plot.subplot directly here? Now in Matplotlib, if you want to relate with something like a plot, do you pass it like this? Like for example, I'm going to explain it to you. Give me 1 second. Give me 1 second. I'll explain it to you. Okay. Do you see the plot of this? Like, okay, look at the output first. Can you see two output, monthly revenue and monthly expenses in this plot? Okay. Tell me this. Do you see AX1, 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 and then there is something called AX2, AX2, AX2. Okay, just for simplicity reason, if I convert this AX2 as AX1, okay, look at this. AX1, 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 AX1. Am I plotting both the plots in one single graph? Yeah. Do you see that everything is now plotted to one graph? Okay, now let me convert it to AX2, 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 and AX2. Do you see the output? The way the monthly revenue and the monthly plot.tight layout, right? Let me make this happen. Yeah, okay. So see, what I'm basically saying is in Matplotlib, you can give each individual graph a name, meaning whatever plot you're doing, you can determine what should happen to that plot. So graph number 1, monthly revenue graph, is named AX1 and the graph number 2 is named AX2. What I simply did in my Python code is I have taken a variable called AX. So I have named the entire graph that you see in front of you by the name AX1, okay, or AX, axis it's called as. And I said AX.getAxis ax dot get y axis. So basically whatever I want to do with that, I'm just trying to give that label, that graph a name, and that's simply whatever you want to do with that graph. Remove x-axis, x ticks, remove y-axis, y ticks, change orientation, rotate the image, whatever you want to do, you now will be doing with the name called ax. So that is the simple sort of like the idea behind it. If you want to mess with any data scientist in the future, import numpy as PD and import pandas as NP. Just write this. It will cause a huge explosion on the server. Of course, you need to come out of that office. What you did, you have imported numpy as PD and you've imported panda as NP. And wherever you work, if you want to make sure that the company goes through total annihilation, you can just write this in the production code and just wait for the world to go haywire. But then I believe it takes another kind of evil to do this, right? Definitely. So don't do it. Like I say, don't do it. It takes another kind of evil to do this. But the point I'm trying to make is that yeah, I mean, there are so many different ways things can be done, and this is just one of the ways that we are doing it. See, if I write down a function called define, sm is equal to, I will take down something called name. Okay, I will say return, I will say hey hey bracket name. Okay, so I will say sm of Rudra, Rudra, Rudra. So I will get the answer, hey Rudra. Did you need to print like this? Did you need to take my function name like this, a is equal to sm, and inside this I had to take something called Rudra, 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 and then I had to print a. If you do, this is the right way of Python way of doing it, correct? This is the actual Python way of handling with a function. But in Jupyter Notebook, do you need it? No. In Jupyter Notebook, sir, if I want to show any image, plot.show, even if I write it or I don't write it, it does not matter. It will anyways show the image. So plot.show is a method in matplotlib, and what it does is, if once you are done with the way you want the graph to look like, you have to mention plot.show. So if you are ever working on Visual Studio Code or any other IDE, you need to mention plot.show. Now plot.imshow full form is image show. If you ever want to see an image, suppose you have your own image, you want to see your image. In Python, we have a method called imshow, which is an image show method that will show me the image and it will convert the image in a graph and it will show it to you, correct? That's pretty much how the whole process works. It's just going to give you an image, it's going to give you the output, and you will be able to see that very, very clearly. Got it? That's how simple it is. So now that you got the idea for the entire logic for sort of implementing just looking at visualizing the data set that we were just able to load. Now, if I could just go back to the topic once again, kind of critical for us to discuss this, but yeah, if you remember that the number between or inside any image is always between 0 to 255, okay? Can we do this in Seaborn as well? You can also do this in Seaborn, but I prefer, rather than doing it in Seaborn, you actually use bokeh. So let me explain why. In Python, we have another package called bokeh. Now, why bokeh? So nowadays, it's become very critical for any graph to be highly interactive. When I say interactive, I want it to look like, so you want your graphs to give you some ideas, so to give you some interactiveness in your chat, interactive in your graph, not chat. I'm so sorry, I'm not in the right state of mind. So you need to interact with your graph, right? You need to interact with the way the graph works, and because you need to interact with the graphs, you want your graphs to be capable of much more than simply just plotting anything, right? So let me see if I can just, so if I just run this, okay, have a look at the graph, right? So now if you look at it, I'm able to get some kind of an idea with respect to interactiveness within the graph. So if I can see that every time I take the graph someplace, I'm able to get like this idea in the sheet, right? So if I want to make like a standard dashboard, some kind of a graph binders, or if you want to do like thousand other things, you have like bokeh as a much better interactive chat. Now, why do we need that interaction, and why is this so important in this graph? Is because if you observe carefully, I literally had to write down the entire loop in Python for me to tell Python program that, hey, you are going to be running for the iteration for all the way till n here. You are going to be plotting the subplot values like this. You don't need to put so much effort in Seaborn or Bokeh. You just need to come back and just write it directly. So your job is pretty much done. Got what I'm trying to say? So you will be able to just plot the data directly with lesser piece of code, and your job is also going to be easy. Plus the graph is going to be interactive. I don't have to put up the title for label. The label will automatically pop up. So you can do this in Seaborn. You can do this in Bokeh. You can do this in Matplotlib. Matplotlib is the most simplistic kind of Python package that can make you, that can, yeah, it's more easy to operate. It's more easy to work on. Very simple. Okay. Yeah. Okay. All right. So now, if you remember that every single image on this planet is either built on channel. If you remember, when I taught you convolutional neural networks, I taught you that any image, if it's a colorful image, every single selfie that you click, every single photo that you share with each other is actually an image that is built with RGB channels, right? So basically you have a red, green and a blue channel, right? In our case, we only have a mono channel, which is a single channel image, and the number will be between 0 to 255. But the problem is, in machine learning or in deep learning, we know for a fact that images cannot work if the ranges is different. So I'm sure you guys have learned this, but I'm just going to reiterate it once again because I want all of you to be on the same page. If you have a variable called age, if you have another variable called salary, and if you have another variable called years of experience, right? Years of experience. And then you're trying to predict whether somebody deserves loan or not. So suppose your age is 23, 29, 30. Yeah. Salary is 25,000, right? 1 lakh, right? You have 1,50,000, and years of experience is 3 years, 5 years, and 7 years. Example. Loan is no, yes, and yes. Now tell me one thing. Age. Isn't age a number between, I don't know, 18 years old to 70 years old? Like it's a number between 18 to 70, correct? It is. What about salary? Salary is a number that maybe starts with maybe, I don't know, 18,000 rupees, go all the way till 1 crore, maybe. I don't know. Years of experience could be either 0 years of experience, or it could be 40 years of experience. So do you see that machine or your machine learning code is now able to, or is about to handle data where the ranges are so different? One range is 18 to 70, other range is 18,000 to 1 crore, other range is 0 to 40. Computers and machine learning codes don't like this. Your machine learning algorithms don't like this. It doesn't work like that. Okay. So age is slightly different, salary is slightly different, and years of experience is slightly different. So if I want to bring everything down to a number between 0 to 1, can I say x train is equal to x underscore train dot as type? I am converting my data type into a float 32. If you remember this, why did I do this conversion called float 32 and divide the whole thing divided by 255? Because if I look at my code, which is x train of 0, look at the way the output looks like. Are the numbers between 0 to 255, 43, 154, 139, 253, 11, 35, 225, 253, 186, 253, 93, 252, and on and on and on. If I convert this x train equals to x train dot as type, let me also copy this and paste this, x test, test, x test would be x test, test dot as type float 32 of 255. If I run this code and if I now print x train of 0, what answer do I get? Do I see every single number is reduced between a number between 0 to 1? Correct? We know this for a fact. And without this, your machine learning program is not going to work at its peak efficiency, at its maximum efficiency. In order to make your computer understand and not let it overthink on so many things, we have to apply normalization. Otherwise, your machine learning code is going to go haywire. It's going to go all over the place. It's not going to remain sane. That is one of the reasons why we've maintained the normalization very, very simply. Now, I want to teach you guys how do you write an encoder, or basically how do you write down an autoencoder. First of all, encoding, so encoding underscore dim, and coding dimension is equal to 32. Okay, just for clarity, 0 means completely dark and 255 means completely white. Okay, that's correct. If you are ever confused about it, just write down hex code on your computer, go on this particular thing, and if you can just go to the complete white space. So do you see that it's completely 255, 255, 255? And now if you want to go back to like the completely dark value, it will be 0, 0, 0. So you go from 0, which is dark, to 255, which is light. So pretty much how you want to do things in life as well. You want to go from darkness to lightness. You want to go from being in a dark situation to a very light, very happy situation in life. So you want to go from 0 to 255 in life. 255 is, let me just say that, or related with like a speed. You want to not stay still but have like some momentum in your life. So 0 means dark, 255 means light. Okay, think of it like that. Stupid analogy, I know, but try to relate with it. Okay, so encoding is equal to 32, right? This is the layer size, or this is my bottleneck layer size. Bottleneck layer size. Please tell me, for simplicity reason, what is the size of the bottleneck that I have done? What is this compression layer or compressed layer size? Layer size. What will be the size of my bottleneck layer, everybody? Is it going to be 32? Did I take my encoding dimension to be 32? Why 32? Haven't I taught you that things go like this: 8, 16, 32, 64, 128, and goes on and on and on. And in machine learning and in data science, we kind of repeat this again and again. And there is no specific reason of me repeating something called 32 again and again, but this is just how machine learning and neural network codes work. Yeah, देखो, see, the thing is, let me tell you one thing. You don't push something to so much extreme level that there is no going back. You have an image of size 28 cross 28. You are doing such an extreme compression of 6 and 7. How are you going to retain the losses back? There will be a lot of losses in the initial stages, and your code is not going to be able to work the fine. I mean, it's not going to be able to work back to reconstruct the loss. It's not going to happen. So don't do extreme compression in the beginning, because it makes so much logical sense also, right? The bottleneck size layer is actually very, very simple. My encoding dimension is actually kind of smaller, which is 32. I'm not doing extreme compression. That's not what I want to do. I keep the compression layer very, very small. I want to have like small incremental decompressions and compressions. But for now, since we are not aiming at something complicated, my compression is going to have very, very simple. So now what do we do is, after you create this, I'm always going to go back and actually change the way I'm actually importing my model. So see here, I'm not going to import any sequential model like how I usually do. I'm not going to have any kind of sequential modeling here. What I'm going to do here, at the way I've imported this particular thing, I'm going to import 4 very simple things. Okay, 4 very simple things. From TensorFlow, I'm going to import something called Keras. And from the Keras, I'm going to be importing something called layers. I'm going to import 4 very simple things. Number 1 is the input. If you remember, while teaching you the feed forward network for the first time, I taught you what this input does. Then I'm going to import something called dense, because I need it. I want the connections to be fully connected. Then I'm going to call something called flatten. This is for a flat layer, and I'm going to call something called reshape. Now this is like the internal library, the internal module in TensorFlow. Long short-term memory models are sequential models, but then I can convert long short-term memory model into a parallelized approach using something called transformers. So I believe your autoencoders, because they are just like a normal neural network, what you can do with it is you can have the data sent, or you can have a data passed on in that autoencoder, one actually parallelly, not one by one, because your neural networks, forward propagation and backward propagation, they both together happen at the same time. So you kind of have to keep up with making sure your neural network, be it autoencoder, feed forward network, is able to consume the data, change the weight values, is able to learn from the representation. So let me tell you like the most simplistic thing to understand this. See, any neural network on this planet, I don't care who it is, the godfather of AI himself, or I don't know, God himself, if he comes on the planet and tries to tell you that no, it doesn't work like that, let me tell you something. In neural networks, in any neural network on this planet, Siamese network, UNet, CapsuleNet, CNN, RNN, Mask RCNN, Shiny, Transformers, RNets, BERT, Robetta, Elmo, Dino, right? I don't know how many other can I name. I can go on. Any neural network on this planet, pre-trained, trained, does not matter. The learning, learning, learning. Majority of the neural networks are always sequential learners. Every other learner is a sequential learner. Couple of algorithms like transformers, right? I'm not gonna say GANs for sure, but there is also something called UGAN. You know what? Just consider transformer is just one of the things that is parallel in nature to consume things. So rather than calling them sequential and non-sequential, just follow more on the architecture, focus more on the architecture. So what I'm basically trying to say is there are people on this planet who love Maserati more than they love Porsche, or they love Land Rover more than they love BMW, or they love, I don't know, Ferrari over they love Lamborghini. Every single car has its own way of build, function, modularity, BHP, the way it is built, right? Some kind of a design philosophy that it goes on. Neural networks are no different. What you like, what you want to build it on, that's more critical. How it is built, that's more critical. Sequential and non-sequential makes sense, but there is no distinction or like a very specific criteria that will make the model that would make me want to say that, hey, I am learning LSTM, it's a sequential model. No, I would rather speak like this. I am learning LSTM. It's a technique in textual analytics and time series analytics that is going to handle a data set size of any dimension or any size, right? So, but yeah, I mean, your question isn't actually inaccurate, but I'm just saying that that's not the discussion point for data scientists or machine learning engineers to talk about. But yeah, there are sequential and non-sequential learners. You can definitely think of it like that. No doubt about that. Okay, no doubt about that. Okay. Anyways, so if you remember, I have taken like the encoding dimension is equal to 32, correct? This is like me deciding what my bottleneck layer is going to look like, or what my bottleneck size will look like. Now input underscore image. Now let me ask you guys a simple question. Every MNIST data image is a 28 cross 28 pixel image. What is 28 cross 28 multiplied together? 784. Yeah. Now in 784, if I say input underscore img, input input underscore img, input image is equal to input. And in this input, I'm going to pass in the shape is equal to 784. What am I doing here? What's the logic behind this? What's the input image? Input image is input of shape 784. What does this mean? My input will have a size of 784 values, correct or not? What is the neuron size at the input? 784 nodes are going to be kept or used at my input size. Are we clear? 784 are the size of my input layer. Now tell me, once you have set your input variable or your input image, now you need to write both the encoder and decoder. So encoder, which is encoder, encoder layer, which is going to be this, is encode the input variable or the input input to a smaller dimension, okay. what I'm going to be doing is why this choice of 784 input neurons. So 28 cross 28 is the pixel size that is given to me by my MNIST dataset. So all I have to do, Moses, is just multiply 28 by 28. I'll give an example. I'll give you a very simple example. Okay. So what's the iPhone resolution? What's the image resolution of an iPhone camera? I don't know. I'm just going to check it. 12 megapixel, right? So this would be, let's say, 4032 times 3024. Okay. An iPhone camera is able to take these many pixels. So if I ever wanted to create an encoding value for, I don't know, my, say an example, oh, I'm sorry, why am I doing cross, right? Yeah. If I ever want to work on an encoded value on, say, an image of an iPhone that it generates, tell me the input number size of the neurons. If I multiply them together, the how many total values there exist? 1, 2, 1 lakh 21, it's not even 1 lakh, it's more. So 1 crore 21 lakh, no, it's actually 12 crores, 19 lakh 2,768. Is that right? 12. So what? Ones, thousands, 100, 10,000, ones, tens, hundreds, thousand, 10,000, lakh, 10 lakh crore. So this is 1 crore. 1 crore 21 lakh 92,768, right? This is the size of your input variable or feature. We only have 28 cross 28, so my input neuron size is kept at 784. Okay, now encoder is going to be encoded, encoded. Encoded is equal to dense representation of encoding dimension. So I'm going to be passing something called encoding dimension. Activation equals to ReLU. And I am going to pass whatever input image I have passed, I'm going to be passing it like this. Until here, are we clear? This is the way my encoder works. How does my decoder work? So my decoded value is going to be dense equals to 784. I want my output back. In what level, on what layer I want it back? I want it again 784 back again, because my input and my output should match, correct? Agree, disagree? My input and my output is going to match. Now, if I say activation is equal to, let's say, sigmoid, what does it mean if I say that my activation is equal to sigmoid and I pass it encoded? So encoded here. What am I doing here, everyone? Just let me just cut and paste it here. So this is my encoder, this is my decoder. Okay, so let me remove this. What am I doing here? Because sigmoid is also another function in Python that gives me numbers between 0 to 1, right? And I have anyways normalized my image values between 0 and 1. So isn't sigmoid going to help me calculate exactly that? I'm just passing my encoded value as it is. So tell me one thing, what have I done here? So if I want to say autoencoder is equal to model, inside this I am taking the input image, which is going to be input input underscore image, comma decoded. Together, all the way from input image together, all the way till decoded. Together, can I call the entire operation my autoencoder? All the way from taking an input image all the way till decodation, or the decode, I don't know, oh my god. Yeah, decoder is going to be the same thing. So autoencoder dot compile. Do I compile? And inside the compile, what do I do? Optimizer, optimizer. I'm not sure. My spellings are terrible. Optimizer is equal to Adam. I hope this is correct. Yeah. Optimizer equals to Adam, and loss equals to, because I'm using sigmoid towards the end, can I say binary cross entropy? Can I say binary cross entropy? I've done something called model.compile. Once the model.compile is done, do I run the autoencoder.fit? Tell me one thing. Why did I need input equals to input and output equals to output in feed forward network? Was there a specific reason behind it? What was the reason behind it? So the reason behind it was, when I wrote input equals to input and output equals to output, because at the time of my output, I had only one layer represented or one output represented, and I had dense connections between all. In my encoder decoder model, it's very simple. I took in the input image. I haven't done much. I took the encoder value. I have taken the encoded representation. I took the decoded representation. If I still want to take input equals to input and output equal to decode, you can do that. We can include it as a part of the representation, but we don't really need to write it. We can write it like the harm isn't there. It's not like I'm going to get an error of any kind. I'm not going to get it. Okay. I'm not going to get any error. Also, not a good practice. You can do it. But yeah, I mean, you can mention it. But for me, just combining everything into one particular variable like autoencoder and model is a portion or a way of handling things and combining things together. So all I'm basically doing here is just taking all the way from my input image, all the way from process of decoded image, and I'm taking that as a piece of one piece of individual code. So I might not need to write that again, but writing that is also not going to be any problem. I hope you are clear. Okay. Yeah, that's not going to be any problem. But tell me one thing. When I encoded the image to a 32 dimension image, I have normalized everything, correct? Everybody, I have normalized everything, correct? After normalization, my question to you all is, do you think you should also do something called flatten? Flatten meaning, I want to convert my two-dimensional array into one-dimensional array, correct? So for example, if my image looks like this, 1, 2, 3, 4, 5, 6, should it become 1, 2, 3, 4, 5, 6? So how do we flatten everybody? So my x train value will be what? X underscore train. So of course, x train dot. Can I say reshape? Can I say reshape? And inside the reshape, x underscore train dot shape. For each individual value, which is the x train value, I want to shape it as a 28 cross 28 pixel. What does it mean? What is 28 cross 28 multiplied by means in Python? Like the multiplication in Python's head would be? Is it going to be 784? And if I take in the same exact x train value and pass it to x test value, what will happen? The x test value here will be reshaped to x test here, PEST, dot reshape of 28 cross 28. What is happening here, guys? Am I basically flattening everything? Look, I'm going to run this and I'm going to show it to you. Wait. X underscore train of 0. Please tell me what dimension image is this? Isn't it one dimension? Look at it. Look at it. Dot ndim. Ndim. Look at this. What did I do here? Look at the size. It's going to be 1. Can you see? The dimension is 1. Row is going to be the first row, only one row. 784 columns can be found, or values are found, not just, don't say columns, but values. I have flattened my value and that 784 I'm passing inside this particular thing. Now, sir, what do you mean by model? In TensorFlow, if you want to write your own layer and you want to club them, combine them together as one, model will act like a glue. Model will act like a glue. It will combine your input image, encoded, decoded together as one piece of code. And can you see here in the model, I have not included anything called encoded. There is no mention of the word encoded. I have only mentioned something called decoded here. But guys, encoder, input and decoder isn't input connected to encoded with input image and encoded connected to decoded with this encoded. So do I even need to mention encoded anymore? Are you understanding? I just pass input image and I pass decoded. The connection is automatically going to be established. Got it? So now tell me, but you used ReLU here for encoding, just little bit. Okay. For every single hidden layer that you had, have you not always used ReLU? So if my encoder or my encoded or my decoded representation is ReLU, what's the harm? There will be just no representation of negative values. In my normalization, do I have negative values or I have always 0 and 1? Why? ReLU positive function? Yes, because ReLU is a positive function. It will always give you answer between 0 to positive infinity. Okay? So tell me one thing. Until here, if I train my model like this, autoencoder dot fit. What will I pass inside the autoencoder? Can I say X train everybody? Comma. What will I pass? Okay, now this is beautiful. You guys are going to love this. Guys, I am going to write down something so weird, it will blow your brains off, but it's important. I'm gonna pass in xtrain comma xtrain. Epochs is equal to, just give me 1 second, okay? Epochs equals to, let's say 50. I don't want to take an epoch size more than 50. Batch size is going to be 32. But you know what? Let me take a batch size of 256. Shuffle equals to true. I will shuffle the data. Of course, I want to shuffle it. And what else do we take? Validation underscore data would be, okay, so V has to be small, not capital V. Validation data would be equal to X test, comma X test. Okay, how are you? Okay, before I even run this particular model, why have I passed X train, comma X train back again and Y train, comma Y train back? What is the logic behind specifically taking multiple X test and X test? What is different in an autoencoder? In an autoencoder, what is different? The autoencoder has what? What does it do? Autoencoder's goal is to do what? What is the goal of an autoencoder? The goal of an autoencoder is to very effectively encode the information you pass in the input, correct? The aim of the autoencoder is not to compress. Let me repeat myself once again. I'm going to repeat myself 100 times if I have to. The goal of the autoencoder is not to encode or compress. Any child can do that. Any simple neural network can do that. How is autoencoder any different? How things are different in life? Autoencoder is different because it needs to learn how to efficiently construct the whole thing back also. It needs to reconstruct things also. So tell me, won't the model take the input image from the X train itself? Basically, the autoencoder is learning to copy it input to the output. It is able to take the input value and copy the same exact input to the output. So rather than passing X train and X test, am I then passing X train and X train? Because I want to copy my input directly back to output, because my input and my output will be the same thing, not same thing, but the same exact thing. Are you understanding? My target itself is the input. That's why I'm writing it 2 times. And I can also validate the result on the test set. Am I able to reconstruct it rightly? Am I able to do the good job? I hope you guys are clear now that why did I take X train twice and X test twice? Because I need to replicate my output. So if I run the model, autoencoder.fit, what's going to happen? Is my model going to start running? And remember, my batch size is like 256. So it's like considerably a smaller batch size. Don't say smaller. I'm saying if you increase the batch size, then the amount of represent inside it will be lesser, right? Anyways, it's going to run, okay? Essentially, the autoencoder is learning to copy its input to its output, but through a bottleneck layer that will force it to learn efficient representation of the input. This is going to be very different from your regular model where your input and outputs have like different inputs and target variables. So remember, the model will take the input image, which is the X-train value, compress it through the encoder to part it and pass it to a lower dimensional representation, reconstruct it through the decoder, and then compares the reconstruction back to the original X-train. Also one of the reasons why you are passing X-train again and again. I want to know, once my encoder or my autoencoder is trained, what am I more interested about? Encoded underscore IMGS images is equal to autoencoder dot predict. Guys, I want to predict what my autoencoder has learned on the test data. Is that right? Whatever my autoencoder has learned so far, it's able to grow so far, it's able to understand something so far. What do I want to do with it? I want my autoencoder to use that knowledge to tell me to construct the values back. So listen to me. N is equal to 10. Example. You know what? Why am I writing the whole thing once again? Give me 1 second. Give me a second. I'm going to copy the whole thing. Give me 1 second. Copy this and paste it here. Give me 1 second. Okay. Keras has its own callback, its own history that it maintains. It has an ID that it generates every single time. This 235 has nothing to do with 256. There is no relationship. You're understanding? There is no relationship. There is no relationship at all. This is just like an ID that the TensorFlow generates on its own. And look, when we did neural network training, did it generate 313, 313, 313, 313? Now, why did I give 313 here? Anywhere is there a 313 here? No, no. It keeps a history. It keeps a log. So it's something to do with that. Don't worry about it. Okay. So tell me this, guys. I want to plot my reconstructed image. My n is equal to 9. This is like the number of images I want to display. And I have this. Okay. First of all, I am going to show you the original image. The original image that was passed in the data. So I'm just going to take it slightly differently. I'm not going to keep the name Praveen as it is. I'm going to call it plot.subplots 2 comma n comma I plus 1. Okay. Plot.im show, instead of x train, I'm going to pass it x test of I, and I'm going to reshape it to 28,28. Plot.gray will be same, and Praveen will change to ax once again, and Praveen will change to ax once again. Dot x-axis set visible is equal to false. Now, just before you run the entire operation, this is going to give me the original display of the image. I don't just want to see the original image, I also want to see the reconstructed image of the same data. So if apart from original image, I also want to see the reconstructed image. Okay, I want to see the reconstructed image. So AX will be equal to plot.subplots, but now I'm going to go from 2 to n to I plus 1 plus n, because the same operation will repeat for plus nth index. Everything else will remain the same apart from plot.imShow. In the imShow, I am not going to pass something called x index. I'm going to pass something called encoded images, because I just calculated exactly that. I am going to reshape it to 28,28. I am of course going to say plot.gray. X.getAxis will also be set visible this, and I'm going to run the whole operation. Now tell me one thing. Let me make your life a little bit more easy by giving only 4 values. Do you see the input image and my reconstructed image a little blurry? So my original image and my reconstructed image. Do you see a slight difference in the image quality and resolution? Are you able to see that my reconstructed image back is not that clear, not that crisp, not that sharp? It is missing the important criteria like the 7's darkness, white color, the 2's sharpness in the bottom. It is missing it. Like if I zoom into it, see, the sharpness of the pixels of the 2 here is very distinct, but in the 2 here is very, very blurry. If I have this 1, my 1 is very distinct in the sharp features, but my 1 isn't that sharp towards the edge. Look at the way my 0 is sharp. I think the reconstruction of 0 is quite good, but the reconstruction of any other number, let's have a look at multiple other numbers, right? So yeah, have a look at this. Can you see the 9 was the worst kind of answer that we got? Look at this. See, this is my answer 9 and this is my reconstruction 9. Is my reconstruction terrible at 9? But it is giving me enough information to recognize the original digit, right? Yes or no? See, if you compare my original image and the constructed or reconstructed image, don't you think that at the end of the day, the reconstruction has done a good job? It's done a phenomenal job. Of course, at number 4, the sharpness is gone. At number 9 and number 5, the sharpness is gone. At number 6, the sharpness is gone. Definitely number 5, it's terrible. Definitely number 9 is gone bad. But there is one small thing everybody should observe in this class, in my session, and in this particular data, is that when we wrote the program for reconstruction, or when we got the whole reconstruction done, have you heard of the concept called pixelation? Okay, so let me explain. Okay, this is an important topic. You guys need to understand this. So how do I, okay, let's take this lady, or let's take somebody else. Actually, it's very distracting. Pixelated image. Give me 1 second. Yeah, let's take, yeah, I think we can take him for an example. Okay. Have a look at this particular idea. Okay. Have a look at this particular image. This is my original image, and this is my pixelated image, and pixelated image example. Okay. For example, all that happens in pixelation is the resolution decreases in the pixelation images, correct? What I'm about to tell you, I want you to listen to me carefully because whatever I am going to tell you is going to make a lot of sense. So listen to me. The original image and the pixelated image, whatever that pixelation is, I have essentially lost the information of the pixel, surrounding pixel. So for example, in an eye, for an eye to be good, like very clear eye, for an eye to look very, very clear, I need to have a pixel that looks like this, side by side, 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 side. So basically, you know what? Give me 1 second. Why am I explaining it like this? 1 3 6 9 2 1 3 2. If I run max pooling operation here with a small window size, 1 and 3 will become 3. 3 and actually 6 and 9 will become 9. 2 and 1 will become 2 and 3 and 2 will become 3. Tell me one thing. I taught you this in the concept of convolution neural network that if you apply something called as pooling, it will reduce the size of the image, correct? You had a 2 cross 4 image and you got a 2 cross 2 image, correct? But tell me one thing, from the original image dimension, is my pixelation decreasing any dimension size? Is it reducing the size of the image? No. What it is doing is, okay, if you have an image like this, expand on it. Let's say you have a pixel called 122. Whatever I'm about to tell you right now, I want you to listen to me carefully because if you understand this concept, you don't need anybody else in your life to explain convolutional neural network or image processing to you. So just hear me out, okay? When I say I have a pixelated image, in an unpixelated, non-pixelated image, the image will be very, very different in variance, okay? The image variance will be higher. Let me explain what I mean by that. Okay, my question is simple. If my image is 1392725861792136219 212111313413213122121. Between this image and between this image, which image has more variance of data in its neighborhood? Image number 1 or image number 2? Observe this image, this portion of the data and this portion of the data. Where do you see more variance? In image number 1 or image number 2? Are you now able to relate that for a clear image, there are distinct variances of values inside the image? The pixel values are different. When you call something pixelated, the values in the neighborhood are always something closer to each other. That is why the name, the size, the shape and the color looks all very, very same, correct? Between an unpixelated image and between a pixelated image, every single neighbor that I see to the left, to the top, to the bottom, to the left, the number is closer to the number that you're trying to look it up with. So what did you understand out of this? If I had my original number 13927251792 and 1, if I pixelate the image, am I losing lot of information? Agree, right, guys? Because 1392725 are becoming 21211313241321. There is a lot of loss of information. Look at my output here. Look at the output of 9, this number 9. What do you see? Do you see minor pixelation from the original values to the new values? Okay. Now that I've given you so much idea, what can you think in your brain what must be happening? Are you able to relate with some kind of logic? What must be happening? So far, I have only used like a one layer compression. Don't you think if I would have used multiple layer compression, my input and output would have been very close to each other? Like literally, you would have to put like an eye, like a keen observation to see, hey, it looks like, to me, it looks like the input and the output looks the same, but they are reconstructed. So if I use multiple different compressions in stages, it would have given me a much better output. But I just ended up using like extreme compression, direct compression, and I got this answered. Got what I'm trying to say? Okay.
Just a quick info, guys. Intellipaat offers artificial intelligence course training, which will enable you to learn skills like neural networks, focusing on CNNs, RNNs, and their application in AI, natural language processing, computer vision, and generative AI. Through this course, you will also master deep learning concepts, AI model building with TensorFlow, transformers, BERT, GPT, LangChain, and NLP pipelines with advanced techniques like image recognition, chatbot development, and much more, all taught by top 1% experts and IIT faculty. And with this course, we have already helped thousands of professionals make successful career transitions in AI and data science. You can check out the testimonials on our Achievers channel. The link is in the description below. And without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take your first step towards the dream career growth in the field of artificial intelligence.